Let's see how this works by starting with a simple data cleaning task. We'll open Copilot and paste the prompt into the chat box. As we can see, Copilot will take a few seconds to execute this command. Then we preview the results and have the option to apply it to our sheet. Next up, let's see how to accomplish a column split, another common data cleaning task. Split the customer column into first name and last name. Handle discrepancies with the word unknown. Here, we've also included instructions for how Copilot should approach cases that don't exactly fit our setup. Please suggest data cleaning tasks for this dataset. Is it ready for visualizations? Copilot can tell us which products sell the most, which customers are top buyers, and which regions have the highest sales. Please create a pivot table that shows total sales by region. Then insert a column chart to visualize the results. Please update any instances of South in the region column to South. Tell me how many instances there were. Then remake the graph. Let's make one more visualization that shows the breakdown by both region and product. Make a stacked column chart where each column is a region and each piece of the column is a product. Swap the region and product fields so that x-axis displays the 4 regions, and each stacked column represents the product-wise breakdown within those regions. Show a table listing each day of the week along with its total sales amount, so I can see which day had the highest sales overall. Using Python code. To determine which day of the week had the highest sales, the date column will be used to extract the weekday for each sale.
You begin this course by creating an Excel spreadsheet and importing data from various external sources. You then move on to visualizing data using Excel, going through some of the simple chart types such as column charts, specifically clustered column charts, and then moving to line charts. Along the way, you also learn how to add trend lines and how to customize the backgrounds of your Excel charts. In this video, we will begin our exploration of Excel. We will open up Excel and go through a very quick tour of all of the functionality contained within it before zeroing in on the Get Data functionality. We have a blank desktop before us and we begin by typing into the search bar in the bottom left. There, we just type the word Excel. The best match which appears is the Excel app. We click on that and Microsoft Excel opens up. This is the Excel welcome screen and we will be coming back to it at several points in subsequent demos. Over on the left, we have 3 menu items: Home, New, and Open. And then in the center pane, we have the ability to open different types of new workbooks. Let's start by clicking on the blank workbook option. This opens up an empty blank Excel workbook. Excel is a spreadsheet program, and a defining characteristic of spreadsheet programs is that they view the world as tables. You can see here that Excel consists of rows which have been labeled A, B, C, and so on, and then there are columns which are labeled starting from 1. This can be thought of as an essentially 2-dimensional representation of data. In addition, we have sheets. You can see at the bottom left that this particular sheet is titled Sheet 1. There's a little plus icon next to that which we can use in order to add additional worksheets into an Excel workbook. All of these terms are a part of Excel's data model. Rows, columns, sheets, all of these make up workbooks, and a workbook is a file in the Excel world. Let's quickly orient ourselves with some of the menu items. You can see that up top in the menu ribbon bar, the menu item that's been selected is Home. To the left of Home is the File menu item, and to the immediate right is the Insert menu item. You can see that in the Home menu, we have groups of menu items corresponding to clipboard, font, alignment, number, that's a number formatting, styles, cells, editing, and ideas. In case you're wondering what this menu item called ideas is all about, if you select a range and click on this, it's going to analyze the data in that range and suggest different visualizations. So if you have some complex data and aren't sure where to start, the Ideas tab might be a good starting point. Remember that the Home tab contains some of the most common operations related to formatting. Let's click on the Insert menu item, which is just to the right of the Home menu item. Notice how all of the contents of the menu bars change. Now we have items corresponding to tables, add-ins, charts, tours, sparklines, filters, links, comments, text, and symbols. Pivot tables and recommended pivot tables are all featured within the table section. This is something to keep in mind because pivot tables are an extremely important and commonly used Excel feature. Let's keep going with our quick tour. Let's click on the page layout menu item, which is one place further to the right of the insert menu item. This is mostly going to come in handy when you're applying themes or attempting to print your Excel workbook. So the groups here are themes, page setup, scale to fit, sheet options, and arrange. Next to the right in the ribbon up top is the formulas menu item, and this again has some extremely powerful features. You can see that towards the left, we have a group called function library. This can be used in order to insert functions of different types, such as financial, logical, text, date and time, math and trigonometric, and lookup and reference functions. The defined names group of menu items can be used to work with named ranges. Formula auditing allows us to trace dependents, precedents, and errors. And finally, there are also different calculation options. And then over towards the right, euro conversion and euro formatting in the solutions group. You can spot a pattern here. Within each menu item in the top level menu ribbon, we have groups of individual menu items. And as we move from left to right, those menu items become less general and more specific. So for instance, the formula items which we see towards the left are extremely general and widely used. As we move towards the right, we get to the more specialized bits of functionality. By this point, Excel has grown to include so many features that it can be quite complex to find exactly what you're looking for. So if you're looking for a common operation and you don't find it towards the left of a particular group of menu items, you're probably looking in the wrong heading. Let's keep going with our quick tour. We switch to the data item from the ribbon up top, and the headings here are called Get and Transform Data, Queries and Connections, Data Types. This includes functionality for stocks and geographical data, sort and filter options, data tools such as converting text to columns, and then forecasting tools such as what if forecasts. And way over on the right, we have the Analyze tab, which includes Solver and Data Analysis. Solver is an add-in which can be used to solve optimization problems from within Excel. Now, the next item in the ribbon is titled New tab, and this has a single item called Camera. This particular menu item has been added by me as an attempt to customize my Excel toolbar. We won't go into the details of how exactly I accomplished this, but you should know that it's possible. This particular tool can be used in order to obtain an image consisting of various cells from an Excel workbook and then manipulate that image and apply formatting and perform other operations. Let's keep going with our quick tour. In the Review tab, we have groups of actions corresponding to proofing, accessibility, insights derived from something known as Smart Lookup, language and translation tools, comments, notes, protection. This can be performed at the level of a sheet, a book, or just ranges of cells within a worksheet. And finally, the use of a pen-like formatter or highlighter that's under the ink section that can be used in order to highlight specific cells using pens or highlights. Next in the top level toolbar is the View menu item, and you can see that the groups here are titled Sheet View, Workbook Views, Show, Zoom, Window, and Macros. So you can use these items in order to freeze panes, view macros that are available in this workbook and invoke them, add page breaks, and perform grid line or formula bar customizations. Let's move to the Developer tab. That's the next item in the ribbon up top. This can be used in order to open up a VBA editor and record macros. In case you're wondering what the difference is between this menu item and the macro menu item in the View tab, well, this one actually works with the code. That's the Visual Basic for Applications or VBA code that underlies the macro. We're almost done with our exploration of the top level menu items. The two remaining items are the Help tab and the Power Pivot tab. Power Pivot is extremely powerful, but it's quite specialized and it's not really our focus right now. So we'll pass over this quite quickly. Let's now turn our attention back to the Data menu item. And then after we click on Data, we click on the Get Data menu item over in the top left. This can be used in order to insert data into an Excel workbook from different sources. You can see that these sources could include files, databases, Azure, cloud platform based tools and data warehouses, as well as from various other sources. Here we are going to start simple, so we just use the From Workbook option, which is listed inside the From File menu item. The other menu items here tell us that we can also get data from text or CSV files, XML, JSON, or PDF files, as well as from directory folders. Now, you might be wondering why we choose to get data from a workbook rather than simply open the workbook using Microsoft Excel. And that's because when we choose the Get Data wizard, Excel is actually going to parse the data in that Excel workbook and create a data table. Let's quickly see this for ourselves. So let's navigate to the Excel workbook which we are trying to import into this particular workbook. This one is called Honey Production and it's sourced from a Kaggle URL. The URL of the original Kaggle data is visible on screen now. When we click on that Excel file, we can see that an import button appears in the bottom right. When we click on that, it takes a moment, but then a navigator wizard opens up. This navigator wizard, which is on the left, has an item for the workbook which we are trying to open. That's called honeyproduction.xlsx. And listed under that is a list of tabs corresponding to sheets in that workbook. Here, this workbook has just one tab or one sheet, and that's called Honey Production. Let's click on that in the navigator on the left, and then in the main data pane over on the right, we get a tabular representation of the data in that particular worksheet. All of the rows and columns in that worksheet are visible here. Once we are ready, we click on the load button at the bottom, and that causes all of the data to be loaded into a data table abstraction in our Excel workbook. Note how this appears in a new sheet which is titled Sheet 2. Also note how over on the right, we have a panel called Queries and Connections. This is what establishes the connection between our current Excel workbook, which is titled Book 1, and the imported Excel workbook, which was called Honey Production. You can see there that 626 rows of data have been loaded into this current workbook. Let's close that Queries and Connections tab and rename our sheet. You can do that by clicking on the sheet name in the bottom left. Because we loaded this data from the workbook, let's call it Workbook. And then let's switch over to the other sheet titled Sheet 1. There, very quickly, we again click on the Get Data button in the top left. We again choose the From File option, but this time we will load from a text/CSV file. We navigate into the same folder. You can see that there is a file there called Honey Production, but by scrolling a bit over to the right, we can see that this is of type text document. We select this file and then hit the import button in the bottom right. This opens up another dialog. This is different from the navigator dialog we saw a moment ago. This dialog only represents the data within this one file. You can see that there are details about the file origin, the delimiter, and the data type based on detection. We click on the load button in the bottom right, and this causes all of the data to be inserted into yet another new sheet. Again, it's in the form of a table. Let's quickly rename that sheet to text CSV. The slash character is not allowed in sheet names. And as before, over on the right, we have the Queries and Connections tab, which tells us once again that 626 rows have been loaded. This gets us to the end of our first little demo in which we performed a very quick tour of Excel's menu items. We then zeroed in on the Get Data menu item and used that to load data first from an Excel workbook and then from a text/CSV file. Now that we have a good sense of the basic get data functionality, let's go ahead and explore some other aspects of importing data from different formats into an Excel workbook. We are currently in the Home menu. We can see that from the little green underlining under the word Home. Let's switch to the Data menu by clicking on the Data menu item. We begin as before by clicking on the Get Data button in the top left. We navigate to the From File menu item, but this time we navigate to the From XML sub-menu item. This opens up a file chooser and you can see our honeyproduction.xlsx. And if we scroll a little over to the right, we can see that the document type is XML, and this is because under the hood, .xlsx files are actually represented using XML. So this file can be opened either as an Excel workbook or as an XML document. Let's click on it. hit import, and once again we are taken into the data import wizard. There's a navigator over on the left, and again at the top level we have an item for the workbook itself, which here is honeyproduction.xlsx.xml. What's interesting, however, is that the items underneath that top level item are no longer the individual worksheets within the workbook. Instead, we have two groups called columns and records. And this is because the data within an XML file is arranged into elements, and here we have two types of elements, columns and records. We can expand each of them by clicking on the little arrows. For instance, if we expand on the columns item, there are 8 of these items, one for each column in our data. If you were to compare this tabular representation with a relational database, then the columns here correspond to the schema of a database table. Let's also expand the records set of items, and there we can see that we seem to have just one item that's called record. So in our analogy with the world of relational databases, the records element corresponds to the actual data contained within the database table. Let's return to the columns. Let's click on any one of them. You can see, for instance, that when we click on numCol, information about that column appears over on the right. For instance, the type of the element, which is text, and the attribute index. In other words, the position within the schema where this column appears. Here, the attribute index of numCol is 2. One important point to always keep in mind. In Excel, all data is indexed starting from 1. This makes Excel quite different from programming languages such as Java or Python, where data is indexed starting from 0. That does it for the schema. Let's turn our attention to the actual data. Now, in order to be able to view that, let's select a checkbox which is over at the top left. That's the checkbox called Select Multiple Items. Once we check this box, you can see that individual checkboxes appear next to the items down below. Let's click on the item called record, which shows up under records. And when we do this in the pane over on the right, we get all of the data contained in our XML file. In case you're wondering why we have records and then within that we have another element called record, that just has to do with the XML format. There are nested elements, and this is just how the data is represented. You can see that we have data arranged into rows and columns. The column names correspond to the columns which we see over on the left, and the individual rows are the actual data in the XML file. Once we are ready, we go ahead and hit the load button in the bottom right. This causes the data to be added into our Excel workbook. This time, however, that data does not appear in a worksheet. It merely appears in the Queries and Connections tab over on the right. You might find this odd. Why is the data not actually visible in the worksheet? Well, it's because XML data can be more naturally viewed via something known as the Power Query Editor. We'll get to that in just a second. But first, notice that if you click on the individual items under the Queries and Connections tab, you can get data about the individual columns as well as when the data was loaded, the last refresh status, and the data source. In any case, once we've got a basic sense of the Queries and Connections data, we navigate down to the bottom, click on the item called Record, and there a preview pane appears. In the bottom left of the preview pane, we have an option called View in Worksheet, and next to that is another option called Edit. We could choose to use the View in Worksheet option in order to get all of this data into our Excel workbook, but instead let's double click on the data. We can also do this by choosing the Edit option, and this opens up a separate window called Power Query Editor. Power Query Editor is a separate Microsoft product. This integrates tightly with Microsoft Excel as well as with Microsoft Power BI, and the primary use case of Power Query Editor is in order to transform data in different ways. You could use Power Query Editor to set up ETL pipelines. ETL is an acronym for Extract, Transform, and Load. In the center pane, you can see the data from our XML file. We can also see over on the right that we have query settings. Within that, we have a list of applied steps. Here, there are 3 steps: source, navigation, and change type. These are steps which were performed by default when we loaded in the XML data. Note that we did not have to perform any of these steps ourselves. Notice that right now we have selected the change type step that's highlighted in green, and because we've selected it, the actual details of this step are visible in the formula bar just above our data. This change type operation was performed by using the table.transform column types method. You can see that table.transform column types method changed the type of num call to be of int64, price per lb to be of type number, and prod value to again be of int64. And in this way, we can see the individual steps which went into preparing our data. That's the whole point of Power Query Editor, and it's an important tool which you must know about and must master to a certain extent to fully leverage Microsoft Excel for data visualization and big data processing. You can also click on the other applied steps. So for instance, if we click on source, we can see in the formula bar that the command was called xml.tables. And this in turn invoked the function file.contents along with the file path from which the data had to be loaded. Once we have a basic understanding of Power Query Editor, we can close that window by clicking on the close button on the top right. This takes us back to Microsoft Excel. Again, remember that Power Query Editor is a separate application. And remember again that we can load the data from the XML into our Excel workbook anytime we like by clicking on the View in Worksheet button, which is visible in the bottom left of the preview for the record field. That does it for XML data. Let's close out of queries and connections, go back to the Get Data button in the top left, and use that now to import data from a JSON file. JSON is an acronym for JavaScript Object Notation, and data is often obtained in this format while performing web operations or sending or receiving parameters from HTTP endpoints. We won't talk a whole lot about JSON, but just enough for you to have a basic sense. Now we have multiple files all called Honey Production. If we scroll a bit over to the right, we can see that one of them is of type JSON. We select that file and then click on Import down below, and this time by default a Power Query Editor window opens up. We can see that we have just one column. That column is called list, and every element within that column also seems to be of type list. In the formula bar up top, we can see that the formula invoked is json.document, and this in turn invokes file.contents along with the file path. Let's try clicking on any one of those list items. Here we click on row 1, and that in turn takes us into yet another list. But this one in turn has one element for each column. So you can see that these elements are state, num call, yield per pound, and so on. This is just the way data is represented in JSON. If you were to actually look at a JSON file, it would have a lot of curly braces, and within those curly braces would be a lot of key value pairs. Also note that every action we perform is being recorded over on the right. So we cross out the navigation step that takes us one step back to the list of lists, and if we click on an individual list there again, we can see a preview of the items in the pane at the bottom. So this particular row, which is row 5, corresponds to data where the state is equal to California and the year is 1998. In this way, we can use the Power Query Editor window in order to preview and transform JSON data. Let's experiment by clicking around on a few different rows. As we click on different rows in the pane on top, the data in the pane below gets updated. And very interestingly, when we click on the first row, we just get the names of all of the columns. So in this JSON representation, the first row contains all of the schema information, and it's a list just like all of the other rows in our data. We now have a good sense of how to work with both JSON and XML data files. So at this point, we can close out of the Power Query Editor window by clicking on the close button on the top right. Next, let's turn our attention to working with PDF data as well as folders containing separate data files. Both of those are in the demo coming up next. In this demo, we will continue our exploration of data import via the Get Data button. This time we will focus on importing data from PDF files and from folders. Let's begin in the usual way. We click on the Get Data button in the top left. Note that we are in the Data menu. From the menu which opens up, we choose the From File menu item and the From PDF sub-menu item. This brings up a file chooser. As usual, we have multiple versions of the Honey production file, one of which is in the PDF format. In case you're wondering how we got this PDF version, well, we simply saved an Excel file using the export functionality. In any case, let's import this file. A navigator opens up as before. This time, note that we have a very large number of pages, 28 to be precise. That's just the way the pagination worked out. Let's select that checkbox called Select Multiple Items, and then we can go through and navigate by clicking on the individual checkboxes next to the pages. Once we are comfortable with the data, we click on the Load button towards the bottom right. Please note that at this point, we've only selected page 1 and page 2. These have been called Table 001 and Table 002 respectively. So when we now hit the Load button, only these two pages appear in the Queries and Connections dialog over on the right. We navigate down to the bottom where these two entries are visible. If we choose any one of them, a large preview pane opens up. Let's spend a moment navigating the data. We can see that unfortunately there are no column headings in this data as it's been loaded in from PDF. In any case, once we are comfortable with how the data looks, let's double click on either of these entries, and this takes us into Power Query Editor. And there we can go ahead and apply various transformations, such as renaming the columns. Because our main focus here is not on Power Query, we are not going to actually perform those operations, but this is something that you should keep in mind. If you read in data which does not have headers, you can always just go ahead and modify those column headings from the Power Query Editor. In any case, let's close out of Power Query Editor and come back to Microsoft Excel. And this time we are going to import data using the Get Data button in the top left. And that data is going to be from a folder. So we navigate to the From File menu item and then to the From Folder sub-menu item. As the tooltip helpfully tells us, this option can be used in order to import metadata and links about files in a folder. We then have to navigate to the folder that we are looking to read in. We click on the Browse button, and that leads us into a file chooser. Here, the folder that we wish to upload is called Datasets, so we choose that folder and then hit OK. At this point, all of the files contained within this Datasets folder are going to be parsed and processed by Microsoft Excel. Let's take a moment to understand what's on screen now. We have columns corresponding to the content types, the names, extensions, and the dates when those files were last accessed, last modified, and created. And over on the right, we also have columns which tell us what type of attributes the files contain. We've already worked with most of these file types. Note the .json, .pdf, .xlsx, and .xml. The first line in this table is an interesting one. This has the extension .accdb. In case you're wondering what that is, well, that's a Microsoft Access database file. More on that in a moment. First, notice that down below towards the right, we have buttons titled Combine, Load, Transform Data, and Cancel. So we could use these in order to combine data from different sources. That's one of the primary use cases of Power Query Editor. For now, let's go ahead and hit Load. This will simply cause information about all of these files to be available in our Excel workbook. This is simply an Excel data table representation of the same data we saw a moment ago in the preview pane. Let's rename this worksheet folder because this data was read in from a folder, and then let's round out our discussion of the Get Data button. This time we're going to read data in from an Access database file. So again we navigate to the Data menu. Again we click on the Get Data button on the left. This time we choose the From Database menu item, and then the From Microsoft Access Database sub-menu item. You can see that it's also possible to read in data from a SQL Server database, as well as from some other database services. Microsoft SQL Server, of course, is the flagship relational database offering from Microsoft. Let's click on the Microsoft Access Database option. Only .accdb files are now going to be visible in the file chooser. So there's only one such file. We click on it and hit the Import button. Access is a much more lightweight database technology than SQL Server, but the basic idea remains the same. Data is organized into rows and columns. The difference is that the row and column information is all encapsulated into an individual Access database file. Each Access database file can contain multiple tables. Here we can see in the navigator on the left that our honeyproduction.accdb file contains just the one table, which is called Honey Production. And of course, we can view the contents of that table by clicking on it. Those contents appear in the preview over on the right. Once we've understood the data and are ready to move on, we click on the Load button in the bottom right, and then we are returned to Microsoft Excel. As before, we have the Queries and Connections tab over on the right. If we scroll to the bottom, we can see that our honey production appears for the third time. If we click on it, we get the actual data from the Access database present in this worksheet. We can rename this worksheet Access just so that we are clear about where this data came from. This gets us to the end of our exploration of loading data from different file types into a Microsoft Excel workbook. In the demos coming up ahead, we will turn our attention away from loading data and towards visualizing and analyzing that data. In this demo, we will actually start visualizing data. On screen now is a subset of the data corresponding to honey production. This data is organized, of course, into rows and columns. The rows correspond to states in the United States, and the columns correspond to years. Each of the individual values contained in cells B3 through G7 corresponds to the number of pounds of honey produced in a particular state in a particular year. In case you're wondering how you could get this data from the raw honey production data, well, it's pretty simple. You just create a pivot table of that data. You would have rows corresponding to the states and columns corresponding to the years. The aggregate function you would use would be the sum. Our focus is on visualization, so let's go ahead and select 3 rows. We include the header row as well as the rows corresponding to the states of Georgia and Hawaii. Once we do this, a little button appears at the bottom right of the selected range. We click on that button and we can see that various actions are now available. These are grouped into categories called formatting, charts, totals, tables, and spark lines. For now, let's click on the second tab, which is charts. Down below are different types of charts which have been recommended by Excel based on its analysis of the data. What's more, for each chart type, as we hover over it, Excel creates a preview. To try this out, let's hover over the cluster chart type and you can see that a preview appears up top. What's more, there's also a great little tooltip telling us what types of situations this chart type is meant for. This is actually really useful information, so let's take a moment to understand it. The cluster chart type should be used to compare values across a few categories, and you ought to use it when the order of categories is not important. How about the line type? Well, if we hover over, the preview changes, as does the tooltip. Line charts are great for showing trends over time, such as years, months, or days. They are also useful for trends across categories. You ought to use it when the order of categories is important and when the number of data points is large. How about stacked bar charts? Let's find out. The preview tells us how they look, and as the tooltip tells us, we should compare parts of a whole using stacked bar charts. And importantly, you should use stacked bar charts to view how parts of a whole change over time. If you just like to view parts of a whole at one moment in time, then a pie chart is probably a better option. A clustered bar chart, on the other hand, is useful when comparing values across a few categories, and it makes sense to use this when the chart shows duration and the category text is long. These tooltips are great. Let's try one more. Stacked charts are great in order to show a relationship of parts of a whole over time. This makes these similar to stacked bar charts, but because these charts are continuous rather than discrete, they help us draw attention to the total value across a trend. Let's also click on the More button on the extreme right, and this opens up an even more detailed dialog where there are both recommended chart types as well as all chart types. If we scroll down through the list of recommended chart types, we see details of the charts we just viewed. If we click on all charts, we also get other chart types which Excel did not think might have been suitable for this particular data. These include some pretty specialized chart types such as Sunburst plots, histograms, box and whisker plots, waterfalls, funnels, and combo charts. We can spend some time experimenting with different chart types. As before, we can hover over them in order to get magnified previews. These different chart types differ in properties such as whether they are 3D or 2D and whether they are clustered or stacked. Once we've settled on the exact form that we like, we can go ahead and click on the OK button down below. This causes the corresponding chart to be inserted into our Excel worksheet as an object. We can manipulate this object we can move it around, we can also resize it by clicking on the knobs at the extremities of the bounding rectangle of the chart. Through all of these operations, notice that not only is the chart object itself selected, but what's more, all of the underlying data is selected as well. And that underlying data has been highlighted in different colors. Cells B2 through G2, which correspond to the labels on the x-axis, have been highlighted in one color. The row headings, which correspond to the states Georgia and Hawaii, have been highlighted in a second color. And finally, the actual data, which has been visualized using the bars, has been highlighted in a third color. This difference in highlighting is important. It tells us that these are all different chart elements. In any case, let's now insert yet another chart. We click on the Insert menu item up top. The menus change, and we then have a large number of available chart types in the Charts section. Somewhat at random, let's go ahead and pick a 2D column chart. When we click on this, we don't have any data from the Excel workbook selected, and that's why it initially appears as a blank chart. Well, that's easy enough for us to fix. Just right-click and choose the Select Data option. We can use the mouse in order to select cells A2 through G3. Note how all of these addresses have been preceded with $signs. That has to do with absolute cell references in Excel. This means that this formula will not change, it will not be updated if we copy or paste it. Note also how the name of the worksheet appears before the cell formula, and that's delimited by an exclamation point. This is the standard way in which Excel cell range addresses are created, and you should be familiar with it in case you need to create a cell range yourself. Now notice that we've only selected rows 2 and 3 and the columns A through G. As a result of this, Excel was able to infer that we have just one data series, and that series is called Georgia. That's why Georgia appears in the chart as the title, and that's also why it appears in the box over on the left in the Select Data Source dialog. What about the values in row 2? Those are the horizontal category axis labels, and that's why they appear along the x-axis in the chart and on the right side of the chart data dialog. Notice all of the checkboxes which can be used to turn the display of these elements on or off. Once we are satisfied with how our preview looks, we can hit OK, and the chart now actually gets added into our workbook. We have two charts in this worksheet. We can go ahead and customize either of them. Note that we have now selected the previously inserted chart, the one which is located over on the right. After selecting it, we click on the Add Chart Element button on the top left. Please also note that this is inside the menu item titled Chart Design. We can see Chart Design way over on the top ribbon bar over on the right. When we created and selected a chart object, this menu item was displayed automatically. In any case, coming back to the Add Chart Element button, you can see that there are options there to configure axes, axis titles, the chart title, data labels, and many other properties. Let's quickly navigate through all of these so we get a quick tour of how chart elements can be customized. Under the axes subheading, we can add either primary horizontal or primary vertical axes. If we'd like to customize axis titles, that's the second menu item. Once again, the options there correspond to primary horizontal and primary vertical. Note how when we select primary horizontal, a little text box appears below the x-axis in the chart on the right. That text box currently just says axis title, but we can customize it. Let's not add any axis titles and instead switch to the chart title menu item. There you can either customize the chart to have no title, or for the title to appear above the chart, or as a centered overlay. Notice how the chart appearance changes as we cycle through these different options. Let's now try the data labels option. Once again, the options here are none, center, inside end, inside base, outside end, and data callout. You can see from the chart on the right that data callouts on every point are a little excessive. The chart gets really quite cluttered. A better way of including the actual data within the chart is using the data table option. Here again, the choices are none, with legend keys, and no legend keys. Let's try the with legend keys option. A little table is going to be added down below, just below the x-axis. This table is a very neat representation of the actual numeric data which has been plotted right up above. No legend keys will preserve the table, but will no longer have a legend color coding the rows in that table. Both of these are great options and you should seriously consider using them. The next item here is error bars. Error bars are a great way of depicting just how much variance a particular data series contains. The default option is none, but we can also have error bars based on the standard error, that's a concept from statistics, based on percentages, as well as on standard deviations. Error bars are closely related to underlying statistical analysis of a data series. We won't spend a whole lot of time exactly understanding these right now. We can also customize the grid lines in our chart. Grid lines are a lot easier to understand. We can choose to have these along the primary, major horizontal and vertical axes or the primary, minor horizontal and vertical axes. Next, we can customize the legend. The choices here include none, right, top, left, and bottom. We've now understood some of the basic elements of customizing charts. The one remaining element in the Add Chart Elements menu is a trend line. That's a little more complex and it's also a very powerful tool in data analysis. So let's discuss that in the demo coming up next. In this demo, we will pick up right from where we left off at the end of the last one. There, we were learning how to customize charts by using the Add Chart Element menu items. The one that we are going to focus on at the start of this demo is the trend line. Trend lines are closely related to the data analysis techniques of linear and logistic regression. On screen now, you can see the choices of trend line available in Excel. The default, of course, is none. This means that our data will appear without a trend line. The other options here are linear, exponential, linear forecast, and moving average. You should know that if we select a linear trend line, that is going to have a linear regression performed on the data, and then the best fitting straight line between the x and y values will be added to the curve. Here, by choosing the linear option, you can see that a trend line has appeared in the graph representing the data for Georgia. That trend line appears as a dotted downward sloping line. That downward slope tells us that production of honey in Georgia over this period of study has been declining. Now, if we look at only the bars and ignore the trend line, it's not really obvious that the trend has been a declining one. In 2007 and 2008, production rose, it then collapsed down in 2009 before starting to recover in 2011 and 12. So it's a little hard to interpret the bars alone. However, if we add the linear trend line, we can see that there is a clear downward slope. How was this line computed? Well, the best fitting straight line between the x and the y values was calculated using least squares regression. That's of course an extremely common and powerful machine learning and data analysis technique. What if we decided that a straight line was not the best curve in order to model the relationship between the x and the y values? Well, maybe an exponential curve is better. So let's hover over the exponential option and you can see that the shape of the curve changes ever so slightly. It's not really clearly visible here, but using the exponent or the log function in order to transform our data often yields a much better trend line. Next, let's try the linear forecast. You can see that when we go with this option, the x-axis appears a little wider. And that's because we now have additional values on that trend line, even for those years for which we do not have bars. Where did those values come from? Well, a trend line, that is a linear regression line, was fitted to the x and y values which we do have. That gave us a model, and that model was used to predict values for years which we do not have data for. Let's also try out the moving average option. You can see that this moving average, as its name would suggest, is quite responsive to the data. You can think of it as smoothing the data by computing a moving average of different points in the data series. The moving average trend line is the only trend line here which correctly captures the fact that production first fell and then rose. Also note how the moving average curve only starts from the second point, and that's because the moving average is computed over 2 points, and so we cannot have a moving average for the first point. There just isn't a window over which to compute that moving average. Let's exit out of the Add Chart Element menu for a moment, and let's now go ahead and select the second chart. This is the one where we have data for both Georgia and Hawaii. Up until now, we had been experimenting with trend lines in the univariate chart, which only had data for Georgia. Because we have two series in this particular chart, we can add trend lines based on either one of them. To see this, let's click on the Add Chart Element button in the top left and then select the trend line option. Let's go with a linear trend line to begin with. When we choose this option, we are going to be prompted for which series we'd like the trend line to be based on. And you can see that the two series are named Georgia and Hawaii. Let's pick Georgia and hit OK, and we see a blue trend line has been added to our bivariate chart. Also notice how the legend has three items, Georgia, Hawaii, as well as a dotted blue line which reads linear Georgia. In similar fashion, we can experiment with different types of trend lines for both series. And what's more, these can be added independent of each other. For instance, you can see that in our graph right now, we have the two bars corresponding to Georgia and Hawaii. We also have a linear trend line for Georgia, an exponential trend line also for Georgia, and then a moving average trend line for Hawaii. And as the legend tells us, that moving average is computed over 2 points at a time. So what we learn from this example is that one chart can have many different trend lines computed using different techniques. We are done for now with our exploration of trend lines, so let's set the trend line choice back to none and then turn our attention to chart layouts. To do this, we'll first add a data table to our chart. So we click on Add Chart Element, select Data Table, and then go with the option with legend keys. This is the most informative of the data table options. You can see that a table now appears below the x-axis in our chart. Now with this chart selected, let's click on the Quick Layout button, which is just to the right of the Add Chart Element button. There are several different layout options. We can hover over any one of these in order to get a description of what this layout contains, as well as a preview. As we hover over different options, you can see that the chart appearance on the right updates in real time. This choice of layout can be used to control which chart elements are displayed. These include the chart title, the legend, data labels, and the horizontal and vertical axes, as well as grid lines. You can see all of these in the tooltip for layout 10 on screen now. That does it for the second button. Let's now try the change colors button, which is the third from the right. Here you can see that there are different color schemes. These are named colorful, monochromatic, and so on. As we hover over these, we can see that different palettes are applied to our chart. And the palettes represent groups of colors which are going to be used to modulate the appearance of our graph. Next, let's experiment with different chart styles. You can see these in a drop down which is just to the right of the change colors button. You can see just how much functionality Excel has for controlling the precise appearance of a chart. And that functionality can be thought of as ranging from very granular to very general. The functionality in the Add Chart element, which is way over on the left, is extremely granular. By the time you get to the chart styles functionality, this is very high level. If you work with visualization libraries in Python, you can see that these correspond to different types of visualization libraries. The Add Chart Element commands correspond to matplotlib operations. The chart styles correspond in some sense to Seaborn or more high-level APIs. In any case, continuing to move from left to right, we can click on the Switch Row/Column button just to the right of the chart styles. As you might expect, this allows us to interchange the X and the Y axes. In this particular example, the switch row/column operation is not terribly meaningful, but there are examples, particularly with scatter plots or regression plots, where switching rows and columns is a very meaningful and interesting operation. Notice how through all of these operations, the underlying data has remained highlighted in the Excel workbook. You can see the highlighting applied separately to row 2, to column A, and then to the data itself, which is in cells B3 through G4. What if we decide that we are just plotting the wrong data? Well, it's easy enough to expand or change the data that we're visualizing. We just need to click on the Select Data button, which is to the immediate right of the Switch Row/Column button. Clicking on that button opens up a dialog where we can change the chart data range. This is the same Select Data Source dialog which we saw in a previous demo. The current chart data range consists of cells A2 through G4. We can change that. We click on the little arrow icon over on the extreme right, and then using the mouse we expand the selected data range so that the new range consists of the cells A2 through G7. We hit OK, and this causes a much fuller graph to appear on screen. This graph now has information for all of the other states as well. As we can see from this example, it's very easy to change the data contained in a graph even after the graph has been created. So if you end up with a visualization that does not have the data you like, you can always just change that using the Select Data button on screen now. What if you're fine with the data that you selected, but you decide that a different type of visualization makes more sense? That's easy enough to change as well. You just click on the Change Chart Type button. That's again just to the right of the Select Data button. And doing this brings up another dialog which we encountered while creating our graph in the first place. There are two tabs, Recommended Charts and All Charts. Currently, by default, the All Charts tab has been selected, and you can see in the pane on the left just how many different types of charts Excel supports. Let's change the chart selection from column to line, and there let's go with the default chart type. And as soon as we hit OK, we can see that our graph is going to be transformed from a bar chart to a line chart. Note how the other properties have not been changed. We still have the data table displayed down below, and we still have the major grid lines. We've come to the end of this little demo in which we saw how different aspects of the data and the appearance of a chart can be easily controlled even after the chart has been created in the first place. We ended the last demo by changing the chart type from bar chart to line chart. Now we are going to see how some of the elements of the chart menus are context sensitive. For instance, if we now click on the Add Chart Element button over on the top left, now we see that some of the menu items are different because we are working with a line chart rather than a bar chart. For instance, the lines menu item had previously been grayed out, but it's now been enabled. By default, lines are not displayed in our line chart. However, if we change the setting from none to drop lines, we see that vertical lines appear from each point down to the x-axis. If we choose high-low lines, on the other hand, those vertical lines will end when they reach the lowermost of the line charts in the graph. Drop lines as well as high-low lines are helpful with line charts because these are continuous charts and it's sometimes hard to see which points on the graph exactly represent actual data points in the underlying data series. These drop lines were a little hard to make sense of, so let's fix that. Let's change the data by clicking on the Select Data button and restricting our selection only to the data for Georgia and Hawaii. Now, when we hit OK, we have only two lines. We then click on Add Chart Element, navigate to Lines, and enable high-low lines. When we do this, we can clearly see that the data begins on the series for Georgia and ends on the line for Hawaii. There's another menu item in the Add Chart Elements menu, Up-Down Bars, which is now enabled. Let's try out the two options. The default is none. The other simply turns on up-down bars. These are quite similar to the high-low lines, except that they are bars rather than thin vertical lines. Finally, let's try out the Move Chart menu item at the very right. You might be wondering why we need to use a menu item. After all, we can simply drag and drop a chart to any location on screen. Well, the answer is it's handy if we'd like to move a chart to a new sheet. You can see that there are two choices about where we'd like the chart to be placed, New Sheet or Object In. Here we've selected the New Sheet option and there's the name of a sheet, Chart 1, which is going to be added into our Excel workbook when we hit OK. As you can see, this sheet has nothing but the one large chart which dominates the screen real estate. At this point, we decide that this isn't quite what we had in mind, so we again click on Move Chart. This time in the New Sheet option, we type in the name of the pre-existing sheet column. Excel picks up that this sheet already exists and it asks whether we'd like to place the chart embedded into that existing sheet. The answer is yes, and when we hit yes, we find that the Chart 1 tab has disappeared from our workbook and the chart has moved back to the column worksheet. We've now thoroughly explored the functionality in the Chart Design menu item. You can see up top that the currently selected menu item is Chart Design. We know that because of the green rectangle under the word Chart Design in the top level toolbar. Let's now turn our attention to the Format menu item. In case you're wondering whether all of this formatting and chart operations constitute overkill, The answer is a resounding no. In the real world, every little feature from Excel is actually used heavily, whether it be by Wall Street bankers or by data analysts who need to build a quick prototype before they switch to a more serious tool such as Python, R, or Java. So let's switch to the format menu, and once we do this, we find that there's yet another set of functionality for us to explore. Let's begin with the drop-down over on the top left. Notice how that drop-down is used to control the current selection. From that dropdown, we can choose any one of a number of different chart elements, the chart area, chart title, data table, and so on. This dropdown is a quick way to select some specific aspect of a chart which might be very hard to select using a mouse. Now, for instance, we choose chart title. Before we do this, pay close attention to the chart title of the chart on the right. After we select chart title, you can see that that chart title is selected. The rectangle which bounds it has been highlighted, and we can now edit the chart title as we like. This drop down over on the top left is a great way of selecting small little elements from within the chart. You can then go ahead and customize them from the chart itself. If you change the selected value from the drop down, for instance, you now choose data table, pay close attention to the chart on the right, the data table is now going to be selected and highlighted. You can now modify it or move it around. And in similar fashion, you can explore different choices of the current selection from that dropdown. Now let's say we select the horizontal category axis. Then if we click on the Format Selection button right below that dropdown, we can see that a new formatting pane appears at the right of our screen. That formatting pane allows us to customize the properties of the currently selected control. This time it's the horizontal axis that we've selected, and that's why on the right we see Format Axis. Note how, for instance, there are axis options as well as text options, and those axis options themselves are of various categories. The axis type is currently set to automatically select based on data, vertical axis crosses, axis positions, as well as a checkbox for categories in reverse order. All of these are available, and down below there are other groups which we've not yet explored, such as tick marks, labels, and number formats. And then up top we have icons which correspond to different types of chart and axis properties. So if we click on the second of these, you can see that the alignment can be controlled from here. Let's click on the bucket icon over on the extreme left, and you can see here that fill and line properties can be controlled from here. We expand fill, and the choices include no fill, solid fill, gradient fill, picture or text fill, pattern fill, and automatic. We also have a color chooser to control the color of the fill. Let's expand the line set of options, and here we can control the type of line used in the bar chart. So no line, solid line, gradient line, or an automatic choice. We can also control the color, transparency levels, the width of the line, thickness, the compound type, dash type, and cap type, all from this menu. Next, let's click on the little pentagon next to the bucket icon, and that in turn opens up shadow, glow, soft edges, and 3D formats. Because every aspect of an Excel chart can be customized in so many ways, it doesn't make sense to try and remember all of these different menu items. However, it is important for you to have a rough sense of what operations are possible and where those operations can be found in the Excel menus. And that's why we're spending so much time orienting ourselves with all of these options. Up top, let's click on text options, and now you can see that there are various font properties. These include text fill and text outline. If we click on the second little icon there, those properties change, and we can now control the shadow, reflection, glow, soft edges, 3D format, and 3D rotation. Likewise, if we click on the third icon there, yet another set of customizations appears. The text box, vertical alignment, text direction, and custom angle. For instance, if we wanted to have our text appear from top to bottom, that is vertical rather than horizontal, this is where we'd apply the change. Now remember that the Format Axis menu only appeared because in the drop-down on the top left, we had chosen the horizontal category axis. Let's close out of this Format Axis menu and then right-click on the graph and choose the Format Chart Area option. As soon as we do this, that drop-down on the top left changes as well. It's the chart area now that is the currently selected object. And similarly, the context-sensitive pane on the right also reads Format Chart Area. There's a little drop-down next to the word Chart Options. Let's use that drop-down in order to select a specific series. This is the series Georgia. And once we do this, you can notice that in the chart area, it's the blue line that's been highlighted. We can now tweak every little aspect of this series using the menu items on the right. What if we'd like to tweak the data for Hawaii? Simple enough. From that drop-down, we change the selection from the series Georgia to the series Hawaii. And you can see that the highlighting has now been transferred from the blue line to the orange line. Let's change the color of that line so that it's no longer orange. This is easy enough for us to do. We just make use of the color drop-down and pick a new color. Let's go with a deep shade of blue. This is a little hard to disambiguate, so we change the color to green. This little example shows how easy it is to customize individual series in this line chart. You can also see that the transparency of these lines is easy to control. We do that using the slider, and in similar fashion, we can adjust the width of that line for Hawaii. In similar fashion, we can also control the width. Notice how easy it is to make the line for Hawaii a lot thicker and more prominent. We can also control the dash type, for instance, to get a double line for Hawaii, or we can scroll up and use a gradient line where the shade changes as we move from right to left. After all of this experimentation, we decide that the automatic choice was just fine, and we click on it in order to undo all of the customizations we just applied. This is an important little tip. Let's say you find yourself making a whole series of changes and then decide that you don't like any of them. You can quickly and easily just revert to the automatic option. In this demo, we are going to pick up right from where we left off at the end of the last one, and we are going to continue exploring different aspects of customizing charts. We had just set the line of our line chart back to automatic. Let's now click on the marker tab up top. Here, there are options related to marker options, the fill, and the border. Now, you might be thinking that these menu items look strangely familiar. After all, this is the same menu that we saw a moment ago. Remember, however, that applied to the line in our series chart, whereas here we are only customizing the marker itself. We can change the color or add a gradient line. However, we'll need to define that gradient. Simpler options include no line or a solid line. Remember again that these settings only apply to the markers, and that's why none of the choices that we go with lead to any great change in the chart appearance. Let's click on the little pentagon. Again, we have the items for shadow, glow, soft edges, and 3D format. And finally, we can also click on the little bar chart icon. This will allow us to format the series. This particular control is an important one. Here is where we can specify whether the series appears on the primary axis or the secondary axis. This is often an operation that you need to perform when you have two different data series which have very different scales. So again, just so that this is not lost amongst all of the other formatting operations you're learning about, the Series Options tab is where you specify primary or secondary axis. Let's close out of the Format Data Series menu. We can tweak the selection of chart that we happen to be working with. We could choose the other chart or stick with current chart that we were working with, and then let's apply some different shape styles. These shape styles are available up top, and you can see that as you change from one to the other, the outline changes to reflect the style. And as before, we can get a live preview by hovering over the styles. In addition to all of those styles is a little drop down over in the right bottom corner of the shape styles button, and if we click on that, we get different theme styles. And as we walk through those different theme styles, the appearance of our graph changes as well. If we scroll a little further down, come a bunch of preset formats. These are very similar to theme styles, and these two can be previewed by hovering over each element in this menu. What if we'd like to fill the shape of our chart? Well, the shape fill button will do exactly that. We can do that in order to customize the background color. There are also different options below, such as picture, gradient, and texture. Let's very quickly hover over different types of gradients as well as textures, just so that you get a sense of all of the available options. The number of possible customizations is infinite. You can now see that we are trying out different shape outlines. As usual, we can preview easily. Then we switch to shape effects, and these are also in several categories: presets, shadows, glows, soft edges, bevels, and 3D rotations. Notice as we toggle through these different options how the corresponding changes are reflected in the graph over on the bottom left. These are nice ways of adding shadows, glows, and other special aesthetic effects to your chart. And it doesn't end with the shape effects, we can also switch to word art styles. These can be used to control the fill, background color, and texture, as well as the other properties of the title and the axes. In similar fashion, we can also change the font colors as well as the theme colors and apply weights, dashes, and other properties. You can see, for instance, that we are now experimenting with different types of shadows. We could equally easily apply reflection and glow attributes to the text. Next, let's see how we can control the relative position of these two charts. We currently have the Georgia chart behind the other, but by using the bring forward or send backward and send to back menu items in the arrange group up top, we can control which chart appears in the foreground. And in this way, we can precisely control whether it's the Georgia chart which appears in front of the Georgia and Hawaii chart or the other way around. Next, click on the selection pane menu item and a dialog appears over on the right which allows us to select one or both of the charts. Using this dialog, we've now selected both charts on screen, and at this point we click on the shape format menu item up top. This will allow us to control the relative properties of these two charts when both of them have been selected. Let's now click on Align. This is going to change the placement of these charts. And there are all of the expected options such as align left, center, right, top, middle, and bottom. There are also menu items here to snap to grid, snap to shape, and view grid lines. These can be used if you'd like to work with multiple charts all at once. Let's really quickly see how the align right, align left, and align center commands work. In the real world, you might find yourself in a situation where you have a complex workbook with many different charts, and in such a situation, selecting all of those charts and using these options will make them all a lot more manageable. Now, with both of them selected, let's try out the snap to shape option. Both the snap to grid and snap to shape options are meant to make it easy to move, add, or resize shapes when there are multiple shapes in a workbook. It's not easy to work with individual shapes or to align them, and that's where these features come in handy. Snap to shape will cause the edges of the shape to snap to the nearest edge of another shape. Here, because we have multiple shapes, these two are going to snap to each other's edges. Snap to grid is very similar, but here the edges of the shape will snap to the nearest horizontal or vertical grid lines rather than to each other's edges. Both of these are great ways of organizing shapes and objects in an Excel workbook. We quickly try out both snap to shape as well as snap to grid. And once we are satisfied that we understand them, we click on the group menu item up top. Here, both of these shapes have been aggregated into a single group, so all operations will apply to both. And in similar fashion, we can also ungroup shapes which have already been grouped together. Notice how once shapes have been grouped, you can also use the regroup option in order to recreate that group after you ungroup them. Let's wrap up this demo by switching back to the format menu and there using those little drop downs over on the extreme right in order to alter the height and width of our images. These are both in the group called size, and as you can see, these are units in inches. We can use these in order to get precise control over the aspect ratio of our chart objects. We spent a lot of time so far understanding how to import data into Excel and also understanding different menu items that help us to customize shapes. We are now going to change our focus away from these menu items and start actually building different visualizations. All of that will begin in a series of demos coming up ahead. We've now come to the end of this course getting started with Excel for data visualization. We began this course by creating an Excel spreadsheet and importing data from another Excel workbook into the spreadsheet. We briefly discussed that the reason you might import data this way is that Excel reads in the data as an Excel table, which is dynamically linked to the underlying data source. We saw how to use the Power Query editor to perform various kinds of operations on the imported data, how to import data from various file formats such as CSV and JSON, and also how to use Excel along with Microsoft Access database files. We then moved on to visualizing data using Excel. We went through some of the different types of column charts before settling on the basic clustered column chart. We saw how we could perform various kinds of formatting operations on this clustered column chart, such as adding data labels, error bars, and access titles. Along the way, we also learned how to add a trend line and how to customize the background of a chart. We then moved from column charts to line charts. Column and bar charts are great for visualizing categorical data, while line charts work best for continuous data, especially time series data. We created a simple line chart, then added lines for the highest and lowest values on the y-axis. We formatted various aspects of our line chart such as the width, color, and opacity of the line in our chart, explored background fill options, used different built-in formats for the chart title, legend, and axes, and also learned how to change the position of charts relative to each other. You now have a good basic understanding of some common chart types and are ready to move on to the use of more complex bar charts and the use of histograms. All of that's in the course Building Column Charts, Bar Charts, and Histograms coming up next. Excel is the most popular spreadsheet program in the world, but it's also a lot more. It's a go-to choice for an incredible range of statistical, scientific, business, and analytics related use cases. From numerical optimization to printing specific views of workbooks, from hypothesis testing to dynamic validation of user input, Excel provides for it all. In this path, our focus is on the data visualization capabilities of Excel. There is a wide range of common built-in chart types available, and in addition, many other specialized chart types can be constructed by ingenious reuse of those built-in chart types. This course starts by introducing column and bar charts. In Excel, the term column chart is used for plots in which the bars are vertical, and the term bar chart is used for plots in which the bars are horizontal. You then move on to formatting and customizing bar as well as column charts. You work with both 2D and 3D chart types. You then move on to histograms, which use bars to represent frequency counts, that is, the frequency of values in various bins. As we learn, histograms effectively discretize a continuous variable by splitting the range of the variable into bins and then calculating how many data points lie in each bin. In this demo, we are going to turn our attention back to a specific type of chart, and that's the bar chart. On screen now is the data which we'll be using in this demo and the subsequent ones. This is the same honey production data that we've been working with before. Let's select a subset of the data. This corresponds to the states Georgia, Hawaii, and Idaho. As soon as we select this range, we can see that in the bottom right corner of the range is a little icon. And when we click on that icon, a menu opens up. Different aspects of this data can be controlled from here, including the formatting, charts, totals, tables, and sparklines. Let's click on the Charts tab. There you can see that there are various chart types available. These are the recommended chart types recommended by Excel. That is, Excel has analyzed this data and come up with these recommendations. If we decide that we'd like to make up our own mind, we just click on the More icon at the extreme right. This brings up the Insert Chart dialog, which has recommended charts as well as all charts. Let's switch over to all charts, and there from the category titled Column Charts, that's visible over on the left, let's try out a few different alternative formats. As before, we can preview these formats simply by hovering over them, and these different formats are available from the dialog over on the right. We decide pretty quickly that a clustered column chart would work just fine for us, so we hit OK, and that clustered column chart gets added to our worksheet. You can see that there's no chart title. There are individual columns for Georgia, Hawaii, and Idaho. Charts can be copied and pasted using Ctrl+C and Ctrl+V, and using those keystrokes, we have duplicated our chart. So we now have two charts containing the exact same data. Let's select the lower of those two charts and then click on Chart Design up top. We will then change the chart type. All that we are going to do is to go with the second chart type that's available in the list of clustered column charts, and then we hit OK, and instantaneously we can see that the representation has changed. Now on the x-axis, instead of having the years, we have the states, and we now have bars which correspond to each year. These two graphs placed one above the other tell us why Excel is such a great tool for slicing and dicing data. The graph up top has a set of bars, that's a cluster of bars for each year. And in that way, we can see for a given year how the production in Georgia, Hawaii, and Idaho contrasted. That chart up above is not great if we'd like to see how production in a given state has varied over time. But that's exactly where the second chart comes in handy. These different types of graphs yield different types of insights. The chart up above, for instance, makes it easy to see that in the year 2008, Georgia had production significantly higher than Idaho, but that was reversed in 2009 when Idaho's production was a lot higher. On the other hand, the second graph helps us to see that production in Georgia in 2008 was a lot higher than 2007 and then fell drastically in 2009. In workbooks which are going to contain a large number of visualizations, it's also helpful to be able to hide and unhide groups of graphs. So we've now selected the columns I through N, and then we click on the data menu item up top. We navigate to the outline group towards the right, and there we choose the group option. Doing this gives a nice convenient little button up top which can be used to either expand or collapse the contents of columns I through N. And in this way, it's easy for us to add many more visualizations into the same workbook without all of them appearing on top of each other and getting in each other's way. So far, we were working with clustered bar charts. Let's now work with stacked bar charts. In order to do this, we again select the data for states Georgia, Hawaii, and Idaho. We again click on the little button in the bottom right of that cell selection, and then we navigate to the Charts tab. Once again, we ignore Microsoft's recommendations and click on the More button towards the right. This opens up the Insert Chart dialog. We click on All Charts, and once again, we switch to the column group of charts. This time, however, we click on the second icon in the top right. That second icon corresponds to stacked column charts rather than to clustered column charts. You can see the difference between them from their preview icons. As you can see, groups of bars will now be stacked one on top of the other rather than being one next to the other. Here, for instance, we have one bar per year, and within that we have stacked sub-bars for the three states. Stacked column charts are great for viewing parts of a whole. Let's go ahead and hit OK, and a stacked chart is added to our workbook. As before, we are going to copy this chart and then paste it so that we have a duplicate. So we now have two charts, one above the other. These are identical. Once again, for the second chart, we are going to change the chart type. And we are going to do this so that we end up slicing our data in a different way. Click on Chart Design up top. Click on the Change Chart Type button towards the right. And then go with the second type of stacked column chart. Once again, this is going to slice and dice our data by state rather than by year. So we hit OK. As before, we have the two charts, one above the other. As before, the one on top has groups for each year. The one below has groups for each state. The difference, however, is that both of these charts are stacked rather than clustered. And that's why in the chart up above, we have one bar for each year. And in the chart down below, we have one bar for each state. The chart up above yields insights about the total production by year. We can see, for instance, that total production across all three of these states rose from 2007 to 2008, then fell in 2009 and 10 before recovering in the years 2011 and 12. This pattern of an increase from 2008 versus 2007 was already visible in Georgia. It's less pronounced when we aggregate the data across all states, but it still exists. A different kind of insight is apparent from the graph down below. By looking at any individual year, you can't really tell whether over this entire period of study, the production in Georgia has been greater or less than the production in Idaho. But the second stacked chart here clearly tells us that over this period of study, the total production in Idaho was ever so slightly greater than that in Georgia. Note that both of these charts have absolute numbers on the y-axis. And that's why we can see, for instance, that production in Idaho across all of these years has totaled about 200 million pounds, whereas that in Georgia has totaled just under 200 million pounds. As you can see from this example, stacked and clustered bar charts have different kinds of insights that they make available. In any case, let's continue to be organized in our workbook. So we are going to select the columns P through U and then use the outline menu in order to group these columns together. Once again, we get a nice set of handles up top. We can use that in order to collapse the display of these graphs as well. The previous demo was all about the difference between clustered and stacked bar charts. Let's now explore a few different types of stacked bar charts. We begin by just hitting Ctrl V. At the end of the previous demo, we had copied a chart and then pasted it, and as a result, we still have that chart in our clipboard. So at this point, when we hit the keystroke combination Ctrl V, we get the same stacked bar chart pasted into our workbook. You can see this stacked bar chart on screen now, and one of the properties of this chart, which we already remarked upon, was that the y-axis contains absolute values. This kind of stacked bar chart is great because it tells us how the absolute honey production varied by year. However, this kind of chart also has an accompanying weakness. It's rather hard to see how the share of each of these three states has varied over time. That would be a lot easier to view if the y-axis did not have absolute numbers in millions of pounds and instead always summed up to 100%. So let's see how Excel makes this very easy to do. As before, we've clicked on the Change Chart Type button over on the top right. This opens up the Change Chart Type dialog, and you can see that the current chart type is set to stack column. In the little preview pane down below, we can see that the y-axis has the absolute numbers we were just talking about. Let's change the chart type. So we'll click on the third icon from the left, and this is the 100% stacked column. Note the difference between a stacked column and a 100% stacked column lies in the way in which the y-axis is represented. And if we just magnify that preview a little bit, we can see that the y-axis extends from 0 to 100%, and all of the bars have the same height. This way, we can no longer get information about the absolute or total production in each year. But we can get other valuable insights. In order to get those, let's hit OK and insert this chart into our workbook. Before we get to interpreting these charts, let's follow our usual practice of hitting Ctrl C and then Ctrl V, and then changing the chart type of the second chart so that we are slicing and dicing our data by state rather than by year. So we've selected the second chart, we've clicked on chart design, change chart type. We are still in the 100% stacked column dialog, but now we go with the second preview option down below. When we do this, our second chart has one bar per state. Within this, there are individual stacked bars for each year. Again, the y-axis ranges from 0 to 100%, and so these two charts both include bars all of equal height. 100% stacked bar charts give us great insights about composition and parts of the whole, and specifically about how those parts of the whole have varied over time. The chart on top, for instance, makes it quite clear that in 2009, Idaho had a particularly good year relative to Georgia, because in this particular year, we can see that the gray bar corresponding to Idaho extended almost down to the 40% mark. This in turn meant that in this particular year, production in Georgia and Hawaii was a lot less than 50%. In the other years, you can see that the orange bar for Hawaii, which is the smallest, tends to be around the 50% mark. This was not true in 2009. If we keep in mind that 2008 was the year of the global financial crisis and an associated boom and bust cycle in commodities, we could infer from this data that production in Georgia is more volatile. It rose more quickly during the boom years, fell more quickly, and then also recovered. A similar pattern is also visible in the chart down below. If we look at the one bar for Georgia, we can see that a large proportion of that production is in the lowermost two bars, the blue and the orange stacked bars, which correspond to the years 2007 and 2008. In the state of Hawaii, on the other hand, the different bars are almost equal in width. On the basis of the second chart, it would seem that production in Hawaii is not very volatile. It does not vary a whole lot from one year to the next, and that's why the contribution of each year to the total production in Hawaii has been relatively constant. Of course, these are all hypotheses which then could be confirmed or disproved by further investigation, but as you can tell, these two 100% stacked column charts have given us yet a further different type of insight. Let's keep going with our usual procedure. We select columns W through AB, get to the data menu, outline, and then group. This will give us a nice set of hide and unhide buttons up top. So we hide all of those columns, hit Ctrl V so that we paste in the same base chart which we had made use of previously, change chart type, and this time we are going to go with a 3D clustered column chart. Please note how the name of this particular chart type is visible in the center of the All Charts dialog. The 3D clustered column chart is very similar to the ordinary clustered column chart that we worked with previously. Of course, the difference is in the 3D nature of all of the bars, but the types of insights that we get from this data is similar. This particular 3D clustered column chart has individual groups for each state. We can change that so that we now have groups for each year. And that's going to be done in the usual fashion. We paste in the chart and then we change chart type and we go with the second item within the heading 3D clustered column chart. As before, this gives us a second chart with a slightly different representation of the data. And in similar fashion, we can go ahead and construct 3D versions of all of the charts that we already worked with. We've just created a pair of 3D clustered column charts. We can also create 3D stacked column charts. You can see this on screen now. 3D stacked column charts are similar to ordinary stacked column charts other than the 3D representation of the data. Because these steps are very similar to each other and because all of these charts yield similar insights, we will not discuss each step in detail. But as you can see, we now have 3D stacked column charts which divvy up the data by year as well as by state. Then just like we had 100% stacked column charts, we have 3D 100% stacked column charts. The advantage of these is that now the y-axis ranges from 0 to 100%. The disadvantage is that we no longer get absolute values on the y-axis. So the pros and cons of 3D 100% stacked column charts are identical to those of 100% stacked column charts. We now have a good sense of the different column chart types. In the demo coming up ahead, we are going to change our focus just a little bit and see how we can customize the appearance of individual data points or data series within these chart types. Let's pick up right from where we left off at the end of the last demo. So far, we have experimented with many different types of column charts. We saw that there is a difference between the kinds of insights that we get from clustered column charts and stacked column charts. We then explored a variant of the stacked column chart, which is the 100% stacked column chart. 100% stacked column charts have y-axis values ranging between 0 and 100%, and they are great for viewing parts of a whole compositions. On the other hand, ordinary stacked column charts are great for viewing absolute trends in quantities such as production. After exploring these different types of column charts, we then recreated each type in a 3D version. Those versions were not very different in terms of their semantics or their meaning, but they did give a nice look and feel to the chart. For instance, on screen now, you can see 3D 100% stacked column charts. The one above has one stacked set of bars per state. The one below has one stack per year. What's interesting is that in both of these cases, the y-axis extends from 0 to 100%. Let's now turn our attention to formatting series in these column charts, but along the way we'll experiment with yet another kind of column chart. As usual, we've pasted in the chart that we've been working with all along. We click on chart design, change chart type, and then we navigate to the right, and there we find the column type 3D column. This is the simplest 3D chart. So we hit OK and pop this into our spreadsheet. This is a rather hard chart to make sense of. Along the y-axis, we have honey production. Along the x-axis, we have the year. But then along the z-axis, we have the state. And that particular form of representing the data means that the columns corresponding to the states are stacked one in front of the other. Right in front, that's the first set of columns are blue, those correspond to production in Georgia. However, that's then followed by the orange bars for Hawaii, and those are partially obscured by the bars for Georgia. And at the very bottom, we have the gray bars for Idaho. A problem with this 3D column chart is that the bars all obscure each other, and this is why this is a great chart type with which to customize the markers and other properties of the series. With the default representation, it's almost impossible to make sense of this data. Before we start that customization, let's as usual slice and dice our data by year as well as by state. So again, we paste in the chart, navigate to chart design, change chart type. Once again, we go with the 3D column type, but we go with the second template this time around. This chart continues to have the honey production along the Y or the vertical axis, but on the X axis, we now have the states, and it's even harder to interpret this graph because we have a large number of tiers of bars along the Z axis. Each tier corresponds to a particular year. So this chart is maybe the hardest to understand of every chart that we have constructed so far. Let's see if we can improve upon that. So we start by hitting OK so that this chart gets added into our worksheet, and then we expand this chart. We can see here that the bars corresponding to Idaho are relatively easy to see. That's also true for the bars for Georgia, but the bars for Hawaii are almost entirely obscured by other bars in this chart. In any case, let's go ahead and select the series for 2008. In order to see how this is done, please divert your attention away from the chart and towards the highlighted data cells in the top left. Currently, we've selected all of the data cells that are included within the chart. Well, we can change that. We right click on the chart and choose the Format Data Series option. In the little drop down which you see down below, we pick the series prod 2008. And when we do this, the highlighting in the data cells on the top left changes as well. Notice how only cells C2 through C5 have been highlighted. And as soon as we select this series, a dialog appears on the right with various controls to format data series. To begin with, let's use the slider to adjust the gap depth. Notice that this allows us to make the bars thinner in the Z dimension, and as a result of that, the bars in front obscure the ones behind a little less. The depth and width settings are going to affect all series, not only the data for 2008. This is something important for you to keep in mind. So let's move the gap depth slider to the extreme left and the extreme right, and we can see how the appearance of the bars changes. The gap depth controlled the extent of each bar along the z-axis. The gap width controls the bar's extent along the x-axis. So as we slide that to the extreme left and the extreme right, the bars become very broad or very narrow. Increasing the gap width certainly has the effect of giving more screen real estate to the Hawaii bars, but we still need to do a bit better. So let's try and change the column shape instead. The default column shape is box, but let's try a few different versions such as full pyramid. You can see that now all of the data for 2008 is represented by a pyramid. We can also try partial pyramid, cylinder, full cone, or partial cone. It's worth noting that column shape choices only affect the selected data series, and that's a difference between the column shape and the gap depth and gap width. We saw that the gap depth and gap width apply to all series, but our changes to column shape are only being applied to the year 2008, which is the data series that we selected. We've now tweaked the series in our 3D column graph to a large extent. Let's start modifying other aspects of the data. We've now changed to a setting related to the shadows. We begin by tweaking the transparency of these bars. You can see that we can also tweak the size, blur, angle, and distance. We can also use the presets option in order to give different types of shadows. Here we are going with a choice of perspective shadows. We can also dial various different settings here. So we are tweaking the size, the blur. You can see how the shadow changes as we modify these properties, the angle of the lighting, and the distance between the bars. It can get quite mesmerizing to make all of these changes and tweaks to the appearance of your graph. But what happens if you decide at some point that your graph does not look the way you'd like it to? And what if you'd like to undo all of the changes you just made? This is a really common use case, and in such cases, we should click on the undo button at the very top left of our screen. There's a little drop down next to that undo icon, and when we click on the drop down, we get a list. That list has all of the individual changes that we just made. We can use our mouse in order to select the items which we wish to undo. So we select all of the items right down, but not including the resize object. These operations have names such as shadow, change series, and so on. We do not include the resize object operation. And when we do this, at the very bottom of that list, we see a little button which tells us undo 26 actions. We click on that button and we are back to square one. In other words, we are back to a resized and freshly inserted 3D column chart. This gets us to the end of our exploration of column charts. You can see that these column charts came in many different flavors. We created these column charts in pairs, and then for each pair, we would group the columns containing those charts and then hide and unhide those controls. That was a great way of keeping our workbook relatively organized. To quickly recap, some of the types of column charts that we worked with included clustered column charts, stacked column charts, 100% stacked column charts, and then 3D variants of each of these categories. And we rounded off this conversation by working with 3D column charts in which the bars extended into the z-axis. That was a type of column chart that was a little hard to read, and that's where we spent some time customizing the appearance, such as the depth and the width properties. We made a number of minute tweaks to the appearance of the 3D column chart and then saw how we can undo a very specific number of operations by using the undo button on the top left corner of the Excel window. So far, we've been using the terms bar chart and column chart interchangeably. There is a good deal of justification for this. In general, column charts can be thought of as a subset of bar charts. In Excel, however, these terms have slightly different meanings. A column chart has vertical bars, a bar chart has horizontal bars. That's the main difference. We are now going to turn our attention from Excel column charts to Excel bar charts. The data that we're going to use is on screen now. It's the same data we've been working with so far. Once again, we select the data in cells A2 through G5. These correspond to the states Georgia, Hawaii, and Idaho, and their honey production in the years 2007 through 2012. As before, when we select this range, we see a little icon at the bottom right of the selection, and when we click on that, we can customize this range in different ways. We are interested in the chart functionality, and so we switch from the default formatting tab to the charts tab. We performed this operation many times before. We click on more and go into the insert chart dialog. There we switch from recommended charts to all charts, and then we navigate down on the left and pick bar charts. As you can see, the column icon has vertical bars, the bar icon has horizontal bars. So we click on bar on the left, and clustered bar is the first chart type that appears in the pane on the right. Clustered bar charts are very similar to clustered column charts. The preview confirms this. We go ahead and hit OK, and a clustered bar chart gets added to our workbook. Along the x-axis, we have honey production. Along the y-axis, we have years. And for each year, we have 3 bars corresponding to Idaho, Hawaii, and Georgia. Next up, we are going to expand our selection of data and then see how data in a chart can be filtered. To get started, let's click on the Select Data button on the top right and then use the mouse in order to change the data source. You can see that we've now selected all of the cells A2 through G7. As soon as we do this, we can see that in the list of legend entries over at the bottom left, we now have all states rather than just Georgia, Hawaii, and Idaho. We also have Virginia and Washington in there. The axis labels over on the bottom right remain unchanged. These continue to be prod 2007 down through prod 2012. We hit OK, and the new and expanded bar chart appears in our workbook. This is where we are now going to change things around. We are now going to click on the sort and filter option, which is way over on the top right. Please note that this sort and filter button is present inside the home menu item. You can see the home menu item towards the top left, and we know it's highlighted from the green rectangle below the word home. When we click on sort and filter, different options appear. We are going to go with the filter option. We can now see that little drop downs appear next to each of the column headings in the cells A2 through G2. Let's click on the little drop down for states, and there we'll use that drop down in order to only select the data for the states Virginia and Washington. So we uncheck the data for the rows we've worked with so far, Georgia, Hawaii, and Idaho. When we hit OK, the chart changes. We only now have bars for Washington and Virginia. So what we learn from this little demo is that there is a link between the sort and filter functionality and a chart which has been constructed using the filtered or sorted data. Let's now undo the filter operation. In order to do this, we click on the states dropdown and we click on the select all choice. That's the first option there. That has the effect of checking all of the checkboxes. And now when we hit OK, we are back to our fairly cluttered graph where we have individual bars for each state. We can perform similar operations for the other columns as well. Let's try and attempt a similar operation on the production for 2007. When we scroll down through the list of values in the checkboxes down below, we see that these are all numeric values, and so it doesn't make a whole lot of sense to select or unselect these values. Instead, let's try and click on the sort button right up top. We are going to sort from smallest to largest, but in order to understand what exactly this operation is going to accomplish, let's first turn our attention back to the chart. Notice that we have on the y-axis the years in order from 2007 at the bottom, 2012 up top. Then for each year, we have individual bars corresponding to the states. Those bars are simply in the order in which the states appear in the range. Note that this is the order from before we click on that button, sort smallest to largest, and that's why we have the bars for Washington followed by Virginia, Idaho, Hawaii, and Georgia in that order. However, once we click to sort by smallest to largest on production in 2007, something pretty interesting happens. Let's first understand the sorting of our data. The first row, that's row number 3, now corresponds to Virginia, and the last row, that's row 7, corresponds to Idaho. And that's because in 2007, that's column B, Virginia had the smallest honey production and Idaho had the largest. Now, if we turn our attention to the chart, we can see that on the y-axis, we still have the years arranged in order from 2012 to 2007. So no change in the order of the years on the y-axis. However, if we turn our attention to the bars for each year, well, now we can see that those bars are in the same order as the production for 2007. So we first have a bar for Idaho, then comes Georgia, then Washington, Hawaii, and Virginia. This order is maintained for all years. It's even maintained for the year of 2012. In 2012, you can see that the largest producer was not Idaho, it was Georgia. We can see that by comparing the contents of cells G6 and G7. And so we can see in this way that when we sort one particular column from smallest to largest, it has a fairly interesting effect on our bar chart. Let's confirm this finding by repeating the experiment. This time we'll sort on production in 2008 and we will go with the sort from largest to smallest. So the first row, that's row 3, will correspond to Georgia and the last will correspond to Virginia. When we turn our attention to the chart, we can see that the bars appear in the same order. Virginia has the first bar, and then comes Hawaii, Washington, Idaho, and Georgia in that order. In general, the bars in the bar chart appear in a reverse order to the rows in the Excel data range. We've now understood the effects of sorting and filtering our data. Let's eliminate the sort and filter operation. To do this, we click on that sort and filter button over on the top right, and there we choose the filter option. This simply eliminates all of the drop downs that we had in our row headers. In this demo, we will turn our attention away from sort and filter operations and now see how we can customize various elements of a bar chart. To begin with, let's simply select the bar chart that we've already created. We do this by simply clicking on the bar chart. As soon as we do this, the underlying data is also highlighted, as you can see in the cells over on the top left of the Excel worksheet. So this is worth keeping in mind. If you have a workbook which has many different charts, if you just click on a chart, the corresponding data will be highlighted. Let's now turn our attention to the three icons to the right of our chart. There's a plus icon, a little paintbrush, and then a filter. Let's start by clicking on that plus icon. This allows us to customize various chart elements. Notice how there are checkboxes for us to turn specific elements on or off. Simply hovering over an item gives us a preview. Here, for instance, we hover over data labels and the appearance of our chart becomes so cluttered that we quickly navigate away. And in similar fashion, we can experiment with turning data table on or off as well. We can also use the Axis Titles menu in order to pick which specific axis we are interested in editing and then type out whatever string strikes our fancy. Here, for instance, we've labeled the y-axis year and the x-axis honey produced in pounds. Next, we click on a data bar. This one happens to belong to Washington, and so we've effectively selected the data series for Washington. Then right-click and choose the Format Data Series option. This brings up the familiar Format Data Series dialog over on the right. Let's tweak some of the controls here. For instance, we can change the series overlap so that the bars all overlap with each other perfectly. This might look like a stacked bar chart, but it's not. And because in a stacked bar chart, all of the bars appear one after the other, whereas here they merely overlap. In any case, let's also experiment with the gap width. We can use that in order to tweak how much white space appears between different bars for the same cluster. Remember that all of these operations were being performed after clicking on a bar for Washington, and we can now control whether that data series appears on a primary or a secondary axis by using the plot series on radio buttons. The default option is primary axis, but we can just click on the secondary axis and you can now see that only the bar for Washington has its scale above the bar chart rather than below. We quickly decide that this is not quite what we had in mind, so we go back to primary axis. Next, let's click anywhere on the y-axis, and when we do this, the dialog over on the right changes. Instead of saying Format Data Series, it's now the Format Axis dialog. We can now use this to customize the appearance of the axes, for example, the vertical alignment, the text direction, the custom angle at which the text appears. Similarly, we can click on the x-axis. It's still the format axis dialog on the right, but now all of the changes that we are going to make will apply to the x-axis rather than to the y-axis. Let's open up the axis options. There we experiment with different values of the minimum and maximum bounds. Currently, the maximum bound is set to 5 million. We can also try minimum bounds and see how the appearance of the x-axis changes. It's also possible to control the units, both the major and the minor units. By default, the major unit on the x-axis is 1 million and the minor unit is 200,000 pounds. Let's change this to something very different like 100, and you can now see that all of the labels overlap with each other and the x-axis is completely garbled. So we quickly undo that little change. And to do so, we just need to click on the reset button. That reset button is a great way to undo any change which didn't work quite as expected. Next, let's scroll down a little bit and adjust the units. You can see that the display units are currently set to none, but other choices in the drop-down include hundreds, thousands, as well as other powers of 10. Notice how those powers of 10 which have specific names such as millions, billions, or trillions are going to appear as strings. Where there isn't a specific name, we just have the decimal version. Below this, we have checkboxes which can be used in order to set our data to a logarithmic scale, and we can also specify the base. If we'd like to display our data in binary format, we just change the base to 2 after having checked the logarithmic scale checkbox. Notice how when we do this, the x-axis has various powers of 2, 1, 8, 64, 512, 4096, and so on. Let's undo that change because powers of 10 are just a lot more intuitive. There's also a little checkbox down below which can be used to display the values in reverse order. Notice how when we check this box, our graph extends from right to left. So on the extreme right, we have the y-axis labels, and then the bars extend towards the left. At this point, we still have the logarithmic scale checkbox marked along with the base 10, and that's why the x-axis extends from right to left, and the x-axis values are 1, 10, 100, 1000, 10,000, and so on. Let's undo all of those changes. So we uncheck the logarithmic scale and the reverse order, and then let's turn our attention to some of the axis options. We do this by clicking on the y-axis and then on the format axis dialog over on the right, clicking on the little bar chart icon. There are cards here for axis options, tick marks, labels, and number representations. Let's expand the card for axis options. There we can control the axis type, where the ticks ought to appear, as well as the axis position. Let's try and tweak some of these settings. We change the axis type so that it's a text axis rather than a date axis. There isn't any discernible change. Then let's move the horizontal axis crosses so that they appear at category number 5. The x-axis ticks now appear next to the production data for 2010. This isn't quite what we had in mind, so once again we are going to undo this change. We try the at maximum category option that just moves the ticks right to the very top of the bar chart, and finally we go back to the automatic choice. We've now gotten a pretty good sense of how we can format individual data series and also format the axis in our bar chart. In the demo coming up ahead, we will run through some of the variants of the bar chart, such as stacked bar charts, clustered bar charts, 100% stacked bar charts, and their 3D variants. These will be analogous to the column chart types that we had worked with in a previous demo. This video is devoted to the 6 types of bar charts. Let's first cycle through those 6 types. We'll then come back to them and discuss them in detail. On screen now is the clustered bar chart. This is the bar chart that we constructed in the previous demo. In the preview pane, you can see that along the x-axis we have honey production, along the y-axis we have years, and then for each year we have a cluster of bars with 1 bar per state. Note that there are 2 different templates which you can see on screen now. In the one on the left, we have clusters for each year and bars for each state. In the one on the right, the clusters and the bars are reversed. The next type of bar chart is a stacked bar chart. Once again, there are 2 variants, but the big difference here is that now the bars are stacked one on top of each other, and so they extend out horizontally rather than being placed next to each other. The x-axis has total honey production in pounds, and this means that we have absolute numbers rather than percentages along that x-axis. So in a stacked bar chart, the bars extend out to different lengths. This makes it great for spotting trends in production over time, but not quite as good in order to compare composition of total production within each year. That's where the close cousin of the stacked bar chart comes in handy. That close cousin is called the 100% stacked bar chart. You can see on screen now that in a 100% stacked bar chart, the x-axis extends from 0 to 100%, and consequently all of the bars are of exactly the same length. That does it for the 100% stacked bar chart. You can see from the icons up top that as we move from left to right, the first 3 icons correspond to 2-dimensional graphs and the next 3 correspond to 3-dimensional graphs. If you look really closely, you'll see that the 3 3-dimensional graphs are equivalent to the 3 2-dimensional graphs. The only difference lies in the extra dimension in the visualization. So the first of the 3D bar charts is the 3D clustered bar, and this of course is a close analog to the clustered bar. Next up is the 3D stacked bar. As you might imagine, this is the close cousin of the ordinary stacked bar. And then if we move to the last of our 6 chart types, this is the 3D 100% stacked bar chart. Once again, there are 6 bar chart types. These are the same 6 types which we encountered while working with column charts. The only difference between bar charts and column charts in Excel is that in column charts, the bars extend vertically. In bar charts, the bars extend horizontally. Now that we've taken stock of the different chart types, let's go ahead and get started. Right now on screen, we have a clustered bar chart. This clustered bar chart has the year on the y-axis, and then it has honey production in each state on the x-axis. We have clusters, that is groups of bars for each year, and we have one bar for each state. Let's now change that around. We navigate into the chart design menu, click on the change chart type button up on the top right, and we pick the second of the clustered bar templates. This has the effect of interchanging the bars and the clusters. So now when we hit OK, we still have the honey production on the x-axis, but now on the y-axis we no longer have the year, instead we have the state. So we have one cluster for each state, and then within each cluster we have individual bars corresponding to the years. That does it for the two variants of the clustered bar chart. Let's navigate back into the change chart type menu, and there let's click on the second icon from the left, and this is going to give us a stacked bar chart. As before, there are two types of stacked bar charts. We click on the first template, the one over on the left. This is going to have one stacked bar for each state, within which we are going to have individual sub bars corresponding to the years. Let's hit OK. This stacked bar chart gets added to our workbook. As discussed before, this is going to yield different types of insights. We can see here, for instance, how for a particular state, such as say Washington, the production varied by year. Hovering over the individual bars shows the tooltips along with the series. You can see that these series tooltips include the values prod 2012, 2011, and so on. As before, we can use the change chart type menu. We stay with the stacked bar type, but we now click on the second template, the one on the right. And when we do this, we are now going to get individual bars, that is stacked bars, corresponding to each year. And then within each year, we are going to have sub bars corresponding to each state. We hit OK, and we can see that the change chart type appears in our Excel workbook. The x-axis is still in absolute numbers, and these absolute numbers represent the total honey production. These numbers get pretty large, and this helps us to identify time trends. We can see, for instance, that the year with the highest production in this period was 2008. Let's try an interesting experiment. We right-click on the data for the state of Washington, and we choose the Format Data Series option. And then we tweak the values of the series overlap and the gap width. And by doing so, we get an appearance which makes our chart look a little bit like a waterfall chart. This is an interesting way of tweaking the appearance of a chart. You can see that this is still a stacked chart, but now the different states appear in different horizontal lines. We'll come back to waterfall charts in a subsequent demo, but for now let's move on to the third type of bar chart. This was a stacked bar. We are now going to click on the third icon from the left. That's a 100% stacked bar. We've already discussed the difference between a stacked bar and a 100% stacked bar. Here, the x-axis is going to have values which range from 0 to 100%. As usual, there are two templates. Let's choose one of these and hit OK. This causes the addition of a 100% stacked bar chart to our workbook. Note how the x-axis has ticks from 0% to 100% at intervals of 10%. Notice how on the y-axis we have one stacked bar for each year. The 100% stacked bar chart is great for identifying changes in composition over time. It does not give information about total production trends, but it does give useful information about the composition. We also get a sense of the variability of production in these different states. For instance, the yellow bars corresponding to Hawaii don't vary a whole lot. However, the length of the orange, blue, and gray bars do vary a whole lot, and that's especially true for the orange bars representing Idaho's production. We can infer from this that production in the states of Georgia and Idaho is relatively volatile. It increases relatively rapidly in some years and decreases rapidly in others. 100% stacked bars allow us to perform the same operations as a regular bar chart. So here we've selected the bars for Washington, and then we've tweaked those data series using the series overlap and gap width in order to get something that looks like a waterfall chart. As usual, there are two templates of 100% stacked bar charts. We can toggle between the two by using the change chart type button on the top right. Also notice how the preview in those templates maintains the properties which we just set using the series overlap and the gap width. So once again, we change template from the one on the left to the one on the right. And when we hit OK, we can see that our x-axis remains the percentage of honey production in that year, but we now have one set of stacked bars for each state. This particular representation makes it clear why, even though this graph looks like a waterfall chart, it's not truly a waterfall chart. And that's because waterfall charts have additive bars. Those bars add up in terms of their heights so that you start at a low level and end at a high level. That's not the case here, where on the x-axis we merely have the state. So it doesn't make any sense to add the heights of these adjacent bars. So we use the format data series options in order to reset the appearance and then go back to the change chart type button and move on to the fourth chart type, and that's the 3D clustered bar. This is merely a 3D representation of the ordinary clustered bar. You can see that on the y-axis we have the state, on the x-axis we have total honey production, and then within each cluster we have groups of bars corresponding to the years. Notice that the tooltip that we currently see on screen contains the words back wall. And if we right click on the chart, we have an option which allows us to format walls. In any 3D chart, we have walls which correspond to every pair of axes. So for instance, we are going to have an XY wall, a YZ wall, and an XZ wall. We can individually format each of those three walls. And you can see from the format walls dialog over on the right that we can control the fill and the border of each of those three walls. With 3D charts, it's also useful to play around with the gap depth and the gap width in order to change the appearance of the different points. We can also change the column shape. Some of the available choices are box, full pyramid, partial pyramid, cylinder, full cone, partial cone, and so on. Exactly as before, we can use the change chart type in order to switch the variables that have been clustered. We switch from the variant on the left to the one on the right, and we now have the year of production on the y-axis, and within that we have individual bars for each state. We are now done with 4 out of 6 types of bar charts. Let's open up the change chart type menu and go to the fifth, and that's the 3D stacked bar. The 3D stacked bar chart is simply a 3-dimensional version of the ordinary or the 2-dimensional stacked bar, so we won't spend a whole lot of time on it. We have individual stacked bars for each year, within which we have individual mini bars corresponding to each state. Let's select the mini bars for Hawaii and then right click and choose the Format Data Series option. The Format Data Series dialog appears on the right. We can use this to control the gap depth and gap width. We can also use this to change column shape. Notice that even though we've only selected the series for Hawaii, our choices of column shape are going to affect all of the other states as well. And that's clearly because in a stacked bar chart, unlike in a clustered bar chart, all of the elements must have the same column shape. We continue with various experiments to alter the appearance of these columns. Once we've gotten a good hang of this, we click on the Change Chart Type button on the top right. This is going to be useful in order to interchange the states and the years. We can still see that on the x-axis we have values which are in absolute units, that's in absolute pounds of honey production, and that's because this is a 3D stacked bar chart. Let's change this. We are now going to move to a 3D 100% stacked bar chart so that the x-axis is always going to extend between 0 and 100%. This is also the sixth and final variant of the bar chart that we are going to cover in this demo. We examine the preview and then hit OK, and this 3D 100% stacked bar chart gets added into our Excel workbook. We've reached the end of our exploration of bar charts. In the demos coming up ahead, we'll turn our attention to histograms, line charts, and other more interesting visualizations built in Excel. In this demo, we are going to turn our attention from bar charts to histograms. Histograms are a special kind of visualization. A histogram looks quite a bit like a bar chart, or in the Excel parlance, more like a column chart, but the data contained within a histogram is quite different. And that's because a histogram has bars for each range of values in our input data. Let's quickly jump into an example to make this more clear. On screen now is a dataset which contains information about diamond prices. We have 3 columns: the carats, the depth, and the price. So these are different attributes of a diamond. Each row corresponds to one diamond. Given a dataset like this one with a large number of rows, it's really common to want to answer questions like how many diamonds are priced below $100? How many are priced between $100 and $200? Questions like this can be answered very easily using a histogram. Let's see how this can be done. We start by selecting all of the data. As an aside, notice that when we do so, some descriptive statistics are displayed in the very bottom lower right corner of the Excel window. So you can see that the average of all of these selected numbers is 1331.782356. We also have a count of the number of data items as well as their sum. In any case, coming back to the histogram visualization, having selected all of our data, we now click on the Insert menu item up top. When we do this, all of the other menu items displayed down below change. We navigate into the section titled Charts. We click on the little down arrow next to the image of a blue column chart. That little drop down gives us options related to histograms and box and whisker plots. Notice how there are two categories here, histograms as well as box and whisker plots. Within histograms, there are a couple of types. For now, let's go ahead and get started with the histogram. That's the simplest visualization in this list. We click on it and a histogram chart gets added to our worksheet. This histogram appears like a column chart. However, the entries along the x-axis seem a little different. Let's take a moment to understand the x-axis. Here, by default, the histogram has been computed on the first column, which is the number of carats that each diamond is. The labels along the x-axis are all intervals. So for instance, the first label is delimited by square brackets and it reads 0.2, 0.244. The square brackets indicate that this is a closed interval. A closed interval includes both its bounding limit points and is denoted with square brackets. The bar corresponding to this first closed interval is relatively short. You can see that the bar over on the extreme left ends somewhere between 0 and 1000. The height of this bar represents the number of rows, the number of diamonds in our data, where the number of carats is in that particular range of 0.2 to 0.244, both numbers included. Let's turn our attention to another much taller bar. Let's focus on the third bar from the left. This is the tallest bar, and as we can see from the y-axis, this tallest bar has a height of 8,000. This means that there are 8,000 diamonds which have the number of carats in the range corresponding to this bar. And what range is that? Well, if we look really closely down below, it seems like this range might correspond to the tick for the interval 0.332 to 0.376. But we can't really be sure because the alignment between the ticks along the x-axis and the bars in the histogram is not perfect. In a bit, we'll see how we can control the number of bins or bars in the histogram in more detail. But for now, let's just understand the form of this interval. Note that this interval 0.332 to 0.376 is a semi-closed interval, also known as a half-open interval. The opening value of this interval is connected to a regular parenthesis. However, the closing value is connected to a square bracket. So this interval includes the closing value of 0.376. That's why it's closed using a square bracket, but it does not include the opening value, that's 0.332. This is a histogram in which the heights correspond to the frequency ranges of the number of carats of each diamond in our dataset. The tallest bar is at 8,000. The second tallest bar is way over to the right, and that's just above 5,000. Note that we have a very small number of bars which extend all the way out to high carat values which are greater than 2. Importantly, this particular histogram does not look like many common histograms found in nature because it does not display a bell-shaped appearance. A bell shape is really common in histograms because it corresponds to normally distributed data. In just a moment, we are going to construct a histogram on the depth column, and that column will indeed have a bell-shaped appearance. But this particular data for the number of carats is not bell-shaped, and from this we can clearly see that this data is not normally distributed. Constructing a histogram is often important before performing other statistical tests or operations. Many of those statistical tests or operations have special cases depending on whether the data is normally distributed or not. Here we can see that this data series in column A is definitely not normally distributed, and that's something that we should keep in mind while performing statistical operations such as t-tests, ANOVA, and so on. In a dataset, the value which occurs most commonly is called the mode. In this data, we can see that there are a number of tall buckets which have approximately equal heights. And in this way, it seems like our data for the number of carrots, that's the data series in column A, is not unimodal, it's not bimodal either, and rather it has a tendency to be multimodal. It has many different values which occur extremely commonly. Of course, we can't make this statement with precision because here we are dealing not with unique values, but rather with ranges of values. But even so, this gives us a good hint that our data is multimodal. Now let's change the column on which we construct the histogram. Remember how this histogram was built? We simply selected all of the data in columns A through C and then chose the insert histogram option. To change this, let's click on the select data button up in the top right. That opens up a dialog where we have the chart data range up top, no change there. But then over on the bottom left, we have the legend entries corresponding to the series. And you can see that we've currently selected the series called caret. To edit this, let's click on the remove button. Caret column disappears from the list of series. We have the depth and the price columns remaining. Because we'd like to build our histogram on the depth, let's now select the price column and hit remove a second time. At the end of this process, there's only one series left in that box, and that's the depth in millimeters. If we now turn our attention to the histogram, we can see that it does indeed look a lot more like a bell-shaped curve. You can see that there are relatively taller bars in the middle of the histogram. The bars get shorter as we move away from the center on both sides, and this is a classic bell-shaped curve histogram. Let's again understand the labels on the x-axis. As usual, these represent intervals. The first interval is a closed interval, which means that it includes both of its endpoints, and that's why it's opened as well as closed with square brackets. All of the other intervals are half open because they are opened with ordinary parentheses but closed with square brackets. This means that they only include their ending points. The tallest intervals are clustered towards the center of the histogram, and that's where the depth in millimeters seems to be a little bit higher than 60 millimeters. It's a little hard to get a precise sense because again, there are a large number of bins here, but even so, it's clear that there is a concentration of tall bars just above 60 millimeters. And there's one bar which is clearly taller than all of the others. That bar has a height which is just above 4000, and it corresponds to a depth in millimeters of somewhere in the range of 61.7 to 62 millimeters. In just a moment, we are going to adjust the number of bars so that we can more clearly see these ranges, and that will make the bell shape even more prominent, but we'll get to that in the demo coming up ahead. We'll end this demo by noting that we have successfully created a histogram with a bell-shaped curve which represents normally distributed underlying data. In the previous demo, we concluded by building a histogram on the depth in millimeters of the diamonds in our dataset. That histogram is visible on screen now. It has a nice bell-shaped appearance. However, it still can be improved upon in various ways. For one, the bins are a little too granular. Each bin is very thin, the number of bins is very large, and consequently, it's hard to really get a sense of the number of points in a given bin. Let's see if we can fix this and also improve upon the histogram in other ways. We've started by clicking on the x-axis. We can see that from the bounding rectangle around all of the x-axis tick marks. This means that we have clicked on the horizontal axis. Now let's right-click, and from the right-click menu, let's choose the Format Axis option. Please note how there's a little dialog below the right-click menu which has a drop-down, and that drop-down currently has the horizontal axis selected. We could use that drop-down in order to modify the vertical axis instead. Once we choose the right-click option, the Format Axis dialog appears over on the right. We've worked with this many times before, but this is the first time we are making use of it with a histogram. Notice that when this Format Axis dialog opens up for a histogram, by default it displays controls on the number of bins. You can see that we can choose to bin our data in many different ways. The currently selected option is automatic, that's the second from the top, but other options there include by category, bin width, and number of bins. Those four options are all part of a set of radio buttons, so you can only choose one out of those four. Below that are two checkboxes for an overflow bin and an underflow bin. Let's go ahead and explore all of these, beginning with the bin width option. Let's start by checking the bin width option, and there's a little text box next to it where we can specify the width of each bin. By default, this value is set to 0.13. Where did that value come from? Well, that's the current automatic bin width. To confirm this, please look at the first tick over on the bottom left of the graph below the x-axis. You can see that that first tick extends from 43 to 43.13, and that's why that bin width is 0.13 currently. Let's see what happens if we edit that number and make it larger. In fact, much larger. We've now set the bin width to be 13, so that's 100 times larger than the automatic bin width. The effect of this is visible on screen now. All of the data appears in the bin 56 to 69. Notice that we now only have 3 bins, 43 through 56, 56 through 69, and 69 through 82. These values are taken based off of the smallest value in our dataset and then incremented using that bin width number. All of the values here are in the middle bin, that's 56 through 69, and that has a height which is greater than 50,000. Notice that the first interval is still completely closed, it's delimited by square brackets on both sides. The other two intervals are opened using regular parentheses and then closed using square brackets. The automatic choice of bin width, that was 0.13, was a little too fine. This choice of bin width, which is 13, is a little too coarse. We need something that's in between. Let's edit the bin width and set it to be equal to 1. And when we do this, we get a really nice, classically bell-shaped looking histogram. You can see that the tallest bar here corresponds to the range 61 through 62. That tallest bar has a height of 18,000, which means that there are 18,000 rows in our dataset where the depth lies between 61 and 62. The bell shape of this histogram arises because the taller bars are concentrated towards the center of the graph, and those correspond to measures of central tendency such as the mean, the median, and the mode. As we move away from the tallest bars in the center, the height of the bars reduces. This means that more extreme values are more uncommon. So very large or very small values are relatively uncommon. We can see that this distribution is roughly symmetric. It's not like there is a large number of outliers on any one side of the center, and this is referred to as a symmetric distribution. A normal distribution is perfectly symmetric. This distribution is not perfectly symmetric, but then that's also to be expected when constructing a histogram. This histogram does not actually give us probabilities. Just so you know, if you wanted to convert a histogram into a probability density function, you would use a technique known as kernel density estimation. It's a very commonly used technique in data analysis. So again, this histogram that you see on screen right now looks roughly like a normal distribution, but it does not give us the probability distribution of the underlying variable. Let's turn our attention back to the radio buttons for the bins. Right now, we've chosen to build the bins based on bin width, and we have specified a bin width of 1. That's why the text box for the bin width is enabled, it's not grayed out. Just below that is another radio button for the number of bins. If we selected this radio button, then a corresponding text box would be enabled. That would allow us to specify the number of bins. Right now, that text box is grayed out, but we can see that the value in there is set to 36. That's because when we specify a bin width of 1, the way Excel builds the histogram, we end up with 36 bins. Those 36 bins begin at 43 and end at 79. 79 minus 43 is 36, and that's why we see that number there. Let's click on the number of bins and let's edit that value. So we change the number of bins from 36 to 360. When we do this, we get a much more fine histogram. So there are way more bins than there previously were. But even so, we still have a very nice bell-shaped appearance. Notice that when we multiplied the number of bins by 10 by increasing it from 36 to 360, the bin width text box up above got divided by 10. It changed from 1 to 0.1. And we can also see from the x-axis of the histogram itself that our intervals now start from 43 and extend out in increments of 0.1. So for instance, the first interval is 43 to 43.1. And in similar fashion, we can try a few different combinations of the number of bins and see how the bin width automatically updates in each case. Then let's move on to the overflow and underflow bins. There are checkboxes for those just down below. We'll understand how overflow and underflow options work in just a moment, but before that, remember their use case. Remember why we would use these? The answer is in order to zoom in on specific portions of a histogram. That's a really common use case for the overflow and underflow bins. Notice how currently neither the overflow bin nor the underflow bin checkboxes have been checked, and that's why the corresponding text boxes are grayed out and not enabled. Let's change that. Let's check the overflow bin checkbox, and the corresponding text box has the value 66, and that's now enabled. As soon as we do this, a couple of things happen. Our histogram seems to move towards the right, and then if we look really closely, the rightmost bar over at the very right edge of our histogram now seems a little taller than the other surrounding bars. This is because we have checked the overflow bin checkbox and specified a value of 66. This means that any value which is greater than 66 is going to be placed in the bin that includes 66. And that's why there are additional values in that rightmost bin, and that's why its height has gone up. Next, let's understand why our histograms seem to move towards the right. Well, we effectively truncated our data on the right. We did not truncate our data on the left. And so we now have many more empty bins on the left. We have no empty bins at all over on the right. And that's why the histogram scrunched over towards the right. Now, if we uncheck the checkbox for the overflow bin, our histogram returns to its original appearance. It's back in the center and there's no sudden spike in the rightmost bin. Now let's experiment by checking the checkbox for the underflow bin, and we get a mirror image of what just happened a moment ago with the overflow bin. When we check the underflow bin, our data seems to move way over to the left, and there is now a spike in the leftmost bin. And if you look really closely, the label for that leftmost bin is also different. That label simply says less than or equal to 57. We now have a good understanding of how overflow and underflow bins work, so we can uncheck the underflow bin checkbox and return our histogram to its original shape. Notice once again that it moves back towards the center and the spike in height from the leftmost bin disappears. We are now almost done with our exploration of histograms, but let's just quickly see how we can customize the appearance of the data series. Note that all this while we've had the x-axis selected. We can see that because we have the bounding rectangles with the markers on the x-axis labels. Let's click outside those bounding rectangles and let's now click instead on the body of the histogram. You can now see that the markers no longer appear on the x-axis, they instead appear on the bins in the histogram. And you can also see that the dialog over on the right has changed. It no longer says Format Axis, it instead is titled Format Data Series. There's a slider in there for the gap width, and as we experiment with that slider, we can see that the thickness of the bars in our histogram changes. And in this way, we can customize the appearance of the data and of the individual bins, as well as controlling the overflow and underflow and other characteristics. This gets us to the end of our exploration of histograms. These are a powerful technique in exploratory data analysis. Histograms can be used to identify outliers in data. There's another kind of visualization which can be used for the same purpose, that's the box and whisker plot, which we will turn to in a subsequent demo. But before that, we'll cover some other more basic types of plots, starting with line charts. Come to the end of this course building column charts, bar charts, and histograms. This course started by introducing column and bar charts. Both of these chart types represent data for categorical variables using bars. In Excel, the term column chart is used for plots in which the bars are vertical, and the term bar chart is used for plots in which the bars are horizontal. We started this course by creating and differentiating between clustered and stacked column charts. We saw how stacked column charts are great for understanding how parts sum up to a whole, and how a variant, the 100% stacked column chart, represents those parts as percentages rather than absolute values. We then moved on to formatting and customizing bar and column charts. We worked with both 2D and 3D chart types, changing the width of the bars, sorting the bars, changing the overlap between the bars, increasing the size of the bars, and creating, inside the chart, a table containing all data being visualized. We then moved on to histograms, which use bars to represent frequency counts, that is, the frequency of values in various bins. As we learned, histograms effectively discretize a continuous variable by splitting the range of the variable into bins and then calculating how many data points lie in each bin. The number of points in each bin is represented as the height of the corresponding bar in the histogram. We saw how the bars in histograms approximate the probability density function of the variable, and as such are often arranged in a bell-shaped curve when the underlying data follows a normal distribution. We explored the use of the overflow bin and underflow bin options to truncate a histogram on either the right or the left side, as well as controlling the number of bins in the histogram. You are now ready to move on to the use of line charts and area charts to identify time trends in continuous variables. That's all in the course Visualizing Data using Line Charts and Area Charts, coming up next. Excel is the most popular spreadsheet program in the world, but it's also a lot more. It's a go-to choice for an incredible range of statistical, scientific, business, and analytics related use cases. From numerical optimization to printing specific views of workbooks, from hypothesis testing to dynamic validation of user input, Excel provides for it all. In this path, our focus is on the data visualization capabilities of Excel. There is a wide range of common built-in chart types available, and in addition, many other specialized chart types can be constructed by ingenious reuse of those built-in chart types. In this particular course, you begin by understanding the use of line charts to visualize time trends in data. Line charts are possibly the most common and popular type of visualization out there for displaying time series data. You then move on to formatting and customizing line charts, including adding data labels, customizing line color, and using gradient fills. You explore the use of trend lines and see how easy Excel makes it to add such trend lines in order to evaluate different types of regression models on data in a line chart. You then move on to area charts and stacked area charts, which are a very powerful type of visualization because they combine information about trends over time with information about composition. In this demo, we are going to turn our attention from histograms and switch topics to line charts. The data that we'll be using for this demo is on screen now. It's a lot simpler than the data we use for the histogram example, and that's because histograms require datasets with a large number of rows. Here, on the other hand, for our line chart, we are more interested in the actual aspects of customizing the line chart, and so our data can be relatively simple. We have rows which correspond to countries and columns which correspond to years. And the values for each intersection of a row and column is a movie budget. So for instance, the total budget of movies made in Australia in 2013 was $121 million. Line charts are especially handy for working with data in which the x-axis is time, and you'll see that in the example that we are constructing. Let's get started by selecting our data. We use the mouse in order to select the entire range A2 through E6. As usual, there's a little icon over at the bottom right. We click on that icon and a context-sensitive menu opens up. The default tab is formatting, but we are interested in the charts, so we click on the charts tab. As usual, there are several types of charts recommended by Excel. It's line charts that we are interested in, so we hover over the third icon from the left. A preview appears up top. That preview shows a line chart where we have the year labels, that's year 2013 through year 2016, and we have one line for each country. On the y-axis, we have the movie budgets in millions of dollars. The tooltip for the line chart is interesting as well, so let's read it really quickly. Excel is telling us that line charts make sense when we wish to show trends over time or across categories. We are also told that line charts are useful when the order of categories is important and when there are many data points. Please remember that this is still just the preview. We can now move over to the extreme right and click on the More button. This will bring up the Insert Chart dialog. As usual, there are recommended charts as well as all charts. Those are the two tabs up top. Let's change the tab by clicking on all charts, and then let's click on line from the list of visualizations over on the left. You can see at the very top of the center pane that there are now 7 icons. These correspond to 7 different types of line charts. Let's quickly understand what each of those types represents. The first line chart, the one that's currently visible in the preview pane down below, is an ordinary line chart. On the x-axis, we have the years. On the y-axis, we have the total budgets. The second line chart that corresponds to the second icon is a stacked line chart. A stacked line chart doesn't really make sense in our example. The third icon, which has a horizontal line and a single line chart below it, represents a 100% stacked line chart in which the y-axis extends from 0 to 100%. The fourth icon is an ordinary line chart with markers. The fifth is a stacked line chart with markers. The sixth is a 100% stacked line chart with markers. And the last seventh one is a 3D line chart. Because we've already experimented with stacked and 100% stacked charts in the context of bar charts as well as of column charts, we are not going to spend time on each of these variants with line charts. You already have a good sense of what these variants mean. Instead, let's insert an ordinary line chart and set about customizing it, focusing on the line chart specific elements. To begin with, we can see the preview of this ordinary line chart. It looks fine, it's exactly what we had in mind, so we now hit OK and the line chart gets added to our Excel workbook. Notice on the y-axis that we have the movie budgets, on the x-axis we have the years, and we have lines corresponding to Australia, Canada, France, and Japan. Let's say we decide that we do not want lines for all 4 countries. That's easy enough to change. Simply click on the Select Data button up top. Now, a dialog opens up with the chart data range. This includes data A2 through E6. We need not change that chart data range. All we need to do is to uncheck all of the series over on the bottom left that we are not interested in. Here you can see that the checkboxes next to each of the 4 countries is currently checked. We simply uncheck the checkboxes for Japan, France, and Canada. We leave Australia checked, and once we hit OK, the appearance of our graph is going to change to only include the data for Australia. This point is an important one. Folks who use Excel often find themselves deleting and recreating graphs simply because they'd like to customize what data is displayed. There's absolutely no reason to do all of that. You might have created a graph and added various customizations. The graph looks fine. All you need to do is to uncheck the boxes corresponding to the series you wish to hide. Also note that we could use the horizontal category axis labels over on the bottom right in order to exclude specific points from the x-axis, and we can also use that button up top in order to switch the rows and columns. So none of these operations should require you to delete a graph or recreate it from scratch. You can just open up the Select Data dialog and perform all of these changes from here. In any case, we are done with our changes. We hit OK and an updated graph appears in our workbook. Notice that it now only includes the line for Australia, and what's more, a title has been added up top. That's because there's just one data series. The title is the same as the name of the data series. As usual, we have the 3 icons next to the graph. Let's click on the first of these, that's the plus icon. That's going to allow us to format and change the appearance of various chart elements. Here we have axes, axis titles, chart title, and so on. Let's hover over data labels. We can see data labels get added into the graph. This is just a preview. We could also click on the little black arrow over to the right, and this opens out different types or positions of the data labels. These could be center, left, right, above, below, or a data callout. As before, we can preview these by hovering over the individual types. Notice how the option for data callouts has a little arrow which points to the exact position of the point. Each point in a line chart represents an inflection point because the line chart changes direction at each point. This will become a little more important when we discuss gradients in just a moment. In any case, let's move on. We decide against having callouts or any kinds of data labels, so we exit out of the chart elements graph. Then we click on the data series. We know that it's been selected because the little knobs appear on each of the points in our line chart. With these points selected, we right click on the graph and then choose the Format Data Series option. As soon as we do this, a dialog appears over on the right, and we can use this in order to customize our line chart as always. This dialog is titled Format Data Series. Although there's a little drop down next to the Format Data Series word, we can use that in order to format different aspects of the graph. Below that are three icons. The currently selected icon clearly shows that we are modifying the data series itself. And that's why we currently see radio buttons, which allow us to control whether the data is to be plotted on a primary or a secondary axis. We just have one data series in this graph, and so primary axis is fine. However, let's click on the little paint bucket icon in order to start modifying other aspects of this graph. You can see that there are controls to modify the line as well as the marker elements. The choices of line include no line, solid line, gradient line, and automatic. This is a set of radio buttons, and the current selection is automatic. Let's try out some of the other options. If we switch to no line, you can see that in the graph, we now only have the data points. We no longer have them connected by any lines at all. If we click on solid line, the controls change, and you can see down below that we can specify the color, transparency, width, as well as the compound type, dash type, cap type, and other properties, all of which we are going to cover in more detail. Finally, there is a gradient line, and when we click on that, we can see that the appearance of our graph changes. It's clear that there is now a gradient or a change in the hue of the lines between each pair of points. Gradient fill is quite a complex topic, and so it's best for us to take it up in a separate demo. That's the one coming up ahead. At the end of the last demo, we had been experimenting with different styles of line markers. We had ended with a solid line marker, and we had commented on how we could alter the color, transparency, and other properties of the lines. Let's now change the line style from solid line to gradient line. And as soon as we do this, we can see that the line graph takes on a very different appearance. Every line segment connecting a pair of points now seems to change in color between those points. And that indeed is the whole point of a gradient line. The term gradient in general means the slope, the degree of change, or the degree of inclination, such as ascent or descent in a highway. Here, the gradient refers to how the color changes between the two endpoints. The endpoints or the data points in the chart are referred to as gradient stops. You can see that there is a control down below which has gradient stops. Notice that we have 4 data points and 4 gradient stops. And of course, that's no coincidence because each point represents a gradient stop where the color resets to its initial value. Next to the slider for gradient stops are 2 little buttons which can be used to either add or remove gradient stops. A gradient implies a change or a slope, and that in turn implies fixed start and end points. Now, it's quite cumbersome to define fixed start and end points for every pair of data points, and that's why it's usually a good practice to make use of the preset gradients. You can see the control for the preset gradients. There's a drop down, and there are several different choices of preset gradients available there. Notice how each of these rectangles in that preset gradients drop down has a changing color. The color is typically at its darkest towards the bottom of the rectangle and then becomes lighter as we move towards the top. That change in color occurs in a 90-degree angle, and that's why the angle drop down, which you can see down below, is set to 90. We can also change the direction of the change in a more direct fashion using the direction dropdown, which you see down below as well. There are several different preset gradients made available. We just pick one, and we can see that there are some where the change is not very large. So in the gradient we've selected now, there's barely any gradient between the bottom and the top ends. We can confirm this by looking at the line chart, which seems pretty much like a solid line chart rather than a gradient line. And we can also see this by looking at the gradient stops slider. We can see that there is a uniform dark blue shade linking all of the gradient stops. We can experiment with a few different preset gradients, and then let's turn our attention to the type. The type is also a dropdown, and you can see that the accepted values in that dropdown are linear, radial, rectangular, and path. These are four different ways in which the hue changes from one end of the line to the other. We can experiment with these different types, and you can see that in each case the appearance of the line chart changes subtly. Gradients are pretty hard to work with because there are many different levers and knobs. For instance, as we change the direction, we find that this also has different effects on the appearance based on the combination of direction and type. In similar fashion, as we alter the angle, you can see that the thickness of the lines seems to vary. It's hard to really pick up on what exactly is driving these different movements, and you've got to just use trial and error if you decide to go with a gradient fill. There is, however, one specific use case here worth mentioning. It often happens that you would like to color one segment of a line chart in a different color from the other segments. Maybe that's a particular time period that you are focused on. There are different ways of accomplishing this, but one of them is to make use of gradient stops. First, click on the two gradient stops which define the segment that you want to color. For instance, I've currently clicked on the leftmost gradient stop, and then with the mouse still held down, I'm going to click on the next gradient stop. So at this point, I've selected two gradient stops. This is how you can select a specific pair of points in your chart. Now on screen, I've tweaked the gradient stops, so I only have two, and I've clicked on the rightmost of those two. With that rightmost gradient stop highlighted, you can see the faint orange highlighting around it. I click on the color dropdown. And now if I pick a specific color like that shade of green, you can see that the gradient begins to move towards that green from just before the selected gradient stop, and then it moves towards a deeper and deeper shade of green as we move towards the right. And this is also reflected in the chart. You can see that the color of the shade starts to turn green just to the left of the third data point, and then as we move towards the right, that is towards the fourth and final data point, it turns a deep solid shade of green. We can also experiment with different color schemes, and you can see that in each case we are able to highlight portions of a graph. Notice how we can also move the position of the gradient stops using that position input picker. We can change the transparency, and note as we increase or decrease the transparency how the curve in our Excel workbook also changes. You can see at this point that the rightmost segment is almost completely transparent, and that's because the value of the transparency is set to 0%. In similar fashion, we can also alter the width. You can see that the curve is now getting a lot thicker because we've now changed the width to be about 7 points. We've explored pretty much all of the controls which are specific to the gradient fill. The dropdown that we've now opened up is for the compound type, and we've now gone with a double line. It's actually hard to make sense of the compound type, dash type, cap type, and some of those other properties with a line of gradient type. So let's go ahead and change the type of line back to a solid line. As soon as we do this, it becomes very clear that the compound type that we had chosen is a double line. In this demo, we will continue with our exploration of different visual properties of line charts. At the end of the last demo, we had finished our exploration of the gradient lines, and we had changed the line back to being a solid line. And we had done this with a compound line, and that's why the chart which you now see in the center of your screen has that double line appearance. Let's now scroll down and experiment with different compound types. You can see that the compound type has a drop down, and in that drop down are various combinations. The first choice is a single thick line. The second choice has two thin lines. The third and fourth choices consist of two lines of uneven thickness. And then the last choice in the drop down is very complicated and it's got three separate lines. Let's quickly experiment with each of these three, and you can see how the chart appearance changes as we choose these compound types. The next property worth looking at is the dash type. Once again, we have a drop down, and you can see here that there are different types of lines. There is a solid line, a dotted line, there are different types of dashed lines, as well as lines which alternate dashes and dots. Let's quickly toggle through each of these choices. As we do this, please keep your eye on the chart in the center of your screen. You can see how the combination of compound type and dash type gives us many different chart appearances. The next two controls that we are going to talk about are the cap type and the join type. These are actually really interesting. So let's turn the dash type back to the default before we start experimenting with the cap and join types. The cap type setting affects the end of an open shape. Here, for instance, it affects how the extreme right or left end of our line chart is going to look. This can be a little hard to discern, so let's zoom in so it becomes a bit clearer. Please just focus on the extreme right end of this line chart. The acceptable values of cap type in Excel are flat, square, and round. Based on these three choices, you can see how at the very end, the appearance either seems flat or square or slightly rounded. Now, the cap type governs how the extreme ends of the line chart look. Those are the open ends. On the other hand, the join type, as its name would suggest, governs the appearance of every joint, that is, every connection between an adjacent pair of line segments. The acceptable values of the joint type are miter, round, and bevel. These are pretty common terms in engineering drawing, and they determine the connection between adjacent line segments for the intermediate points in our line chart. Then there are the begin and end arrow types and sizes. These four controls are a lot more intuitive to understand, so we can zoom out and start experimenting with these combinations. You can see that the names of these are quite interesting. You can see from the tooltip in the drop down that if the begin arrow type is a left pointing arrow, that's called a stealth arrow. It's also possible to have other arrow shapes such as the diamond arrow, which you see on screen now. We quickly toggle through all of these begin arrow types, and as we do this, we see that the appearance of our graph also changes quite materially. In similar fashion, we can also toggle through different end arrow types. So for instance, now we have a graph which begins with a circle and ends with a downward pointing arrow. This kind of visualization could be useful if your graph tells a story of decline. For instance, if you'd like to draw a picture of a business whose revenues are falling over time, this is a great way to set up the begin and end arrows. Next, let's turn our attention to the checkbox which says smoothed line. This is a really powerful control because it lends a very polished, sophisticated look to a line chart. To try this out for ourselves, just check the box and notice how smooth the arrow looks. We can experiment with other combinations of markers in addition to this smooth line chart. These marker options, along with the choice of begin and end arrows, as well as smooth or linear curves, can add an extra layer of polish to your Excel visualizations. To explore these, let's click on the marker card up top. When we do this, subcards appear called marker options, fill, and border. So we expand the marker options card and change those marker options from none to built in. Then we toggle through different values of the drop downs for the type and the size. And as we do this, we keep an eye on the visualization in the Excel workbook. Because of how thick our line currently is, it's actually a little hard to discern the different marker options. So let's switch back to the line, and there let's change the line type back to automatic. This gives us a very thin line, and this in turn makes the markers much more visible. So we switch back to the marker card, and we now proceed to toggle through the different types of marker options. There are a variety of geometric shapes. We can increase and decrease the sizes, and as we toggle through all of these, we can see that the appearance of our chart changes quite a bit. It's almost a bit mesmerizing to keep tweaking all of these controls. At some point, we decide that we have had our fill. We then turn our attention back to the size control and use this to shrink or expand the size of the actual point markers. Once we're done with the marker options card, we can move on to the fill card. That's the second card. Here the options are no fill, solid fill, gradient fill, picture or text fill, pattern fill, and automatic. Let's just experiment with a solid fill. Let's pick a color. Note that we can also specify the transparency, but we've now got to change the size of those markers in order for our changes to become apparent. Now it becomes quite clear that we have large yellow markers. We can also tweak the transparency in order to make them semi-transparent. After experimenting a little bit with the transparency, let's scroll down and start adjusting the border. Please note here that these borders refer to the borders of the point markers. Again, the choices are familiar. No line, solid line, gradient line, and automatic. Let's toggle through some of these different controls, and as we play around with the color, transparency, width, we can see that our markers start to display pretty prominent borders. You can currently see that the border color is set to red, and those borders are 3.75 points in width. That gets us to the end of this demo, in which we cycle through various customizable properties of line charts. In the demo coming up ahead, we will continue with line charts, but use this in order to turn our attention to some of the other types of line charts before moving on to other interesting chart types such as area charts and box and whisker plots. This demo, like the last one, is about line charts. However, we are now going to turn our attention away from the finer points of gradient lines and bevel and miter, cap and joint types, and turn our attention back to the data. So we've selected our line chart. At this point, it only has the data for Australia. We change that by clicking on the Select Data button in the top right of the menu bar. This opens up the Select Data Source dialog, which we've seen before. There's no change in the chart data range. That continues to be the cells A2 through E6 of the worksheet called line. However, in the bottom left corner, we can see that currently only the data for Australia has been selected. Let's change that by rechecking the boxes corresponding to the other data series. So we check the boxes for Canada, France, and Japan and then hit OK. That causes the appearance of our line chart to change. Notice that we still have one curved data series, that's the one corresponding to Australia. The other three lines are straight, they are not smooth lines, and that's why each of them is a pretty jagged one. Let's change this. It's easy enough for us to do. We select the Australia series by clicking on it, and then in the Format Data Series dialog on the right, we scroll down and uncheck the box which reads Smooth Line. As soon as we do this, the appearance of the Australia chart becomes similar to that of the other lines. Next, let's click on the Add Chart element over in the top left. Notice that we do this when the main menu item that's been selected is Chart Design. We can see that the green rectangle appears under the words Chart Design over in the ribbon on the top right. When we click on the Add Chart Element button, we see that there are controls for many different aspects of our chart. These include axes, axis titles, chart titles, and so on. For now, let's scroll to the very bottom and click on the up-down bars. We've encountered these before. Remember that up-down bars come in a few different flavors. When we hover over the up-down bars option, a preview gets added to our chart. Up-down bars by default are going to indicate the difference between the first and last data series. This makes them different from high-low lines, which are going to extend from the highest value to the lowest value in each category. Here in our data, the extreme data series are the ones in blue, that's Australia, and the ones in yellow, that's Japan. And that's because in our data range in the top left of the Excel workbook, Australia is in row 3 and Japan is in row 6. The up-down bars now always extend between the points for Australia and Japan. They ignore the other data series entirely. You can see, for instance, that for the year 2016, the highest data point corresponds to France, but the up-down bars don't extend up to that point at all. Also notice the color coding of the up-down bars. The first three up-down bars are shaded dark, and that's because for those points, the blue line, that's Australia, is above the yellow line, that's Japan. The relationship has flipped around for the last point, that's 2016, and that's why that up-down bar is colored white. Finally, notice that there is a line item in the menu which reads more up-down bars options, and that can be used in order to create something known as a floating bar chart. You do that by disabling the line charts and only having the floating bars. In any case, let's move on now and talk about trend lines. That's the second last item in the Add Chart Elements menu. As we've seen before, the types of trend lines supported in Excel are none, linear, exponential, linear forecast, and moving average. Let's try and add a linear trend line. This is going to perform a linear regression behind the scenes. When we click on this, we are prompted for the series to which we wish to add the trend line. Let's choose Canada and then hit OK, and we get a trend line which only performs a linear regression through the points for Canada. Now, you might be thinking that a linear regression requires X and Y values. Here, the Y values are pretty clear. They correspond to the total movie budgets for Canada. What then are the X values? Well, the answer is that in an example like this, the X values simply correspond to the indexes of the X-axis points, that is to the numbers 1, 2, 3, and 4. In other words, you can think of this trend line as the time trend of movie budgets in Canada, and that's sloping ever so slightly down. Let's turn off the other data series and hone in on the data for Canada. To do this, let's click on the Select Data button in the top right, and then from the dialog which opens up, let's uncheck all of the data series other than Canada. So we uncheck Australia, France, and Japan, and then hit OK. This leaves us with a single line, and that's the movie budgets line for Canada. We also have a linear trend line, which is the time trend for Canadian movie budgets. This trend line is not actually very satisfying, and that's because it misses out on the underlying structure of this data. Canadian movie budgets started out from $20 million in 2013. They rose extremely sharply to almost $140 million in 2014 before falling back down to a number even lower than 20 million, just 10 million to be precise, before rebounding somewhat again. This zigzag trend is completely missed by the trend line, and that's a limitation of the kind of linear regression used here. Let's see if we can do better. Let's click on the trend line. Then after selecting it, let's right click and click on Format Trendline. That's the last option over at the bottom. This opens up a Format Trendline dialog over on the right, and we can see here that there is an expanded set of trend line options. The currently selected option is linear, but we can also see that there are exponential, logarithmic, polynomial, power, and moving average options available. Let's try some of these. Let's first click on exponential, but that doesn't do any better. And that should come as no surprise because both exponential and logarithmic relationships will not contain inflection points, whereas this data has at least 2 inflection points, and that's why these types of trend lines are not going to work very well. In any case, we switch back from exponential to linear, and then we try the logarithmic trend line. As expected, this doesn't work very well either. Things get a lot more interesting when we switch to the polynomial option. Notice that there's a little text box in which we can specify the order of the polynomial that's currently set to 2. This means that we are going to try and fit a quadratic curve to our data. And that quadratic curve does indeed approximate the rise followed by the fall. Now at this point, if we hover over the text box, we get a message telling us to enter a whole number between 2 and 6. We are emboldened and we try an order of 3, and that provides an even much better fit. Before rushing to celebrate, we should remember something known as overfitting. That's exactly what we run the risk of doing if we keep increasing the order of our polynomial. Given a certain number of data points, if we increase the order of the polynomial far enough, we will perfectly replicate the data in the data set. However, that won't really have any predictive power. There's no trend left. We just have the original exact shape. And that's why it's a good idea to keep the order of the polynomial as low as possible. A polynomial of order 3, that's a cubic polynomial, does a perfectly satisfactory job of explaining this data, and so we leave it at that. There's a great deal of functionality related to trend lines that's left for us to explore, so let's pick up on that in the next demo. Let's continue with our exploration of trend lines and capabilities related to trend lines in Excel. At the end of the last demo, we had used a polynomial trend line of order 3, that's a cubic polynomial, in order to get a very nice fit of our data. The next option is a power trend line. This one is pretty similar to an exponential trend line, but the difference is that here we assume that the y value follows something known as a power law. In other words, that it increases at a certain rate. A power trend line doesn't do very well in our example. Let's move on to the moving average trend line. As its name would suggest, the moving average trend line merely computes the moving average of the last n periods. How many periods is n? Well, it's currently set to 2, and that's because we have the value of 2 in that little text box for the period. Notice how the period is equal to 2, and that in turn means that the first point in our moving average trend line appears for the second point, the one corresponding to 2014. The trend line point there is at 80 million, and that's the average of the first 2 points in the Canadian budget data, which are at 20 million and 138.5 million respectively. We can confirm those two values in row 4 in columns B and C. That's why the first trend line point is at about $80 million, and that's also why we do not have a trend line point for 2013. If we now change the period to be 3, then we are going to have even fewer points because no trend line can appear until the year 2015, which is the first time that there are 3 past periods to be averaged. You can think of a moving average trend line as a smooth version of a curve. It makes sense to use this kind of a trend line when you have a large number of data points. Here, because we have just 4 data points, a moving average trend line isn't very satisfying. In any case, let's now move on and try out some of the other customizations. Down below is a control for the trend line name. It's set by default to automatic, but we can change that by clicking on the radio button titled custom and then typing out whatever name we'd like into the little text box next to it. Notice that when we cleared the contents of that text box after selecting custom, the name from the bottom of our line chart disappeared as well. So there's no longer a name associated with the trend line there. If we type something into the text box, let's type the digit 2 because here we have a moving average over 2 periods. We can see that the word 2 appears in the title down below. If we go back to automatic, we can see that Excel creates a nice name for the trend line based on the manner in which it was computed. We can also use the trend line in order to perform some forecasting operations. To see how this is done, let's first change the trend line type to exponential, and then let's scroll back down and use the forecast text boxes. We now have added a forecast for 1 forward period and 0 backward periods. And when we do this, we can see that the trend line extends out towards the right beyond the end of the actual data for Canada. And that gives us a forecast for 1 period out. We could use that if we wanted to use this trend line to predict Canadian movie budgets in 2017. Let's set that forecast number back to 0. And as soon as we do this, we see that the trend line no longer extends out further to the right. It now purely coincides with the data in the series for Canada. Next is a checkbox which allows us to set the intercept to a specific value. Let's check that box and see what happens. Well, it's pretty clear that the shape of our trend line went absolutely awry. This is now an exponential trend line which no longer has any relation to the data at all. So clearly this idea was not a very good one in this case. What just happened? Well, linear regression or even exponential regression involves the fitting of a model which has 2 parameters, the slope and the intercept. For instance, in a linear regression model, the model being fitted is of the form y is equal to a plus bx. The value of a and b are determined by the linear regression procedure. This checkbox, however, allows us to explicitly specify the value of that intercept a and not have it be determined by the data itself. And you can see that that was not a great idea in this particular case. However, there are certain technical situations when it's a good idea to set the intercept to a fixed value, usually 0. Let's uncheck this checkbox and try out the 2 remaining controls. The first of these is titled Display Equation on Chart. As soon as we do this, you can see that the equation of the exponential curve now appears next to the trend line. Let's also check the second checkbox, which is display R squared value on chart. Both of those labels get added onto the trend line. Let's resize them and move them just a little bit so that they are clearer to read. Let's start with the R squared value, which is just 0.0005. That's a really low R square, and it indicates that this trend line does not explain the data at all. The R square is a number between 0 and 1. You can think of it as the proportion of the variance in the y variable, which is explained by the x variables. Here, that proportion is 0, so the x variables have no explanatory power at all. A good R square would be something above 50%. Then let's turn our attention to the curve equation. That is of the form y is equal to a multiplied by e raised to bx. Here a is the constant 4 multiplied by 10 raised to the power 7, so that's 40 million. And then b is the constant minus 0.02. This particular model might not seem very convincing to you, but don't be fooled. The ability to add trend lines and to play around with those trend lines and experiment with different types of trend lines is an extremely powerful feature of Excel. These trend lines are an important tool in exploratory data analysis, and the fact that you can compute these trend lines along with a visualization means that you can easily try out different types of models without writing any code at all, and with an interactive UI which updates and shows you in real time how well the model fits the data. So again, the ability to add and manipulate trend lines in Excel is an extremely powerful one. We've now explored the capabilities related to trend lines and model fitting in line charts in a great level of detail. Let's now turn our attention to the different variants of line charts. Let's first clean up all of the state from the end of the previous demo. So we first uncheck all of the checkboxes for display equation on chart and display R squared value on chart. We click on the select data button up above, and we use that to check the series corresponding to Australia, France, and Japan. So we are back to having a chart on which we have 4 lines, one for each country in our data. We still have a trend line. You can see that exponential trend line for Canada. We've got to turn that one off as well. Removing trend lines isn't very difficult. Just click on the Add Chart Elements button in the top left, navigate down to trend line, and select the option None. This will eliminate the trend line from our graph, and we are back to a clean graph with 4 series. Now let's get back to the Change Chart Type wizard. This will help us to toggle between the different types of line charts. As usual, we have the 2 tabs, Recommended Charts and All Charts. We are on the All Charts dialog, which is where we want to be. The line type is selected from the list over on the left. And then in the top, we see the icons corresponding to the different types of line charts. You can see that there are 7 icons up top. The middle one of these has been highlighted, and in the preview pane down below, we can see that this is called line with markers. If we hover over either of the templates, we get a preview. That preview, which expands out of this dialog, is a little different from the graph which we have in our workbook, and that's because we now have lines corresponding to the years, and on the x-axis we have ticks corresponding to the countries. Of course, we've encountered this situation before. When we have multiple variables, the 2 templates allow us to toggle which variable is represented on the x-axis. We can now click on the OK button at the bottom of this dialog, and this updates the graph in our workbook. And in this way, we have changed the graph so that we now have ticks corresponding to countries and lines corresponding to years. We can always go back to the previous template by using the same Change Chart Type dialog. Let's go back to that dialog in order to explore a rarely used type of line chart. So we click on Change Chart Type. The current chart type is line with markers, and that corresponds to the 4th icon over from the left. Let's try the first icon. We do that and we can see that this one is simply called line. Let's try the second, and this one is called stacked line. Stacked line charts are not used very often. The reason for this is that they are not very easy to interpret. Stacked bar charts, which we've already worked with, as well as stacked area charts, which are coming up in just a little bit, are usually a better option. But even so, for completeness, let's preview this stacked line chart and see how it's created. In the preview on screen now, you can see that we have x-axis ticks corresponding to the years 2013 through 2016, and then we have lines corresponding to the four countries. That seems fairly unremarkable. But the difference is that now all of the values along the y-axis have been computed by adding the budgets for each country for a particular year, and that's not very easy to interpret. To see what this means, let's focus on the year 2013. You can see that the blue line corresponds to Australia, and we can see that the budget in Australia, which is present in cell B3, is $121 million. That makes sense. What's a little harder to make sense of, however, is that the line for Canada appears above the line for Australia. We can see in cell B4 that the budget of movies made in Canada in 2013 was only $20 million. Why then does the red point for the year 2013 appear to be just below 150 million? The answer is because that was stacked on top of the value for Australia. So the value on the y-axis for Canada is set to $141 million. That's the sum of 121 and $20 million respectively. In similar fashion, the value for France, which is $39.5 million, we can see that in cell B5, has been stacked above the value for Canada, and that's why the cumulative value is now close to $180 million. One implication of the manner in which these stacked line charts are computed is that the top point for any given x-axis value is the sum of all of the y values for that point. For instance, the top point for the year 2013 is the yellow one that's from the curve for Japan. And if we precisely measured out the value for Japan for the year 2013, that would work out to $210.5 million, because that's the sum of all of the movie budgets for all countries in the year 2013. As you could see from this, interpreting a stacked line chart is quite complex. A stacked bar chart is a lot easier to interpret because the bars there are clearly visually placed one above the other, so we can see that the bars are related. That's not true with a stacked line chart. Let's also explore the other kind of stacked line chart, that's the template on the right. Here you can see that the x-axis values correspond to the countries and the lines correspond to the years. Now the values for any one country are all stacked up above each other. So for instance, if we look at the topmost point for Australia, that's the yellow point, that represents the cumulative budget up to and including the year 2016. That works out to a little more than $400 million, and that would exactly coincide with the sum of all of the budgets present in row 3 of our spreadsheet, where country is equal to Australia. Well, if you thought a stacked line chart was hard to interpret, just wait till you get to the next variant, which is the 100% stacked line chart. This one is very similar to the stacked line chart, with the difference that the y-axis is now normalized to always be between 0 and 100%. We can see from the preview that we always have a horizontal line corresponding to the last data series, and that's because the last data series is always expressed as the cumulative sum of all of the data series before it, and that's why it's always going to be the largest. Here, the last data series is Japan, because Japan was the last row in our data. And that's why in the preview, we have that horizontal yellow line right up top at 100%, which corresponds to the budgets for Japan. In case you're wondering why, for the year 2014, the gray line for France seems to almost touch the yellow line for Japan, well, just turn your eye to cell C6 of your spreadsheet. You can see there that the value for Japan in 2014 was only 5 million. That's a very small value. And so the cumulative sum barely increased when we moved from France to Japan. And that's why the lines for France and Japan for 2014 touch each other in the preview on screen now. That does it for the 100% stacked line. Let's click on the fourth icon. This is where we started this demo. This is on the line with markers. We've already worked with this one extensively in the previous demo, so we can move on. The fifth icon corresponds to a stacked line with markers. This is again very similar to the stacked line. The only difference now is that we have individual point markers. And we are back to having all of the lines expressed in cumulative terms, but notice in the preview that the y-axis still represents absolute values. We can confirm that this is indeed a cumulative sum by looking at the highest point for the year 2013, we can see that that works out to around $210 million. And that makes sense because if we sum up all of the values in column B, that sum works out to 210.5 million. And the cumulative sum is always expressed by the highest point in a stacked line chart with or without markers. In similar fashion, we can move on and check out the 100% stacked line with markers. Once again, this one is going to have the y-axis normalized to be at 100%. And once again, we are going to have a horizontal line corresponding to the last series. And that's because of the cumulative nature of the stacked line chart. This again is the close cousin of the 100% stacked line chart. We just have point markers in there now. And once again, you can see that for 2014, we see the points for Japan and France very close to each other. And that's because the value for Japan in the year 2014 was only $5 million. As always, there are two templates, the 100% stacked line with markers, but we know what the other one looks like. So let's move on to the last chart category here, and that's the 3D line. You can see that that's the last icon over on the top right. And in the preview pane down below, we see that this is a three-dimensional version of the very first chart. We've not used this one before, so let's hit OK and add this one into our workbook and manipulate it there instead of doing all of this from the preview pane. You can see that along the y-axis, that's the vertical axis, we have the dollar amounts. Note that these are not cumulative. Then on the x-axis, we have the countries, Australia, Canada, France, and Japan. The third dimension, which is the depth, has the z-axis, and that encapsulates the year 2013 through 2016. This particular 3D line chart is actually quite hard to interpret, and the reason for that is that the x-axis has the country rather than the year. We are so used to having time as the x-axis in a line chart that it can get a little disconcerting if the x-axis has any other variable. But even so, we can still make sense of this if we just put our minds to it. Each line here corresponds to a year, and those lines have markers corresponding to the countries. So for instance, in order to answer a question like, what's the total movie budget for Japan in 2014? We'd first find the line for 2014. Note that that's the red line. We've now clicked on it. We then find the marker corresponding to Japan. That's the one on the extreme right. And we can see that that marker is a very small value. It's very close to the x-axis, and that's because that value is $5 million. Let's change the axes around and see if the graph gets easier to interpret. So we click on the Change Chart Type button up top. We are still in the section for 3D lines, but we now hover over the second template, the one on the right. And now when we hit OK, we can see that the x and the z axes have been interchanged. Along the x-axis, we now have the year, and along the z-axis, that's the depth dimension, we have the countries. Let's now take a moment to answer an arbitrary question. What was the budget of movies made in France in 2015? Let's first find the line corresponding to France. That's the gray line which shoots upwards in 2016. Then let's find its marker for the point 2015. And that marker is actually quite hard to identify. And in other words, it's not really easy at all to tell from the plot that the answer to our question is $116.2 million. We can see that value in the Excel worksheet that's in cell D5, but it's quite hard to tell it from this 3D line chart. As we can tell from this little exercise, interpreting a 3D line chart is not always very simple, but it does have a nice polished appearance. In this demo and the next one, we are going to turn our attention away from line charts and now focus on area charts. Area charts are quite similar to line charts in that they connect all of the points using a continuous curve. However, they differ from line charts in that the area under the line is shaded as well. And that's what gives rise to the name area chart. The data that we'll be using is on screen now. This is the same movie budget data we were working with in the previous example. Let's get started. We select this entire data range. That's all of the data A2 through E6. And then this time we're going to click on the Insert menu item up top. That in turn allows us to choose a chart from the group of charts, which is present in the center of the screen. We click on Recommended Charts, and that brings up the same dialog which we have worked with multiple times before. There are two tabs, Recommended Charts and All Charts. Let's shift to the All Charts tab. You can see that the default selection there is column. You can see that over on the left, but we navigate down and click on area. We can see from the 6 icons up top that there are 6 types of area charts supported in Excel. The first of these is currently visible. It's just called an area chart. The second is a stacked area chart. The third is a 100% stacked area chart. That does it for the first 3. The second set of 3 charts merely represent the 3D equivalents of the first 3. So the fourth icon represents a 3D area chart. The fifth icon represents a 3D stacked area chart. And the sixth and last icon represents a 3D 100% stacked area chart. Let's hover over the first template. This is our first area chart. We can see on the y-axis that we have the budget. On the x-axis, we have ticks corresponding to each year. That's year 2013 through 2016. And most importantly, we have areas corresponding to the 4 countries. Now you can see that in the legend down below, we have 4 countries: Australia, Canada, France, and Japan. But when we look closely at the area chart, we see no sign of Canada. In fact, that's because the area for Canada has been completely obscured by the area for France. This represents a major limitation of the ordinary area chart, and this is why the stacked area chart is by far the most commonly used flavor. While working with line charts, we had commented on how stacked line charts are not used very often, and it's only ordinary line charts that find common usage. The exact reverse is true with area charts. With area charts, it's stacked area charts that are the easiest to use and find the most favor. In any case, let's hit OK and add this area chart to our workbook and start working with it in different ways. We resize it, we hover over it, and we can see that we have the series for France. We can hover over different points and we always get a helpful tooltip. But no matter where we hover, we do not get a tooltip for Canada, and this brings up the same problem we mentioned a moment ago. There's absolutely no sign of Canada anywhere in this graph except in the legend. Let's see what we can do to improve on this. Let's right-click and choose the Format Data Series option. At this point, you can see from the dropdown that the selected data series is Japan. When we click on this, the Format Data Series dialog appears on the right. And there you can see a little drop down arrow next to the words series options. By clicking on that arrow, we can change the selected data series. Right now, the series that's selected is Japan. We can see that in the drop down, and we can also see that from the data present in row 6. The row for Japan has been highlighted. Let's use our mouse to select the series for Australia, and then let's set about modifying its transparency. You can now see that it's Australia that's been selected, and you can faintly see an outline for the Australia data points. Note that you can now even see those data points which have been hidden by the curve for France. Let's click on the paint bucket icon up top and add a solid fill. This gives the data series for Australia that bright green shade. That shade is still not going to be visible when it comes behind the areas for the other countries, namely France and Japan. Let's experiment with a few other theme colors, and then let's play around with the transparency slider. This transparency slider currently is only changing the transparency of Australia's area, but now we can use the drop down up top in order to select the series for France. Note that the highlighting has shifted to row 5 of our spreadsheet, and the gray area in our chart has been selected. Let's go with a solid fill, and we now see that the area for France is that bright blue color. We can tweak the theme color and set it back to gray before we experiment with the transparency. And this finally gives us the result that we wanted. By lowering the transparency of the surface for France, the surface for Canada, which was previously completely blocked by France, has become visible. So we finally found a way to mitigate the great weakness of the ordinary area chart, and that is to tweak the transparency of the different data series in order to ensure that all data series are clearly visible. In similar fashion, let's use the drop-down to select the data series for Japan. Note the highlighting has now shifted to row 6, and there we can also play around with the solid fill as well as the transparency. And at the end of this process, we have achieved a uniform look where all of the different areas in our chart are semi-transparent. Now there's one other little trick that is especially popular while working with area charts, and that's the use of a secondary axis. Let's now click on a single data series. Here you can see that we've chosen the data series for France. The highlighted row in the spreadsheet is row 5. Now in the Format Data Series dialog on the right, click on the little bar chart icon. This brings up the series options, and this is where we can specify whether our series should appear on the primary or on the secondary axis. The current selection is primary axis, but let's change that. We click on secondary axis and you can see that our graph immediately changes. We now have only the data series for France plotted with an axis over on the right. The other data series are still plotted on the primary axis, which has the ticks over on the left. Now, the use of a secondary axis is usually meant for situations where we have two series which are expressed in different units, and there we want the different series to be compared against different axes. Here, all of our series are expressed in dollars. So in case you're wondering why we are choosing a secondary axis here, it's simply in order to be able to highlight the data series for France. This is not a common use case if you're working with an ordinary line chart, but if you're working with an area chart which is not a stacked area chart, in other words, an ordinary area chart just like this one, you might find it helpful to have a secondary axis just in order to be able to hone in on one series. In any case, let's go back to a single primary axis by changing our selection in the radio buttons. That gets us to the end of this little demo. We will continue our exploration of different area charts in the next demo. In the previous demo, we introduced the area chart and we explored the simplest kind of area chart, that's a non-stacked area chart. We saw that the great limitation of that area chart was that areas in front tended to obscure the areas behind. And we saw that one way to fix this was to adjust the transparency of the different surfaces. By making those surfaces semi-transparent, we could ensure that even those surfaces which were behind or which were going to be obscured by larger surfaces became visible. On screen now is exactly such an area chart. You can see that we've tweaked the transparency, and that's why the surfaces corresponding to the different countries are all somewhat visible. This particular area chart has surfaces corresponding to the 4 countries, and it has ticks on the x-axis corresponding to the years. Like with all of the other chart types that we've worked with so far in Excel, it's really easy for us to swap the surfaces and the x-axis ticks. In order to do this, we follow our usual procedure. We click on the Change Chart Type button up top. We are already in the Area Chart dialog, and the current chart type is indeed just area, but we are now going to switch from the template on the left to the one on the right. So we click on that and hit OK, and a new updated version of the area chart appears in our workbook. This version now has surfaces that correspond to the years, and it has x-axis ticks which correspond to the countries. This is slightly less intuitive than the previous area chart just because such charts usually have time on the x-axis. And now, because we have a categorical variable, that's the country, along the x-axis, this is just a less useful kind of chart. A general rule of thumb is that you should be using bar charts or column charts in order to plot categorical variables on the x-axis, and you can consider area charts or line charts when you have continuous variables such as time on the x-axis. Remember that a categorical variable is one which takes a discrete set of values. Here, country is a categorical variable and its acceptable values are Australia, Canada, France, and Japan. Time, on the other hand, can be thought of as a continuous variable, and that is true even though we currently have labels for the different years. So again, just because our labels are strings, year 2013, year 2014, and so on, that does not mean that time is a discrete variable. On the other hand, the country is a discrete variable. In any case, there's nothing explicitly wrong with having an area chart or a line chart where the x-axis variable is categorical. Let's go ahead and perform a few simple operations. We right click and choose the Format Data Series option. As before, we can experiment with the choice of primary and secondary axis. Notice that while we are performing these operations, it's the year 2014 which has been selected. You can see that both from the highlighting in the graph and from the highlighting in cells C2 through C6. And in similar fashion, we can also play around with different types of fill. You can see that we are adjusting the transparency, selecting different series, and modifying various properties of the graph. We've now explored building two different types of area charts. Both of these area charts were not stacked area charts. One of those had a categorical variable, the country, along the x-axis. The other one had a continuous variable, that's time, along the x-axis. And clearly, the better of these two is the one which has the continuous variable, that's time, along the x-axis, but the other one isn't wrong either. Let's now move on to one of the most popular types of charts out there, and that's the stacked area chart. We get started in the usual fashion by clicking on the Change Chart Type button on the top right. This opens up the Change Chart Type dialog. Over on the left, you can see that it's the area chart type that has been selected, and up top you can see that there are 6 icons corresponding to the 6 types of area charts. We've currently got the ordinary area chart selected, but we are going to click on the second icon and convert this chart into a stacked area chart. As always, there are two templates. Let's hover over the one on the left, and that causes an expanded preview. This expanded preview has the countries on the x-axis, and it has areas corresponding to the years. We'd like to study this in a little more detail, so let's hit OK. It gets added into our Excel workbook. A stacked area chart, just like a stacked line chart or a stacked bar chart, is built using cumulative sums. So in other words, every series starts from the series below it. To see what this means, let's just focus on the data for Australia. You can see that the first data point for Australia, which corresponds to 2013, has a budget of $121 million. And that's why that blue line intersects the y-axis at about 121 million. The next point, however, which we can see in cell C3 is $93 million, but this point appears in our graph at over 200 million. And that's because that number has been added to 121 million, and that's why the second point corresponding to Australia intersects the y-axis above 200 million. In similar fashion, the budget for year 2015 in Australia was 159.6 million. We can see that in cell D3. However, the corresponding value in the chart, that's Australia for the year 2015, clocks in at almost $370 million. Finally, Australia's budget in 2016 was only 40 million, and that's why the last and highest point in the column for Australia in the chart appears just north of 400 million. In similar fashion, we can see that all of the other lines are built one atop the other as well. We've now made sense of this stacked area chart, but it still suffers from one drawback. Notice that on the x-axis we have a categorical variable, which is the country. We've already discussed that with area charts and line charts and with most other continuous chart types, it's a best practice to have time or some continuous variable on the x-axis. This is simple enough for us to fix. Let's click on the Change Chart Type button. We stick with the stacked area chart, but now we are going to move to the template over on the right. We hit OK, and now the chart which appears in our workbook has the year, which is a continuous variable, on the x-axis. The interpretation of this chart is similar to that of the previous chart, but with the important difference that the highest point for each year now represents the total budget across all 4 countries in that year. So for instance, if we look at the year 2014, we can see that the highest point there clocks in at between $350 and $400 million, and we can get that number by adding all of the budgets for the year 2014. You can also see for 2014 that the curves for France, that's the gray curve, and for Japan, that's cream colored curve, are very close to each other. And that's because the movie budget in the year 2014 for Japan was a very small number. It was just 5 million. This is now a really legitimate stacked area chart. We've used this in order to get the total movie budgets for each year, and we are also able to observe time trends for each country as well as for the total movie budget as a whole. In order to interpret trends for each country, we've got to keep an eye on the thickness of the areas for that country. Whenever a particular curve becomes very thin, that represents a very small data point. We can see that, for instance, with Japan in 2014, and we can also see it to a lesser extent with Canada in 2015. Note how in 2015, The blue curve and the red curve come very close to each other, and that's because the budget for Canada was a very small number, just $10 million, a lot smaller than that for all of the other countries. This is a stacked area curve, and that's why we have absolute dollar numbers on the y-axis. That's great for discerning time trends, but not so good for telling how much each country contributed in a given year. For that, we can change the chart type. We just click on the Change Chart Type button in the top right. In the dialog that opens up, the current chart type is stacked area. The second icon from the left has been clicked. However, we click on the third icon, the one just to the right of the stacked area, and that converts our chart into a 100% stacked area chart. This is yet another really commonly used type of chart. We take a quick look at the preview, but then we hit OK and add this 100% stacked area chart into our Excel workbook, and we'll discuss it at length in the demo coming up next. At the end of the last demo, we had created and inserted our first 100% stacked area chart. This 100% stacked area chart is visible on screen now. Let's make sure that we understand it. We can see that the y-axis ranges from 0 to 100%. So that's the first bit worth noting. The second bit worth noting is that the top of the graph is always defined as one boundary of the last series. Here, our four series are Australia, Canada, France, and Japan. So the last series of those is Japan. And we can see that the area for Japan is always flush against the ceiling of this graph. The reason for this is that all of the series are planted one above the other. This means that for each year, all of the values are normalized versus the sum of all budgets for that year. Let's take 2013 as an example. In 2013, we can see that the budget for Australia was 121 million, that for Canada was 20 million, for France 39.5 million, and Japan 30 million. The sum of these four numbers works out to 210.5 million. Now, every one of those budgets for 2013 is going to be divided by 210.5, and then the cumulative proportions are going to be displayed on the graph. Let's work this out. Australia, for instance, has a budget of 121 million. 121 divided by 210.5 yields 57.48%. And that's why for 2013, the blue area extends all the way up to 57.48%. Then comes Canada, which had a budget of 20 million. 20 million divided by 210.5 yields 9.5%. However, that 9.5% is now stacked on top of the 57.48%, and that's why the upper edge of the Canada curve hits the y-axis at 66.98%. Similarly, the number for France is 39.5 million. That constitutes 18.76% of 210.5. That 18.76% is stacked up above the bars for Australia as well as Canada, and that's why the upper end of the area for France in 2013 hits the y-axis at 85.75%. All that's left is Japan. The lower end of the Japan curve starts at 85.75% and it extends all the way up to 100%. A similar operation is performed for each year. What's important to keep in mind is that the sum of the values is computed independently for each year, and that's why for each year we always end up with the ceiling at 100%. Now that we understand the exact construction of a 100% stacked area curve, we can derive some valuable insights from it. We can see that whenever a curve gets very narrow, this means that in that particular year, the contribution of that particular country was very small. Our favorite example is Japan in 2014. You can see that the number which you can see in cell C6 was only 5 million, and that contributes less than 5% of the total. That's why the Japan curve in 2014 is so narrow. On the other hand, if we look at the data for 2016, we can see that the gray curve, the one for France, occupies a very large area of the graph. If we look closely, we can see that the upper end of the France curve for 2016 clocks in just below 80%, and the lower end intersects the y-axis at just below 20%. So from this, we can see that France in 2016 contributed to something like 60% of the total budget. How did we get 60%? Well, the top was at 80%, the bottom was at about 20%. 80% minus 20% gives 60%. So from this graph, we inferred that France's share in 2016 was around 60%. How does this match with the actual numbers? Let's find out. In 2016, the budget for France was 259 million. If we add up all of the budgets for all four countries, we get the number 433 million. That's the sum of the values in the cells E3 to E6. Now, 259 divided by 433 gives us 59.81%, which is almost exactly equal to our 60% estimate. And so you can see that this graph passed our basic gut check. In a previous demo, we had seen just how difficult it was to make use of a 3D line chart in order to answer basic questions about our data. That seemed to suggest that a 3D line chart was not a very good visual representation of the data. However, as you can tell, this is not true in the case of our 100% stacked area chart. We are able to answer complex questions such as the share of a particular country in a particular year extremely easily using this representation, and this explains why the 100% stacked area chart is such a popular type of visualization. Another great advantage of this 100% stacked area chart is that the areas do not overlap, and so we can get rid of the transparency that we had introduced. Let's right click on a data series. Notice when we do so that the drop down up top says Series Australia, so that's the data series that we've selected. And we can now change the transparency back to 0. We click on the paint bucket icon in the Format Data Series dialog over on the top right, and there in the fill options we see the slider for transparency. We've currently got that set to 70%, but we don't need that anymore. That transparency was only required for the non-stacked area charts. So we set the transparency back to 0. So we've now made the series for Australia completely opaque. You can see that it does not obscure or get in the way of any of the other areas. This tells us that it's perfectly fine for us to repeat this operation for the other countries as well. We click on the little drop down next to the word series options and choose the other series one by one. We make that change and quickly have an entirely opaque chart. This is a 100% stacked area chart. None of the areas overlap with each other, and that's why it's perfectly fine to have them all opaque. Another good feature of this chart is that we have a continuous variable on the x-axis. As we've discussed, while making use of continuous chart types such as lines or area charts, it's usually a good practice to have a continuous variable, especially time, on the x-axis. However, it's still possible to have a categorical variable like the country on the x-axis. All we need to do in order to make this change is to click on the Change Chart Type button over on the top right. In the dialog that opens up, we stick with the 100% stacked area, but we now click on the template over on the right instead of the one on the left. And when we do this and hit OK, we find that a modified version of the 100% stacked area is added to our worksheet. This one now has the year as the area variable, and it has the countries on the x-axis. Again, there's nothing particularly wrong about this representation, but it's less than ideal because we now have a categorical variable on the x-axis. A better alternative to this particular visualization would have been a 100% stacked column chart or a 100% stacked bar chart rather than this 100% stacked area chart. In any case, this gets us to the end of our exploration of stacked area charts. We still have various other types of area charts to talk about, and we'll get to those in the demo coming up next. We ended the previous demo with a 100% stacked area chart. We spent quite a bit of time discussing its many advantages. In this demo, we will move on to some of the other remaining variants of the area chart, notably the 3D variants. Some of these have some important limitations, but we still ought to know how to work with them. In a corporate environment, you don't always have the liberty to choose the exact type of visualization that you've got to use in a slide, say to senior management. That decision might have already been made for you. In such situations, little tips and tricks can turn even a suboptimal visualization into a pretty impressive one. Let's get started. We've already selected our graph. We now click the Change Chart Type button in the top right. The current chart type is 100% stacked area. and you can see that the third icon from the left has been selected. With the mouse, we now click on the fourth icon, and you can see that this one has the name 3D area. And this, of course, is just a 3D version of the ordinary area chart. Let's preview it. You can see that we have curves corresponding to the different years, and on the x-axis we have the countries. As already discussed, this is not ideal, but even so, it's not wrong. Let's go ahead and hit OK and add this graph into our workbook. One point to note about this particular 3D area chart, you can see that along the z-axis we have the years. The first year is 2013, that's followed by 2014, 15 and 16. Now, let's say that we'd like to make the data for 2015 very clearly visible. There's a trick that we can use to make this happen. Let's click on the area that's blocking 2015. That's the red-brown curve for 2014. And then with that curve selected, we right-click and choose Format Data Series. As expected, the Format Data Series dialog appears over on the right. We click on the little paint bucket icon. This brings up different fill options. You can see that the default choice is solid fill, but now we change that to no fill. And as soon as we do this, we see that the curve for 2014 has vanished. We can now clearly see the curve for 2015. And in this way, by changing the fill of the obscuring surface, we have revealed all of the surfaces behind it. This problem, where we had one surface overlapping and hiding another, is one which we had encountered with the ordinary two-dimensional area chart as well. In that case, we had attempted to solve it by changing the transparency of the different surfaces. Here, we've achieved something similar by changing the fill property to no fill. As always, we can also control other aspects of the graph. We can see on screen now that we are adjusting the gap depth using the controls from the series options. And as we do so, the extent of those curves on the z-axis changes. We can also go back to the automatic fill, and that causes the year 2014 to reappear. On second thoughts, it's better to go back to the no fill so that we can see the data for 2015 more clearly. In any case, let's now close out of the Format Data Series option and swap the data on the X and the Z axes. We click on Change Chart Type in the top right. We stick with the 3D area type of chart, but we now click on the template over on the right. This preview opens up. You can now see that we have the year on the x-axis and the country on the z-axis. This is different from the graph which we were working with a moment ago. We hit OK and this gets added to our workbook. In the context of 2D plots, we've often discussed how line charts and area charts go well with continuous variables, particularly time, on the x-axis. This is true for 3D charts as well. Here we have a choice about whether we'd like to represent the year on the x-axis or on the z-axis. In the previous version of this graph, just before we changed the type, we had the year on the z-axis and the country on the x-axis, but that gave us continuous curves on the x-axis which weren't really very easy to interpret. Here, by swapping things around, we've actually improved the quality of this visualization. Take for instance the blue curve. That blue curve shows the time trend of Australian budgets on the x-axis, and that's why it's just much more easy to interpret. So again, if you're trying to decide whether time should go on the x-axis or on the z-axis of a 3D chart, keep time on the x-axis. That's a better choice. Now there's another bit worth noticing about this chart. If you look really closely, you'll see that the data for Canada is missing, and that's because Canada has the fill set to no fill. This might seem odd because after all, we had recreated this chart by changing the chart type from another chart, and the no fill property had been applied to that chart and not to this particular chart. But this is a clue to us. It tells us that when we change chart types, some customizations might unexpectedly carry over. Here, we definitely do not want to hide the data for Canada, so we are going to go ahead and add that data back in. It's slightly complicated to do this because the data for Canada is invisible, so we select a different data series, that for Australia, then we right-click and choose the Format Data Series option. Note how the drop-down above the right-click menu says Series Australia. This in turn causes the Format Data Series option to appear on the right. We use that drop-down in order to select the series for Canada. We click on the paint bucket icon in order to bring up the fill options, And there we've got to change the choice from no fill to automatic, and that's what brings back the missing surface for Canada. Again, the lesson from this little example is that customizations might unexpectedly carry forward when you change chart type, and you've got to keep a really sharp eye out for that. While we're on the subject, let's explore another little issue that can come up when you try to change chart type. In order to demonstrate this issue, first let's go ahead and make a few changes to our data series. So we've now changed a bunch of data series to no fill, and as a result, our chart looks pretty sparse. Importantly, at this point, we have not selected the entire chart. Rather, we have selected an individual data series. We can see that from the blue highlighted points on the surface of our chart. That's the invisible data series that's currently selected. And now here's the issue. If you attempt to change the chart type after selecting a series rather than selecting the entire chart, Excel thinks that we are trying to create something known as a combo chart, and that results in the rather strange warning which you see on screen now. Excel tells us you cannot create a 3D combo chart. Do you want to change this chart to a 2D chart so that you can create a combo chart? At this point, if you got here by committing this little mistake, you probably would have had no idea at all what Excel is asking you. All that you need to do in order to get around this is to ensure that when you attempt to change the chart type, you have selected the chart and not an individual data series inside that chart. So at this point, we've selected the chart itself rather than any data series. Note that there are no little dots indicating a selected series in the body of the chart. And now if we attempt to click on the change chart type button in the top right, there's no warning and everything goes through smoothly. The current chart type is 3D area, but we are now going to click on the fifth icon in the top row, and that is going to change our chart type to be a 3D stacked area. We've already discussed ordinary stacked area charts in a lot of detail. We spoke about how stacked area charts as well as 100% stacked area charts are both really common and really popular. The great advantage of stacked charts is that the different area surfaces do not overlap with each other. We can see this from the preview pane. Notice that at this point, because we've set two of our data series to no fill, our stacked area chart looks rather strange. It only seems to have two floating surfaces. These are the surfaces that correspond to Canada and Japan. The idea of using the no fill in order to make some surfaces visible is no longer required because this is a stacked chart. So we hit OK and then we edit the chart in our Excel workbook to display the invisible data. Again, it's a little cumbersome to do so because the invisible data cannot be selected very easily. Instead, we select one of the visible data series. Here, we select the data for Japan. Then we use the drop down over on the top right in order to select the series for Australia and change its fill property to automatic. So the data for Australia reappears. In similar fashion, we now use that same drop down in order to select the data for France. That was the other invisible data series, and that is set to automatic as well. And at this point, we are back to a fully populated stacked area chart. We've already discussed the 2D version of this chart in a lot of detail, so we understand its construction and the values on the X and Y axes pretty well. Let's also try out the other variant in which we have the countries along the X axis rather than the years. Note that we have the chart selected when we click on change chart type. We stick with the current chart type, which is 3D stacked area, but we just click on the template over on the right. And this opens up a preview. We can see that on the x-axis, we now have the country. We've already discussed on several occasions that this isn't ideal, but even so, it yields some interesting views of the data. Notice, for instance, how the sudden spike for the country France corresponding to the year 2016 tells us that the budget for France in this year was a lot higher than in previous years. So again, like almost any other visual representation of data, there are insights to be gleaned from this one as well. We've now experimented with 5 out of 6 types of area charts. Let's use the change chart type icon in order to try out the sixth one. We click on the sixth icon over on the extreme top right, and you can see that the name of this chart type is 3D 100% stacked area. And of course, this is a close cousin of the 100% stacked area. The only difference is that this is a 3D version. Let's hit OK so that we can examine it more closely in the Excel workbook. You can see that in this particular chart type, the data is inherently represented in 2 dimensions, and so there's almost no difference between the 3D and the 2D versions of this chart. Notice, however, that as before on the y-axis, we always have the last data series flush with the ceiling, that's at 100%. For that reason, we could actually remove that last data series without eliminating any information. Let's try that out. We've now selected the data series for the year 2016, and then we right click and use the format data series option in order to get to the dialog on the right. We click on the paint bucket icon, and there we change the fill type to none. When we do this, it's only the top bit, the top stacked surface that goes away. We still can deduce all of that information from the remaining surfaces. In any case, let's go ahead and add that back. We can do this either by setting the fill property to solid fill or to automatic. Either option will have the same effect. The reason we add this back is because we are going to change the chart type once again. We'd like to try out the last variant of the 3D 100% stacked area chart. That's the template on the right. We choose that and hit OK, and we now have a similar 3D 100% stacked area chart, except that the X and the Z axes have been flipped. So on the X axis, we now have the years, and we now have the surfaces corresponding to the countries. At this point, we've run through all 6 types of area charts supported by Excel. However, there's one little loose end which we still need to tie up, and that has to do with the formatting of walls. We've discussed walls very briefly in passing. In any 3-dimensional plot, the plot is bounded by walls, also known as planes in high school mathematics. For 3 dimensions x, y, and z, we have walls corresponding to the xy, xz, and yz planes. Excel has excellent support for formatting these walls. Let's see how it's done. In order to do this, let's change the chart type yet again. We click on the Change Chart Type button up on the top right. We are careful to have the chart selected when we do this. And now we change the chart type from the 3D 100% stacked area chart to just an ordinary 3D area chart. It's best to illustrate the formatting of the walls with a 3D area chart because that leaves the walls most visible. We do a quick examination of the preview and then hit OK and add this chart to our Excel workbook. Note that this is a 3D chart. On the x-axis, we have the country. On the z-axis, which represents the depth dimension, we have the years. And on the vertical y-axis, we have the total budgets. Let's right-click on the chart area and choose the Format Data Series option. This brings up the dialog over on the right. As usual, we are going to navigate to the drop-down next to the word series options, and from that drop-down, we are going to choose the option back wall. That's the first option in the drop-down. If we look closely down below, we can see additional wall-related options. We can see, for instance, that there is something known as the floor. A little further down is a side wall, and then towards the bottom is just walls. Let's take a minute to understand what all of these represent. If you think about it, the back wall is bounded by the x and the y axes. So the back wall is the xy plane. The floor is bounded by the x and the z axes, so that makes it the xz plane. And the side wall is bounded by the y and the z axes, and that makes it the yz plane. Finally, the option called walls will just apply formatting to all 3 planes. For now, we've selected the back wall. Choosing this from the drop-down allows us to perform various customizations. You can see that there are cards corresponding to the shadow, glow, soft edges, 3D format, and 3D rotation. The currently expanded card has presets, color, transparency, size, blur, angle, and distance. All of these cards are under the icon of the pentagon. Let's change that. Let's click on the icon of the paint bucket and a different tab opens up. There we can change the fill, and as soon as we apply a solid fill, we see that there is a dramatic change in the appearance of our graph. Right now, the back wall has the same color as the year 2016, so it's not very clear. Let's fix that. So we change the color of the back wall to be this bright green. Then we can apply different transparency levels and customize it in order to look a lot nicer. Note how we see the bright green circular dots, which indicate the bounding rectangles of the back wall. They also tell us that we still have the back wall selected. We can also use the mouse to click on the side wall. That side wall is now selected. Let's go ahead and edit it. We choose it from the drop down on the wall options dialog over on the right. In fact, because we had already selected the side wall, that's the item that's already been chosen from the drop down. The current fill is set to automatic. Let's go ahead and try a few different options. Let's try a solid fill first. You can see that this has a deep black color. We can change that from the color picker, and after experimenting with a few different combinations, we can also play around with the transparency. After a few changes, we are satisfied with the outcome. Then from the drop down up top, we choose the walls option. This is going to apply changes to all three walls at one go. Now, for instance, if we change the transparency, that change is going to be applied to all three walls. And finally, really quickly, let's also see how we can format only the floor. So from the drop down up above, we choose the floor. The title updates. We are now formatting the floor. We can try different fill options. Let's try a solid fill. As before, we experiment with the transparency as well as the color picker. That gets us to the end of this little demo in which we saw how the bounding walls of a 3D plot can be modified. Remember that a 3D plot is bounded by three axes, and that in turn yields six planes or six walls. However, our 3D plots are always going to be open on three sides, and that's why we have only three remaining walls. Those are the floor, the back wall, and the side wall. We have now come to the end of this course, visualizing data using line charts and area charts. We began by understanding the use of line charts to visualize time trends in data. Line charts are possibly the most common and popular type of visualization out there for displaying time series data, which is pretty much any visual with time on the x-axis. This allows time trends to be summed up at a glance. We then move to formatting and customizing line charts, including adding data labels, customizing line color, and using gradient fills. We also saw how to customize various other aspects of the line from a line chart, such as the thickness of the line, the markers corresponding to the beginning and end of the line, and whether a line is represented using dashes or dots. We explored the use of trend lines and saw how easy Excel makes it to add such trend lines in order to evaluate different kinds of regression models on data in a line chart. We saw how to customize and format these trend lines, and also how easy it is to smooth the curve connecting the points in an Excel line chart. Next came area charts and stacked area charts. Stacked area charts are a very powerful type of visualization because they combine information about trends over time with information about composition and parts of a whole. We examined in detail the several types of Excel stacked area charts and customized their appearance, including that of the various walls or bounding planes in 3D visualizations. You are now ready to move on to the use of more specialized chart types in the course, plotting stock charts, radar charts, tree maps, and donuts coming up next. Excel is the most popular spreadsheet program in the world, but it's also a lot more. It's a go to choice for an incredible range of statistical, scientific, business, and analytics related use cases. From numerical optimization to printing specific views of workbooks, from hypothesis testing to dynamic validation of user input, Excel provides for it all. In this path, our focus is on the data visualization capabilities of Excel. There is a wide range of common built-in chart types available, and in addition, many other specialized chart types can be constructed by ingenious reuse of those built-in chart types. You start this course by using Excel visualizations for stock data. You learn how effective the high-low close and the open high-low close charts are at quickly summarizing several different aspects of stock performance. You then move on to radar charts, which are great for visualizing multivariate ordinal data such as ratings or scores between 1 and 10. You move on then to tree maps to visualize hierarchical data in the form of shaded rectangles contained within a larger bounding rectangle. You move then to pie charts, which are great for displaying parts of a whole at a specific moment in time. You will create pie charts to display composition of a whole, and then explore the use of pie and bar of pie charts, both of which use a secondary visualization to complement a primary pie chart. You will then explore how donut charts, which are closely related to pie charts, can be used to visualize composition as well, with the added benefit that a donut can make use of multiple concentric donut rings to plot such composition at differing moments in time. In this demo, we are going to turn our attention to a rather specialized form of visualization in Excel, and that is the stock chart. On screen now is the data that we are going to use in this example. One little point which is worth noting is that the stock charts in Excel require the data to be arranged in a specific order of columns. Here we have the dates followed by volume, open, high, low, and close information. And the stock charts in Excel do require data in this particular order. The order that you see on screen now in row 2 is actually compatible with all of the different varieties of Excel stock charts. Excel has support for 4 types of stock charts. These 4 are the high, low, close, the open, high, low, close, and then the volume, high, low, close, and the volume, open, high, low, close. You can see for yourself how the order of columns on screen now is compatible with each of those 4 types of charts. The first chart we are going to build is going to be a high, low, close. So for this, let's select all of the data in columns A, B, E, and F. These columns correspond to the date as well as the high, low, and close. In case you've not come across non-contiguous selections before, well, you should know that Excel does support such selections. All that you have to do is to keep the Control key pressed down as you select different ranges. So here, for instance, I had pressed down the Control key while selecting all of the data in cells A2 through A12, and then without lifting my finger up from that Control key, I also selected the cells D2 through F12. Also, I'm doing this on a Windows machine. If you happen to be using Excel on a Mac, you need to keep the Command key pressed down instead of the Control key. Just the usual Windows to Mac translation of keys. In any case, let's click on the Insert menu item up top. We navigate towards the Charts section, which is in the center. There's a little icon there which looks like a waterfall chart. We click on that. It opens up many different kinds of charts, which include a waterfall, funnel, stock charts of various varieties, surface charts, and radar charts. We'll have more to say on all of that. Also note that at the very bottom, there's a little button which tells us that there are more stock charts available beyond the 4 you see in the center of this dialog. In any case, we now hover over the first of the 4 stock charts, and the tooltip tells us that this is a high, low, close chart. As that same tooltip tells us, this is a great type of chart to show the trend of a stock's performance over time, and we ought to use it when we have 3 series of price values, high, low, and close. Note that that's exactly what we have in this instance. So we click on that, and a high, low, close chart gets added to our workbook. Well, to begin with, it doesn't seem to be a lot to look at. In fact, those different high, low, close values are barely discernible. Clearly, we are going to have to change the formatting of this chart. Well, one clue as to why this chart looks this way is on the y-axis. You can see that it ranges from $0 to $600. Now, we don't have any prices lower than $430, so that's clearly an extra large range. We've got to truncate that range on the y-axis. We click on the y-axis, then right-click and choose the Format Axis command. This brings up the Format Axis dialog over on the right, and we now specify new bounds. We set the minimum bound to be $400. We don't change the maximum, which is automatically set at $560, and instantaneously the appearance of our chart improves a great deal. There are lots of other access options that we could tweak, but none of them particularly relevant here. So we can close those cards and then use the drop down up top in order to apply individual customizations to the series for the high, low, and close data. Let's start by selecting the series low. We are going to apply distinctive formatting, which is going to make it clear within each point where exactly the low value was. When we selected the low, you can see that the low level on each point has been highlighted in the chart. Also note that in the worksheet, cells E3 through E12 have been selected as well. Let's now click on the marker tab over on the top right, that's in the Format Data series, dialog, and there let's change the point markers so that instead of none, we make use of one of the built-in types. We've experimented with these built-in markers before. This time we are going to go with a bold red circle. And when we do this and when we apply a solid fill, it becomes really clear where the low value in each point was. Let's now do something similar for the high values. From the drop down up top, we choose the series high. Notice how the highlighting has shifted to the high column values in column D. We can also now apply built-in shapes. Here we are going to apply an up arrow. So we choose that up arrow from the list of built-in shape types. We apply a solid fill and we also tweak the color. We are going to give this a nice bright green color. And finally, we are also going to increase the size of these markers. Note how we make use of the size picker up top and we change the size to be 7 points. Finally, we are going to format the series close. And for that, we select that series from the drop down next to the word series options and apply similar customizations there as well. The shape type that we go with is a diamond. We are also going to apply a solid fill. We scroll down a little bit and from the color picker, we apply a bright orange color and then we tweak the size. And with that, we can close the format data series option because our high, low, close chart is ready. We can click out of the chart area in order to see how it looks. And then we hover over the individual elements so that we get the benefit of the tooltips. Right up top is the green arrow which points straight up. That green arrow corresponds to the series high, and that's confirmed by the tooltip. Let's bring our mouse down just a little bit over the orange diamond, and that corresponds to the series close. Once again, the tooltip has the actual value as well as the date. Finally, at the very bottom of the arrow is the low. The low is always going to be the lowest point, so that lowest point is always going to be the red circle, and the top is always going to be the green arrow head. The position of the orange diamond, which corresponds to the close, is variable. You can see that on some days, such as on the 2nd of January, the orange diamond coincides with the green arrow head. And that's because on the 2nd of January, the close of 430.26 was almost exactly the same as the high, which was 430.7. We can see those values in row 3 of the Excel data. However, on some other days, such as for instance on the 15th of January, that orange diamond corresponding to the close coincides with the low. And that's because on the 15th of January, the close, which was 518.5, was almost the same as the low value, which was 516.79. That was significantly lower than the high of 537.84. We've now successfully created a high-low close chart. Let's try out one other type of stock chart in Excel, and that's going to be the open high low close. We'll get to that in the demo coming up next. In this demo, we'll start right from where we left off at the end of the last one. There we had constructed a high low close plot, which is what you can see on screen now. This plot managed to get across 3 pieces of information: the high, the low, and the close, in addition to the date, and it packed all of this into one 2-dimensional chart. In this demo, we are going to try and add one further dimension, and that's the open. And that's going to be called, well, you guessed it, an open high low close chart. Because that type of chart is closely related to the high low close, we won't go over the steps in quite as much detail. So let's plunge right in. Let's select the dates. Remember that we hold down the control key and then select the data for the open, high, low, and close. Also do remember that these Excel stock charts require the columns in exactly this specific order. We can see from the highlighted regions in the Excel sheet that we've selected the data in A2 through A12 and then in C2 through F12. Now let's click on the Insert menu item up top, navigate to the Charts section towards the middle of the screen, click on the little waterfall icon. That opens up a menu. There are 4 stock charts towards the center of that menu. We hover over the second one. This is an open high low close chart. We've already built the high low close, and this one has the additional bit of information, that is the open. At this point, a new open high low close chart gets added to our worksheet. Let's resize it. We can see that this has many of the same issues as the high low close. For instance, the y-axis begins from 0. As before, we edit that y-axis by right-clicking on it and choosing the Format Axis command. That brings up the Format Axis dialog over on the right. We specify the minimum bound to be the value of 400, and the appearance of our graph instantaneously improves. Next, we are going to individually apply formatting to the 4 series corresponding to the open, high, low, and close. But before we do that, let's understand the basic structure of this open, high, low, close chart. You can see it on screen now, and you would be forgiven for thinking that this looks very similar to a box and whisker chart. This open, high, low, close is constructed along very similar lines to a box and whisker. We have a box and whisker for each day. By definition, the lowest point is the low and the highest point is the high. So that explains the whiskers associated with each of these points. Now let's turn our attention to the cylinders in the center for each day. The cylinders are of two types. For all dates other than the 9th and the 10th, the cylinders are white. And that's because these are days in which the market closed higher than it opened. In other words, the close was higher than the open. We can confirm this by looking at the data for any of these days. Take the 2nd of January as an example. The close is 430.26, and that is higher than the open, which is 424.5. And that's why the cylinder corresponding to the 2nd of January is colored white. On the other hand, of the points which are currently visible, we can see that the 9th of January and the 10th of January are both down days. And that's because the close values for these days are lower than the open values. Look at row 8, which has data for the 9th of January. For instance, the close is 481.34, but the open was 497.1. In similar fashion, the close on the 10th of January was 478.15, but the open was 481.79. And because these days saw the close lower than the open, the cylinders for these 2 days are shaded dark. Now that we've understood the construction of this chart, it's easy enough for us to select the individual series using the drop down up above. We've already done this in the previous demo, so we won't belabor the point, but you can separately configure the open, high, low, and close series, all of which are visible in this drop down on screen now. And we can then apply all of the formatting which we've already done in the previous demo in order to get a really nice looking chart like the one you now see on screen. What you see on screen now has a technical term in the world of financial technical analysis, and that term is the candlestick chart. A candlestick chart, which is also sometimes called a Japanese candlestick chart, manages to pack a remarkable amount of information into one two-dimensional chart. At the heart of this candlestick chart is the construct of the box and whiskers. The whiskers correspond to the high and the low. The box in the center contains the open and the close, and the color of the box tells us whether this was an up or a down day in the market. Let's now go back into the insert menu, and we can see there that there are still 2 more types of stock charts that we have not covered. The one that we just constructed was the open, high, low, close, for which you see the tooltip. There are 2 more types of stock charts over to the right. We are not actually going to talk about those in more detail because those are the exact equivalents of the 2 charts we've just built, with the only additional information of the volume, and that volume is encoded in the form of a bar chart. You can see that from the little illustrative icons in this menu on screen now. So this gets us to the end of our exploration of the stock chart types in Excel. There are 4 such types supported. We constructed 2 of them. The other 2 are closely related to the 2 that we constructed. And in the demos coming up ahead, we can turn to other exciting types of visualizations such as radar charts, tree maps, pie and donut charts, and box and whisker plots. Our exploration of stock charts showed how a visualization can convey information about many different dimensions even using just a simple 2D format. We saw, for instance, how the candlestick chart presented information about the open, high, low, and close, as well as the date, using an ingenious method which combined a box and whisker construct along with a shaded color. In this example, we are going to turn to radar charts. Radar charts are also used in order to display multivariate data. If you've not encountered radar charts before, you might find them slightly hard to understand. In any case, they are a valuable tool in the toolkit of any data analyst. So let's go ahead and get started. On screen now is the simple data set that we will be making use of. We have rows corresponding to skills, and then we have columns corresponding to employees. These skills are traits. These are effectiveness characteristics of employees in a workplace setting. Communication, punctuality, problem solving, meeting deadlines, whether that employee is a team player, and a level of technical knowledge. The columns correspond to the employees Luke, John, Mark, Susan, and Tom. This is a good example, a simple but good example of multivariate data. There are multiple rows and multiple columns, and we would like to get all of this information across in just one compact visualization. And for this, we are going to try and use a radar chart. You should be aware that radar charts have some limitations, and one of those limitations is that they work best with fairly small data sets like the one that you see on screen now. You would not think of making use of a radar chart with data which has hundreds of rows or columns. In any case, let's go ahead and get started. Let's select all of our data, click on the Insert menu item up top, navigate to the Chart section, and click on Recommended Charts. Now you should be aware that radar charts are unlikely to show up in the list of recommended charts. They are just not all that commonly used, and that in turn is because, as I said a moment ago, they have some well-known limitations. So we click on the All Charts tab, and there we find radar in the list of visualizations available on the left. When we click on radar, we can see the different types of radar charts supported on top. You can see that there are three icons. The first of these is a simple radar chart. The second is merely a radar chart with markers, and the third is a filled radar chart. So there isn't a great deal of variety in terms of the number and types of radar charts supported in Excel. Let's just go with the simple radar chart to begin with. We hover over the first template on the left and a preview appears. Let's go ahead and hit OK, and this chart is going to get added into our Excel workbook. And now let's take a moment to understand this chart in more detail. First, let's pay attention to the shape of this chart, which is hexagonal. The reason that this chart is hexagonal is because there are 6 axes, and those 6 axes correspond to the 6 skills: communication, punctuality, problem solving, meeting deadlines, team player abilities, technical knowledge. So in a radar chart, the shape of the underlying axis is going to correspond to a polygon, and that polygon is going to have as many sides as we have dimensions. Next, note that we have curves corresponding to each of the columns, and those columns in turn correspond to the employees. And that's why we have Luke, John, Mark, Susan, and Tom. Now, along each axis, points are plotted based on the individual scores, and those points are then combined using a curve. To see what this means, let's consider one of these curves, say the one for John. You can see that for John, along the team player axis, he has a maximum score, and that maximum score is 5. The reason that that score is where it is because if we look at the column for John, that's column C, we can see that his score in row 7 is equal to 5. In a similar fashion, he also scores a 5 on punctuality, and that's why the curve for John intersects the punctuality axis at the extreme right. When a particular individual scores low on a particular skill, that point is very close to the origin. You can see, for instance, that the gray curve corresponding to Mark is very close to the origin along the axis of technical knowledge. And that's because Mark only scores a 1 on technical knowledge. You can see that in cell D8. Now, how might we use a radar chart like this one? The primary use case is to quickly eyeball the areas under the individual curves. For instance, in this example, we can see that the red curve, that's the one corresponding to John, seems to enclose a great deal of area. And that in turn would suggest that in aggregate, John's scores are pretty high. That's also confirmed by looking at the data present in column C. Most of John's scores are either 4 or 5. He only has a 3 on meeting deadlines. So the area under the curve for John is pretty large, and that in turn is because John's scores are large. The other advantage of a radar chart is that it quickly allows spike areas to jump out. To see this, let's look at the gray curve. This one corresponds to Mark, and you can see that the gray curve spikes out along the communication axis. And this in turn would suggest that while Mark's overall skills, as measured by the area of his total curve, might not be all that great, in the axis of communication, Mark scores really well. And that's confirmed by the contents of cell D3. And this brings us to one of the primary use cases of radar charts, which is identifying outliers. In the field of human relations, for instance, there is a practice known as strengths based hiring, which tends to reward employees for areas in which they are exceptionally strong relative to their peers. Given data for employees and their skills, a quick way of identifying those spike areas, as they are called, is using a radar chart. Now, we've mentioned more than once that radar charts suffer from some limitations, so let's also enumerate those limitations. One limitation has to do with the size of the dataset, as we've already discussed. These make sense for small or moderate sized datasets. As the number of dimensions increases, the underlying coordinate shape is going to approach a circle and become harder and harder to interpret. A second limitation has to do with the axes of the polygon. You can see here that visually we might think that communication and punctuality have some similarity or are more related than, say, communication and meeting deadlines, merely because communication and punctuality appear next to each other in the hexagon. But this isn't actually the case. And this brings up another limitation, which is that neighboring variables seem like they are related when they actually are not. In similar fashion, the fact that the area under the curve is an aggregate measure of the total scores makes these charts hard to interpret. After all, how do you quickly estimate the area of an irregular polygon like the ones you see on screen now? Let's take a hypothetical question like, which of these individuals has the highest aggregate or average score? It's almost impossible to answer that question from a radar chart. The area based measurement has another flaw, however, and that has to do with the fact that areas scale as the square of their sides. So, relatively small differences in the individual scores can lead to very large differences in the areas. This again is not a very desirable characteristic. Finally, a radar chart will only work when all of the axes have common units and where all of those variables are naturally ordinal, which means that they can be ordered. In our example, we have data which has been constructed to satisfy these conditions. We have ordinal scores between 1 and 5, all measured on the same scale. And this is why a radar chart was a good choice here. However, had we been making use of data with, say, different currency units, a radar chart would have been a very poor choice. We spent quite a bit of time understanding the limitations of radar charts, but you should know that they are great for very narrow, restricted use cases like exactly this one. So let's continue with our exploration and let's change our radar chart so that we swap around the traits and the individuals. We are going to do this as usual by making use of the change chart type button up top. We've already used the copy and paste commands in order to create a duplicate of our original radar chart. Now we click on the change chart type button up top. We're still going to stick with the radar chart, but we are now going to make use of the template on the right instead of the one on the left. Let's quickly hit OK and add this to our workbook. And now we can see that the shape of the second radar chart is different from the one above. The one above is a hexagon, the one below is a pentagon. And of course, that makes sense because the one on top has 6 axes corresponding to the 6 traits. The one below has 5 axes corresponding to the 5 individuals. As always, a change in the variables represented on the axes gives us some new insights. We can see, for instance, how Mark is clearly an outlier on communication, and that's because the light blue curve corresponding to communication comes really close to the edge of the axis for Mark. We can also see that Susan seems to score high on more attributes than some of the other individuals because there are more curves which come right up to the edge of the Susan axis. And this is confirmed by eyeballing the data in column E. Susan scores 5 on no less than 3 attributes. There are no other candidates who have the highest score of 5 on so many attributes. We've now got a good sense of the creation of radar charts and their advantages as well as some of their limitations. In the demo coming up ahead, we'll turn our attention to some of the finer points of formatting and using the other two types of radar charts supported in Excel. In this demo, we will pick up right from where we left off at the end of the last one and continue our exploration of radar charts. We currently have two radar charts. In order to keep our workbook organized, let's select the columns H through O which contain these charts and then use the data outline menu item in order to group these together. So we click on the data menu item up top, then click on the outline button over on the right, and then choose the group option. A set of handles appears above columns H through O. Let's first select these two charts. We'll do this by using the Ctrl C keyboard shortcut, and then we collapse the columns containing them. We now use the Ctrl V keyboard shortcut in order to paste copies of these two charts into the worksheet. So let's select one of these two charts, use the right click menu, and then use the change chart type command from in there. This in turn opens up the same dialog which we have worked with many times before. There are three types of radar charts supported in Excel. The current chart type is just radar, that corresponds to the first icon on the top left. Let's now click on the second icon and we can see from the name which appears down below that this one is called radar with markers. We can get a quick look at the preview. We can see that there's nothing really different other than the addition of the line markers, and then we hit OK and add this to our worksheet. Now you can see that the top chart has the radar with line markers, the bottom is still an ordinary radar chart, so we repeat the same change chart type operation and convert that one also into a radar with markers. In general, the radar with markers is a bit more readable than just the plain radar, and that's because of the way in which the radar chart is constructed. Remember that we take the individual scores, mark them out along each axis, and then connect the points that we have obtained in this way. When we add the markers, we can clearly see those points that have been connected by the lines. And so, for instance, it's easy for us to precisely identify the scores of an individual along different trait axes. In this particular zoomed in version, we can also see something interesting about the axes themselves. Here we have 5 axes corresponding to the 5 individuals: Luke, John, Mark, Susan, and Tom. And that's why the axes are represented in the form of a pentagon, or to be precise, in the form of many concentric pentagons. You can see that there is a really small pentagon right at the center of the chart. This corresponds to a score of 0. That smallest pentagon does not have any points on it, and that's because there are no scores of 0 in our dataset. If we go one level out radially, we come to the second smallest pentagon. And there are multiple points on that second smallest pentagon, which corresponds to a score of 1. For example, the green curve intersects the second smallest pentagon on the axis corresponding to Mark. Now we can see that the green curve is for technical knowledge. We see that from the legend over on the right. And from this, we can infer that Mark scores a 1 on technical knowledge. And that can be confirmed by looking at the data in cell D8. Mark indeed does have a 1 on technical knowledge. Then let's turn our attention to the deep blue curve. That deep blue curve also intersects that pentagon, which corresponds to a score of 1 on not 1 but 2 axes. And that deep blue curve corresponds to being a team player. We can see from this that there are 2 individuals who score only 1 on their ability as team players. Which individuals are those? Well, just look at which vertex has been intersected. The first vertex is that for Susan and the second is that for Tom. And we can confirm that the scores for Susan and Tom on their being team players is indeed 1. We can see those values in the cells E7 and F7. In similar fashion, we can use this radar chart with markers in order to get much more detailed information about the scores of individuals along different trait dimensions. A radar chart with markers is thus better for low-level questions. A radar chart without markers is probably better to get a quick intuitive sense of which individual has the most area under his or her curve. We can customize the appearance of this radar chart with markers in just about any way we like. So we can right click, format the data series, and perform various operations with different kinds of marker options. We can try out the built-in shapes, adjust the sizes, and various other such customizations. Because we've performed these on many occasions in the past, notably with the stock charts, we are not going to spend a lot of time discussing these. But once we've had our fill of tweaking their appearance, we can again hide these columns using the same data outline and group mechanism, and then copy paste them in order to move on to the third and final type of radar chart, which is the filled radar chart. So we've selected the chart on top, then we right click and use the change chart type button. And now we click on the third icon that corresponds to the filled radar chart. You can see that name down below. As always, there are two templates, and let's quickly make use of both of them. So we change the first chart to the first template and the second chart to the second template. At the end of this process, we are left with two filled radar charts on screen. One of these has axes corresponding to the individuals, that's the one below, and the other one has axes corresponding to the traits, that's the one above. What jumps out right away is that all of these filled areas overlap each other, and this is a serious drawback. Here, let's bring one of our charts forward and expand it. That doesn't really make the chart any clearer. It's a serious problem with a filled radar chart that you cannot see the surfaces corresponding to the points below. You only can see those right up top. This explains why the filled radar chart is probably not a great choice, but even so, there might be situations in the workplace where you are constrained and you have no choice but to use this. What can you do in such a situation? Well, let's turn back to a similar problem which we had dealt with while working with some types of area charts, specifically non-stacked area charts. You might recall that we had the exact same issue there because those also were filled charts where some surfaces on top obscured the ones below. And we had solved that problem, at least partially, by changing the transparency of the different data series. So that's exactly what we are going to do in this case as well. This is a handy trick, and you should keep this in mind whenever you have the problem that we've encountered here. So one by one, we select the data series, right click, choose the format data series option. Then in the pane over on the right, we switch to the marker tab. We play around with the fill and the transparency until we can see the surfaces below the one on top. We've made this change to the series for Tom. We now have to go ahead and do the same for every one of the other series. This is a slightly painstaking process, but by the end, we get a filled radar chart where all of the surfaces are at least somewhat visible. And in this way, we have overcome one of the chief weaknesses of the filled radar chart. This gets us to the end of our exploration of radar charts. There's a reason why radar charts are a relatively specialized type of visualization, and that reason is that they have many limitations which prevent their use from all but a few specific use cases. But when those use cases do arise, they are a great way of getting across multivariate information on a two-dimensional plot. And those use cases include small and moderate sized datasets containing ordinal data, all of which has been measured on the same scale. And that's a perfect description of the dataset we employed in this example. How do you visualize parts that make up a whole? This is a really common question and common problem in data visualization. There are many different types of visualizations exactly for this purpose. If you would like to plot parts of a whole at a moment in time, one choice is a pie chart. We are going to get to pie charts in a subsequent demo. If you would like to view how parts of a whole change over time, then you could go with either a stacked column or bar chart if you have categorical data, or a stacked area chart if you have continuous data. In situations where you have hierarchy, however, that's an additional level of complexity. And that's the kind of data you see on screen now, where we have hierarchy consisting of categories, subcategories, and then sales. So we now like some kind of data visualization which will give us a sense of parts of a whole, which includes detail about the first level of the hierarchy, which is the category, as well as the second level of the hierarchy, which is the subcategory. And this is exactly where a specific type of visualization called the tree map comes in handy. Let's go ahead and try it out. As usual, we start by selecting our data. Now we can make use of the little button in the bottom right of the selected range. We've used this button on multiple occasions, so let's take a moment to learn more about it. This button also comes with its own tooltip, and that tooltip tells us that this is the quick analysis control. You can see that there is a shortcut, and that shortcut is Control Q. So do keep this in mind. Anytime you have data in Excel that you'd wish to analyze really quickly, if you find yourself missing this little button, all you need to do is to hit Control Q. Remember, Q for quick analysis. When we click on it, a tabbed dialog opens up. The tabs here include formatting, charts, totals, tables, and sparklines. Let's click on the charts tab. A tree map is not one of the recommended options, but we can just click on the more option over on the right. This opens up the insert chart dialog. And here you can see that it does indeed have the tree map right up top in the list of recommended charts. And that's because Excel was able to pick up on the hierarchical structure of our data. As an aside, also look at the second recommended chart type on the top left. That's known as a sunburst plot. Sunburst plots are a great alternative to tree maps when you're working with hierarchical data. However, as the number of levels in the hierarchy increases, you might find tree maps a little handier. And that's probably why the tree map recommendation has appeared above the sunburst recommendation. The pane on the right shows that there's just one kind of tree map in Excel, so we don't have a whole plethora of types or variants of tree maps. As the little note below tells us, a tree map represents data values as the area of rectangles. So in our example, the greater the sales, the greater the area of the corresponding rectangle. And of course, this is great for representing hierarchical information. Let's hit OK, and the tree map gets added to our Excel worksheet. Let's take a moment to orient ourselves with this data. We can see that we have three groups of rectangles which are colored gray, blue, and orange. And as the legend up above tells us, these correspond to the values of the category column, that's column A. So the gray rectangles are all from the category technology, the orange rectangles are all from office supplies, and the blue rectangles are all from furniture. Within each category, we can see the category name in the top left of the topmost rectangle. So for instance, in the technology category, we can see that the rectangle corresponding to phones has the category name in the top left. In the furniture category, it's the chairs rectangle which contains the category name, and in office supplies, it's the storage category. The subcategory values appear at the bottom left of each rectangle. You can tell just by looking at it that the tree map is a very elegant and sophisticated looking visualization. You should try and find opportunities to use it as often as possible. That, however, does not mean that tree maps have no limitations. Let's quickly understand some of them. For one, you cannot plot data which has negative values using a tree map because, of course, the rectangle's area cannot be negative. It's also important for all of the units being represented to be the same, otherwise, the magnitudes on the areas will get out of sync. Finally, the fact that it's the area which is proportional to the magnitude gives rise to another limitation. Small data items really can get lost and almost completely obscured in a tree map. This is a limitation of all types of charts in which the area is used to represent the magnitude. We discuss this in the context of radar charts as well. Here, for instance, you can see that really small selling subcategories, such as, for instance, fasteners, which have sales of just about $3,000, you can see that in cell C10, and labels, which have sales of about $12,486, that's in C11. These two categories are barely visible. They are squished into the bottom right corner, and the labels for these categories are either truncated or not visible at all. So again, the differences in the magnitude of data items can get accentuated with tree maps. Now that we've understood what tree maps are and how they work, let's set about customizing them. Because we are quite well versed with customizing visualizations, we are going to do this somewhat quickly. We can start by using the chart elements drop down on the top right, and that in turn allows us to vary the overlay, the position of the data labels. We can also format those data labels using the dialog on the right. You can see that there are options corresponding to the series name, category name, and value. At this point, we've selected all of those checkboxes, and that's why the information for each subcategory now includes all of these properties. The series name, category name, and value are all in there. We can also control the separator, the manner in which currencies and other categories are represented, and the number of decimal places. You can see here that we've now specified the dollar symbol with 0 decimal places and comma separators. This gives a nice finished look to the number representations for the sales. All of this is being done with the little bar graph icon highlighted on the top right. Let's switch over by clicking on the paint bucket icon. There we can experiment with fills. We can also change the patterns, textures, transparency, and other properties of all of those labels. After cycling through many different alternatives, we decide that the simple automatic pattern is the best, and so we just revert to that. Notice as usual that there is a little drop down up top next to the word label options. If we click on that, we can choose which element of our chart we wish to modify. The choices include chart area, chart title, and so on. From this menu, let's select the legend. This brings up a different set of options which we have not worked with so far. Here we can control the legend position, and down below is a checkbox which asks whether we'd like to show the legend without overlapping the chart. Let's toggle the value of the checkbox, and as you can see, this changes the appearance of our tree map quite a bit. As usual, thanks to the power of Excel, there's just no end to the customizations, so we can also change the fill, color, and transparency of the legend. We can apply texture fills, pattern fills, and a whole bunch of other sophisticated customizations. And then once we've had our fill, we go back to the drop down up top, and from that drop down, we select the series that's called sales, which is being represented in this tree map. This series can also be customized in many different ways. Let's focus on the series options. You can see here that there are label options such as none, overlapping, and banner. Let's take a moment to understand the banner option. You can see that when we select this from the list of radio buttons, we now have headings above each group of rectangles, and those headings have the quantity that's being plotted using the area, that's the sales, followed by the name of the top level category. So the first group of rectangles is titled sales, technology, the second one is titled sales, furniture, and the last one is titled sales, office supplies. Another useful set of customizations has to do with the fill color of the chart itself. We can cycle through the usual suspects: no fill, solid fill, gradient fill, picture or texture fill, and pattern fill. As is often the case, after experimenting with a bunch of gaudy designs, we decide that the automatic color scheme was the best. Next, let's turn our attention to the border card. So we expand that card and collapse the fill card. And using the border card, we can control the color and other properties of the borders between the rectangles. You can see that this is an important way in which to customize your chart. The effect on the chart itself is subtle but quite pleasing. Once we've had our fill of customizing the appearance, we can close this dialog by clicking on the cross button on the top right. This takes us back to the Excel workbook. Now notice here that there are two little buttons on the top right of the tree map itself. So far we were working with the top of those two buttons, the one which looks like a plus sign. As you can see from the tooltip, this is the chart elements button, which we can use in order to add, remove, or change chart elements. Let's click on the second button, the paintbrush. The tooltip tells us this is the chart styles dialog, and when we click on it, a dialog opens up over on the left. That dialog has two tabs, style and color. We can quickly navigate through it and see that we can apply different styles to our tree map. We've now understood the basics of creating tree maps, we've understood how they work well with hierarchical data, and we also have a sense for some of their limitations. It's time for us to move on. We're going to talk about pie charts and donut charts in the demo coming up ahead. Make the common case easy and the difficult case possible. This is a well-known dictum from various fields including product management and computer architecture, and this also applies to data visualization. A common use case is when we wish to view composition and parts of a whole. These are parts of a whole at a given moment in time. And it is for this really common and really simple use case that the pie chart is an ideal type of visualization. More complex kinds of parts of whole visualizations, which include time trends or hierarchical information, could be solved using stacked charts such as stacked bar or stacked area charts, and tree maps for the hierarchical use cases. But again, for the simple parts of a whole analysis at a given moment in time, it's hard to beat the pie chart. Let's go ahead and get started. On screen now, we have data corresponding to the sales of various computer brands. These are in column A. Then we have the number of units sold in two quarters, quarter 1 and quarter 2. These are listed in columns B and C. Remember that pie charts are for one moment in time, and so we select the data for quarter 1 alone. We select the columns A and B, and then we click on the insert button up top. we navigate to the chart section, and there we click on the little pie chart icon. You can see that there are 5 commonly supported variants of pie charts in Excel. 3 of these are 2D pie charts, there's one 3D pie, and then there's a donut. We'll be talking about all of these in detail. Let's get started with the simplest, which is the simplest 2D pie. As soon as we hover over it, a preview appears, as does a tooltip. And that tooltip tells us that the pie chart is great for showing proportions of a whole, and we ought to use it when the numbers sum up to 100%. The second bullet point there makes an interesting point. It tells us that the chart should only contain a few pie slices because many slices make the angles hard to estimate. As we shall see, this problem can be partially solved by using the 2 other types of 2D pies. You see the little icons for those. Those are known as pie in pie and bar in pie. More on those in a subsequent demo. In any case, let's click on this 2D pie and our first pie chart appears. As expected, it has a full circle, so there are slices corresponding to each brand in column A. Let's get started customizing the chart by clicking on the plus icon in the top right. This is the chart elements control, and here we can control the chart title, data labels, legends, and so on. Let's add data labels. These give us the total sales for each brand in each quarter. Let's just take a moment to orient ourselves with this pie chart. Remember that the sum of angles in a circle works out to 360 degrees. So if we took the sum of all of the angle slices, that would sum to 360 degrees as well. Now the angle of a slice determines its area, and that's why the larger the sales in the quarter, the larger the area of the slice. We can see, for instance, that the green slice, which corresponds to Samsung, has a far smaller area than the adjacent large blue slice for Apple. And that's because Apple sales were $4,876, Samsung sales were only $1,867. And the areas of these 2 slices are going to be proportional to those numbers. Now that we've understood the basic idea of the pie chart, let's experiment with a few different customizations. We experiment with several different choices of position for the data labels. The choices include center, inside end, outside end, best fit, and data callout. Data callout is what you currently see on screen. Let's also explore the more options available at the end. When we click on that, a dialog opens on the right. Here we can specify even more customizations. To begin with, let's change our pie chart so that the labels are now taken from a specific range. This specific range need not always be the same as the actual data that's being displayed. So to enable this, we check that box called value from cells, and then we navigate to a range of our choice. Here we decide to just navigate to the same range which we've already displayed, but this need not always be the case. We now hit OK. We can also select checkboxes to include or exclude the series name, category name, value, percentage, leader lines, and legend key. Also note how we can specify the separator. Here that's the comma separator, and then there are label positions down below as well. Customizing the labels in a pie chart is a common operation, so it's important that we understood it in a bit of detail. We'll now move on to other customizations which we've covered before. We'll skip over these a little faster. For instance, we can uncheck the value from cells, turn on the series name, use different kinds of fills. You can experiment with these as well as with text fill options. These are only going to fill the labels. We can see that we are now changing the font of the labels with each slice of our pie chart. It actually helps to have these in a light font. The light font stands out against the dark background of the slices. We can also customize what precise information is included in the labels. We can turn on or off the series name, category name, and the percentage. This is an important one, so let's take a moment to understand it. By checking that little checkbox called percentage, we are quickly able to tell what percentage of the total comes from each brand. We can see, for instance, that Apple contributes 22% of quarter 1 sales. On the other hand, Samsung contributes only 8%. This is a very common operation, and so you should keep in mind the use of this percentage checkbox. We continue experimenting with various other settings in this label options tab, and once we've had our fill, we navigate to the drop down up top next to the label options. The choices there include the chart area, chart title, legend, and plot area. Those are the usual suspects. And then the series, which is quarter 1. And finally, the data labels of that series quarter 1. So far, we've been working with the data labels as the last option, but now we're going to click on the second last option and modify or customize the data series itself. At this point, we can see that there is a grayed out set of radio buttons for the primary and secondary axis. That's not relevant in the case of a pie chart because there is no secondary axis possible. Then come two sliders, both of which are important. The first is titled Angle of First Slice and the second is titled Pie Explosion. Both of these are initially set to 0 degrees, but let's tweak the values on the sliders and see what happens. When we change the angle of the first slice, in effect we rotate our pie chart. This has the effect of moving the relative location of the slices relative to what? Well, relative to the x and y axes. So the angle of the first slice matters if you would like to have a particular slice in a particular corner, the top or bottom, right or left. In case you're wondering why this matters, well, remember that most visualizations from Excel are going to be used in the context of presentations, and those presentations might have specific requirements in terms of layout and the appearance or position of a particular slice. In similar fashion, we can control the explosion of the different slices in the pie using the second drop-down. Right now, the pie explosion is set to 0, and so all of the slices meet at the center like an uncut pizza. However, if we change the pie explosion angle, the slices no longer meet at the center. It's as if our pizza has been cut up into pieces. This pie explosion can also help with the precise layout of our pie chart. However, an even more common operation is where we wish to only separate out or explode one particular slice of the pie. How is that to be accomplished? Well, the answer is simple enough. We click on the slice which we would like to explode. So please pay careful attention to the mouse. We've clicked on the slice for Acer, and as soon as we clicked on Acer, there was a very subtle change in the format dialog over on the right. That dialog is no longer titled Format Data Series. Instead, it reads Format Data Point. And if we look really closely at the second of the two sliders, that slider no longer says pie explosion, it now says point explosion. And now if we change the angle in that slider, it's only the slice for Acer that's going to be exploded in or out. This is a really important operation while working with pie charts, and so you should be sure that you understand how to accomplish this. Again, you select a particular slice, you go to the Format Data Point dialog over on the right, and then you use the Point Explosion slider in order to control precisely the location of an individual slice. We've now covered the important aspects of the basic pie chart. Let's select our chart and click on the Change Chart Type button over on the top right. And there, let's click on the second icon. This is the 3D pie. As we can tell from the preview, the 3D pie is almost indistinguishable from the ordinary 2D pie. The main difference is in the slight shadow effect and the slight angle or perspective that is visible at the bottom of the lowermost slice, here the one titled HP. We can perform all of the same operations, so we can right click and format plot area. We can also adjust the angle of the slices as well as the pie explosion. Exactly as before, we can either explode out all slices of the pie, or we can click on one slice and only change the point explosion angle for that slice. Let's round out this demo by quickly learning how to exclude specific slices. We begin by clicking on the Select Data button that's on the top right. This opens up the Select Data Source. We need not change the chart data range, that remains as before. We also need not change the legend entries on the bottom left. We can, however, eliminate access labels from the bottom right. We currently have checkboxes for each of the brands checked. We can change that. Let's uncheck the boxes for Dell and Asus. And once we are satisfied with this, we can hit OK. As soon as we do this, the number of slices reduces by 2. We no longer have the slices for Dell and Asus. The 5 remaining brands are still in there. To add those back, we again click on the Select Data button on the top right, and then we again check the boxes for Dell and Asus. And at this point, we confirm all the other boxes are checked as well and hit OK, and we are back to having all of the slices in our chart. This gets us to the end of this first demo, which dealt with the simplest types of pie charts. We'll now turn to some of the other intricacies of pie charts before moving on to donut charts in the demos coming up ahead. In the previous demo, we explored all of the intricacies of the basic 2D and 3D pie charts. In this demo, we're going to try and understand two variants, the pie of pie and the bar of pie. Let's get started by clicking on the Change Chart Type button over on the top right. We are still in the list of pie charts. We currently have the 3D pie selected, but we click on the third icon, that's the one just to the right of the 3D pie, and that opens up the pie of pie dialog. This preview on screen now gives us a sense of what the pie of pie is all about. The basic idea is that we have one large pie chart over on the left, and that has a section or a slice called Other, and that slice is then going to be expanded in the smaller pie chart over on the right. Let's hit OK, and a pie of pie chart is added into our workbook. As usual, let's take a moment to orient ourselves with this graph. The large pie chart over on the left has individual slices for Acer, Dell, Asus, and HP. You can see those slices, and you can also see that those are the first four rows in the source data. These are the rows 3, 4, 5, and 6. Then we have that large dark brown slice titled Other, which accounts for 43% of the whole. And it's that Other which has been expanded out in the smaller pie chart over on the right. And you can see that that pie chart in turn consists of Apple, Samsung, and Lenovo. We can see the percentages of those three brands as well. Apple is 22%, Samsung is 8%, and Lenovo is 13%. Those three numbers add up to 43%. It's clear from this that the choice of the other slice from the first pie chart is based on the order of the rows. At least that's what's done by default. Now, it does not make a whole lot of sense to have the largest single brand, which is Apple, consigned to the other and then only expanded over on the right. So we are going to have to change the criterion on which the other slice is computed. We'll get to that in a moment. But before that, let's note that the pie of pie is a handy construct when we have a very large number of data points. You might remember the tooltip which we saw when we first experimented with the 2D pie chart. It told us that pie charts work best when we have a relatively small number of slices. If we have a very large number of slices, the pie of pie is an option. We can collapse all of the large number of small slices into the other slice. Next, let's get on with the task of fixing that other slice. So we right click on the chart and choose the Format Chart Area option. This in turn brings up the Format Chart Area dialog over on the right. We click on the drop down up top and navigate to the Series Lines 1 option. This in turn brings up a tabbed pane. You can see that the currently selected pane corresponds to the paint bucket icon, but we use the mouse to click on the little bar chart icon in the top right, and this is where we are going to be able to control the exact composition of the other slice. Currently, we've split our series by position, and the number of values in the second plot is equal to 3. Let's see how we can adjust both of those properties. We click on the first drop down, and in addition to position, the other possible choices there are value, percentage value, and custom. For now, let's click on value. This in turn changes the UI so that we can now specify a specific value. That value is going to serve as a threshold in order to determine whether a point appears in the first or the second series. Notice that as soon as we chose value from the first dropdown, the appearance of our graph changed. Now we have no values at all in the small pie chart over on the right, and that's because the value threshold is set to 1.0. That's a very small number. It's far smaller than any of the sales figures that we have in column B. And that's why based on this condition, we had no slices at all in the second series. All of the slices now appear in the main pie chart on the left. What if we type out a much larger value in the text box? You can now see that all of the values were smaller than this threshold, and that's why nothing at all appeared in the pie chart on the left. We just have one slice other which equals 100%, and then all of the actual slices appear in the pie chart on the right. After swinging between both extremes, let's type in a sensible value there. That's now $2250. And at this point, we have only two brands, Samsung and Acer, which have sales below this number. And that's why those two brands appear over on the right, and they are a part of the other slice in the pie chart on the left. Let's tweak that value and make it 3250. This causes one more brand, that's Lenovo, to be moved into the other category, and it now appears in detail on the right. Now, manually entering these dollar numbers is a bit cumbersome, so let's switch to split series by percentage value. Now, the threshold is set in terms of percentages. It's now at 10%, and that's why the only slice which appears by default in the pie chart on the right is Samsung, and that's because Samsung only accounted for 8% of sales in quarter one. Note that as we use those spinner buttons in order to increase the percentage threshold, additional brands get transferred over to the pie chart on the right. At this point, we have Samsung, Lenovo, and Acer. Note that 8% plus 13% plus 10% exactly equals to 31%, which is what we can see next to the other slice in the pie chart on the left. Note that there are also controls to tweak the pie explosion angle, the gap width, and the size of the second plot. We can experiment with all of these different properties, and you can see that it's possible, for instance, to make the plot on the right much larger or much smaller than the one on the left. Finally, let's turn our attention to one last remaining way of splitting series, and that's the custom choice. So we've selected custom from the split series by drop down, and now we get to exercise the ultimate level of control on where a point appears. We click on a point in the bar chart. To pay close attention with the mouse, we are clicking on the orange slice for Dell, and then we make use of the drop down, which tells whether this point belongs to the first plot or the second plot. That drop down is currently set to first plot, but we change that and Dell moves over to the plot on the right. We then click on other slices. We've now clicked on HP and move that to the second plot as well. And we finally do that for Apple as well. And by the end of this process, we have customized exactly which brands we'd like to appear in the second plot. We clicked on each of those brands one by one and then changed their position using the drop down on the right. We've now thoroughly understood the pie in pie chart type. Let's click on the change chart type button on the top right. The change chart type dialog opens up. All possible chart types are listed over on the left. We still have type of chart pie chosen on the left, and that's why we are still navigating through the different types of pie charts. We can see that there are 5 icons over on top. We are currently on the third, that's pie of pie. Let's now click on the fourth one, and that's called bar of pie. We can see from the preview that bar of pie is very closely related to pie of pie. The only difference is that the ancillary illustration over on the right is now a stacked bar chart rather than being a pie chart. Let's go ahead and hit OK, and a bar of pie appears in our workbook. Again, we can see that the split and all of the other properties have been carried over even after we changed chart type. So we have a pie chart over on the left and a bar chart over on the right. That bar chart still has the same setting. We still have the same 3 brands, Dell, HP, and Apple, which we added to the series on the right, and that was done using a custom split. What's more, we can confirm this from the split series by custom, which we can still see over on the right. That's in the format data series dialog. Let's take a moment to tweak the settings such as the pie explosion angle. All of these visual aspects can be controlled in exactly the same fashion as with the pie of pie. The important bit, however, is that the split series dropdown still has the exact same choices. As for the pie of pie visualization we were working with a moment ago, you can see that the current choice in that dropdown is custom. The other choices are position, value, and percentage value. Of course, these are the same choices which we've already worked with in detail. In fact, there's an even better little feature here. If we click on one of these, let's say value, we find that the last value which we had entered into that text box has actually been remembered. You might recall that we had last entered a value of 3250, that was the threshold value, and that's why in the current bar of pie, we have a pie chart with a slice called other, which accounts for 31%, and that slice has been expanded in the bar chart over on the right, and that includes all brands where the value of the sales is less than $3250. There are 3 such brands: Acer, Samsung, and Lenovo. We've now come to the end of our exploration of pie of pie and bar of pie visualizations. In the demo coming up ahead, we are going to explore the last variant of pie charts that's commonly supported in Excel, and that is the donut chart. We had started our discussion of pie charts by remarking that they make the common use case really easy. That common use case was analyzing parts of a whole at a moment in time. The basic 2D and 3D pie charts also had another limitation. They are not very suitable for cases where we have a very large number of very small slices. We mitigated that limitation by using the pie of pi and bar of pi charts. You can see the bar of pi on screen now. Both the pi of pi and the bar of pi allow us to combine a large number of slices into a catch-all category called other, and then expand on that other category in a secondary visualization on the right. And Excel makes it easy for us to control the relative sizes of the right and the left side visualizations. It's now time for us to turn our attention to the last variant of the pie chart, and that is the donut chart. And as we shall see, the donut chart mitigates yet another limitation of the pie chart. To see this, let's click on the Change Chart Type button on the top right. The usual Change Chart Type dialog opens up. We still have pie selected from the long list over on the left, and we still have the second last icon clicked up top, that is the bar of pi. Let's now click on the sixth and rightmost variant, which is the donut. The terms donut chart and pie chart, of course, both come from the resemblance of these visualizations to the corresponding food items. We hit OK and a donut chart appears in our workbook. Now, this donut chart, which we can see on screen right now, has the exact same information as the corresponding 2D pie chart. So there's nothing really special or better about this donut chart relative to the corresponding pie chart. We can, of course, customize this donut chart just like we would any other chart. We can add callouts or fill colors and various other properties. But really, the use case for the donut chart lies in representing data for more than one point in time. And this is the crucial limitation of the pie chart that is addressed by the donut chart. In all our pie chart examples so far, we've only worked with data for quarter one, but we are going to change that. Click on the Select Data button in the top right, and then expand the chart data range. That's the first control in that dialog. Include the data for quarter one as well as quarter two. You can see that in our current setup, we have somewhat clumsily selected data for both quarters, and we've also included one additional empty row over at the bottom. But that's not a problem at all. Excel just ignores the blank rows. We do need to eliminate the brand from the legend entries, that's the set of series in the bottom right. We do that by unchecking the box for the brand column, and then we hit the remove button. And when we do this, we find that we have only two donut rings corresponding to the quarters 1 and 2. We can see right away that the donut chart packs in a lot of information, but it can be a little hard to understand. We can change that, or we can mitigate that to a certain extent by improving the sequence labels. So let's do that. We add data callouts and also experiment with various settings of category name and series name, but we still don't get the look that we really want. What we actually need to do is to add the axis labels. For this, we click on the Select Data button on the top right. This brings up the same dialog which we used in order to select the source data, but now we focus on the control on the right. That's for the horizontal category axis labels. We can see from the values down below that those axis labels are just the numbers 1, 2, 3, 4, 5 and so on, and that's not what we have in mind. We hit the little edit button, and that in turn allows us to select the names of the brands in cells A3 to A9. Once we're done, we hit OK. This takes us back to the select data source, but we now see that the horizontal category axis labels are the brand names, so all is well there. Now that we've correctly selected the series as well as the axis labels, when we hover over the individual points in our donut chart, we get tooltips which contain all of the necessary information. The current tooltip, for instance, tells us that we are looking at the series for quarter 2 and the point corresponds to the brand Acer. Donut charts are thus successfully able to represent two moments in time, and we could really push it and even represent three moments in time. But beyond that, as you can tell, the visualization would get really busy. We can customize the appearance of our donut chart in all of the usual ways. We can vary the angle of the first slice, the donut explosion, as well as the donut hole size. We can use the drop down up top in order to select individual series and we can use that to change the angle of the first slice, and we can also vary the donut hole size from here. These are very similar to the customizations that we'd apply to a pie chart, and that's why we're going over them relatively quickly. Please note that our donut currently has slices which correspond to the different brands, and then we have two concentric donuts, one for each quarter. As usual, it's possible for us to swap around the quarters and the brands, and to do this, let's explore the last remaining variant of the donut chart. We click on the Change Chart Type button over on the top right. We've currently selected the first variant of the donut chart, that's the template on the left. Let's hover over the one on the right, and you can see that this one has a pretty complex appearance. There are only two types of slices. These correspond to the quarters, quarter 1 and quarter 2. But now we have individual donuts for each brand. Let's try this one out as well just for completeness. So we hit OK and add this into our Excel workbook. This is not a very good visualization, and the root cause is just a very large number of concentric donuts. Let's see if we can fix that by eliminating some of the brands. To do this, let's right click on the chart, use the select data option. This brings up the same select data dialog we've worked with multiple times before. Now from the bottom left, let's uncheck the boxes corresponding to several brands. We do this until we are left with only 4 brands, and that in turn is going to lead to a far simpler donut chart. But of course, then we've also lost the benefit of having the multiple donuts. This whole exercise gets to the heart of the weakness of the donut chart, which is just that multiple donuts make the chart hard to interpret. Let's add back all of the brands, and then let's apply various formatting operations so that we have at least a minimal level of readability. We now have a donut chart on screen where we have donuts for each brand, and we've also managed to convey information for both quarter 1 and quarter 2. This gets us to the end of our exploration of pie charts as well as donut charts. We began with the simplest 2D and 3D pie charts. We saw how different slices can be exploded out. We saw how pie on pie and bar on pie visualizations allow us to add a secondary visual to hold data for an other category. We saw how that other category can be defined in many different ways. And finally, we explored the use of the donut chart, which allows us to represent data corresponding to parts of a whole at multiple points in time. It's time for us to move on to other exciting types of visualizations in the demos coming up ahead. We have now come to the end of this course, plotting stock charts, radar charts, Treemaps, and Doughnut. We started this course by using Excel visualizations for stock data. We saw how effective the high-low close and the open high-low close charts are at quickly summarizing several different aspects of stock performance. The open high-low close chart in particular is a very popular financial visualization, also called a candlestick chart, and has several important similarities to box and whisker plots, which we will explore in the next course. We then moved on to radar charts, which are great for visualizing multivariate ordinal data, such as ratings or scores between 1 and 10. Radar charts are great for quickly identifying outlier columns in high-dimensional data, which makes these charts great spotting strengths or spikes in evaluating alternative candidates, for instance. Radar charts do have some limitations though. They work best with relatively small to moderate sized datasets, and variables placed near each other on the axis often seem related when in reality they are not. We then moved on to the use of Treemaps to visualize hierarchical data in the form of shaded rectangles contained within a large bounding rectangle. As we noted, the area of each rectangle is proportional to the value being represented. We then moved on to pie charts, which are great for parts of a whole at a specific moment in time. We created a pie chart to display the composition of a whole and customizations such as the angle of the slices and how to explode out one or more slices in the pie chart. We then moved to pie of pie and bar of pie charts, both of which use a secondary visualization to complement a pie chart. We saw how the pie of pie chart type could be used to create one pie chart with an other category and a second pie chart which expanded the fields in that other category. The bar of pie chart is very similar to the pie of pie, but relies on a bar rather than a pie as the secondary visualization. We then explored how donut charts are closely related to pie charts in that they visualize composition, with the added benefit that a donut can make use of multiple concentric donut rings to plot such composition at differing points in time. You are now ready to move on to the use of various plots such as box and whisker plots, sunburst charts, and various other specialized plots. That's in the course Building Box Plots, Sunburst Plots, Gantt charts, and more coming up next. Excel is the most popular spreadsheet program in the world, but it's also a lot more. It's a go to choice for an incredible range of statistical, scientific, business, and analytics related use cases. From numerical optimization to printing specific views of workbooks, from hypothesis testing to dynamic validation of user input, Excel provides for it all. In this path, our focus is on the data visualization capabilities of Excel. There is a wide range of common built-in chart types available, and in addition, many other specialized chart types can be constructed by ingenious reuse of those built-in chart types. In this particular course, you start by creating a box and whisker plot and understanding its elements in great detail. You learn how such plots convey a wealth of statistical information such as the mean, median, 25th and 75th percentiles, as well as various outliers. You move on then to the use of sunburst charts, which are great for visualizing hierarchical data, in particular when such data has differing levels of detail available. For instance, where some but not all years are broken up into quarters, or some but not all quarters are broken up into months. You then move on to waterfall charts and Gantt charts. Waterfall charts show the cumulative effect of positive and negative changes to illustrate how you go from an initial to a final value. Gantt charts are a powerful tool in project management and help illustrate progress towards a goal involving multiple parallel tasks. Next come band charts and scatter plots. Band charts can be used to quickly eyeball the trend in a line chart. Scatter plots are very useful for identifying and understanding the relationship between two variables. Scatter plots have gained widespread popularity in recent years as an essential part of EDA or exploratory data analysis. Round out the course by constructing a waffle chart, also known as a KPI chart. You'll see how waffle charts can be manually constructed using an ingenious system that includes a grid of cells representing percentages, various conditional formatting rules, and a spin button from the Excel developer menu. In this demo, we are going to experiment with box and whisker plots. Box and whisker plots are a way to get a quick sense of the statistical distribution of data in a data series. Using a box and whisker plot, at a glance, you can tell the mean, median, the 25th and the 75th quartiles, as well as various outliers. You might recall the candlestick chart that we had created while working with stock data. Box and whisker plots follow a very similar construct to the candlestick chart that we had used for open, high, low, and close information. On screen now, you have the dataset which we are using for this example. This has a list of cars. These are in column A. Then we have the associated prices of the diesel and petrol variants in columns B and C respectively. Let's start with a very small and tractable subset of our data. So we've intentionally only selected the rows 2 through 12 and columns A through B. Now, with this very limited selection of data, let's go ahead and insert a box and whisker plot. As always, at the lower right corner, we see the little icon for the quick analysis toolbar. When we click on it, we get a tab dialog. We click on the charts pane there. Here, the recommendations shown are clustered bar and column charts and pie charts, but we are actually interested in the box and whisker plot, so we click on the More button over on the right. This leads us into the Insert Chart menu, which you're quite familiar with by this point. We switch to the All Charts tab, and there towards the bottom left, we find the box and whisker plot. We click on that, and we find more information in the center pane. We can see that there is exactly one variant of the box and whisker plot, and that's the one that we are going to use. When we hover over the preview, we get an expanded preview, but we are going to work with this in more detail. So we just hit OK and add the box and whisker plot to our worksheet. On the y-axis, we have dollar figures, and on the x-axis, we have just one label, and that label is Ford. This is something to keep in mind. Box and whisker plots are great for plotting statistical distributions where all of the data series share some categorical label. Here, that categorical label is Ford. In a later example, when we expand our selection, we will have separate box and whisker plots, one each for Ford, Toyota, and Volkswagen. So again, in a box and whisker plot, on the x-axis, you're going to find the labels corresponding to a categorical variable. Here, that categorical variable is car brand. Next, let's turn our attention to the outlier, the one single point which is positioned by itself up above. That outlier is not included in the box and whisker plot. If we hover over that point with our mouse, we can see that this corresponds to the price of 23,000. That's the value present in cell B3. Why was this point not included in the box and whisker plot? Well, that comes to the construction of the box and the whiskers. Let's hover over the top edge of the box. Doing so reveals that that top edge consists of the point with the value 12,100. This value 12,100 is the third quartile or the 75th percentile of the numbers in our data. This means that of all of the prices in our dataset, 75% of the values are equal to or less than 12,100. So that third quartile or the 75th percentile is the upper boundary of the box, which you can currently see highlighted. Within the interior of the box is a horizontal line. By hovering over that horizontal line, we can see that it corresponds to the value of 9250. And this value of 9250 is the median of all the points in our dataset. Given a set of points, the median can be thought of as the value such that half of the points are above the median and half are below. The median is a measure of central tendency, just like the mean, but it has the advantage of ignoring or downweighting outliers. To calculate the median of an odd number of elements, you simply sort all of the elements and take the middle element. For instance, out of 5 elements, you sort them and take the third one. That's the median. What happens if we have an even number of data points? Well, then the median is simply the average of the middle 2 elements. This is actually how the median in our little dataset has been computed. If you look really closely, you can see that we have 10 points selected. And if we sort all of these points, we'll find that the middle values are 9,000, which is in cell B4, and 9,500, which is in cell B11. The average of those two middle points gives us 9250, and that's what we see in the tooltip next to the horizontal line in the middle of our box and whisker plot. So that's where the median came from. You can see in the interior of the box is a very faint cross mark. That very faint cross mark corresponds to the average. This is simply the arithmetic mean. We added up all of the prices and divided them by the count. And you can see a confirmation that this is the average down in the ribbon at the very bottom of the screen where it says average 9760. You've now understood the top of the box as well as the median and the average contained within the interior. Let's now hover over the bottom edge of the box. We can see there that the value is 5125. This bottom edge of the box is the 25th percentile, also known as the first quartile. This bottom quartile or third quartile is computed such that 75% of the numbers in our dataset are going to be larger than this number. Now, the finer points of the construction of a box and whisker plot get quite complex. And in particular, there's one feature of the Excel box and whisker plot which is worth pointing out. Many authoritative sources define the 25th percentile and the 75th percentile as the medians of the numbers which lie above and below the medians. That does not work, however, in Excel, and that's because Excel has its own ways of computing the 25th and 75th percentiles. They match the results of the Excel function percentile.exe or percentile.inc. To see what I mean, consider the data points on screen now. If we focus only on the numbers which are smaller than the median, those numbers are 3,500, 4,000, 5,500, 5,600, and 9,000. The median of these numbers does not work out to be 5125, which is the lower bound of the box that you see on screen now. So again, that lower bound is simply calculated by Excel internally using the function percentile.exe, and it passes in the percentile of 25%. It's worth knowing this little detail in case you present a box and whisker plot to a corporate audience and then find yourself faced by a skeptical member of the audience who sets out to hand calculate the 25th and 75th percentiles. In similar fashion, we can also see that the upper end of the box, in this case works out to 12,100, is not quite the same as the median of all numbers greater than the median. So again, this upper bound of 12,100 has been obtained from Excel's percentile.exe formula, passing in a percentile of 75%. We now understand in a lot of detail the box itself. Let's turn our attention now to the whiskers. Let's place our mouse on the top whisker. We can see that that corresponds to the value 16,000. Now, the top whisker is defined as 1.5 times the interquartile range above the upper quartile. What's the interquartile range? Well, that's the thickness of the box, which in our case is the difference between 12,100 and 5,125. So that thickness of the box is the interquartile range. We multiply that interquartile range by 1.5. We then compute 1.5 times that distance from the top edge of the box. Then in the Excel implementation of the box and whisker plot, we find the largest data point which is smaller than this, and that gives us the top whisker. And that top whisker in our example gives us the value of 16,000, which you see on screen now. So the computation of this top whisker in Excel is again slightly different than in some other statistical packages, because in those packages, the top whisker is often defined as 1.5 times the interquartile range from the third quartile. In Excel, there's the additional wrinkle that it's the largest actual value in the dataset, which is smaller than this bound. All values above this are going to be marked as outliers, and that is why we have that one outlier at the very top, which has a value of 23,000. In similar fashion, let's turn our attention to the bottom whisker. That bottom whisker in this example is $3,500. That number has been arrived at in a similar fashion. We compute the interquartile range, which is the difference between the 25th and the 75th percentiles. That's the same as the thickness of the box. We then compute 1.5 times that thickness from the 25th percentile, and then we find the smallest actual value which fits within that range. In this example, the smallest value which fits within that range is 3,500, and that's also the smallest value in the range, and that's why we don't have any outliers on the downside. This is yet another slight difference between Excel's box and whisker plot and the standard 2K box and whisker plot, where, as we've already discussed, the bottom whisker would have extended down to 1.5 times the interquartile range below the 25th percentile. We've now come to the end of this little example. You can see how easy it is to get caught up in the implementation details of a box and whisker plot. In the demo coming up ahead, we are going to continue working with box and whisker plots, but we are going to explore other features which include the ability to tweak and customize their appearance, and also to have separate box and whisker plots for the different brands which we have in column A of our data. The previous demo was fairly complex because we did all of the heavy lifting required to understand exactly how a box and whisker plot is computed in Excel. This demo is going to be a lot smoother. We are going to return to customizing and formatting our box and whisker plot. Let's start by clicking on the little plus icon over in the top right corner of our plot. This, of course, is the Chart Elements dialog. We have all of the usual customizations related to the axes and the axis titles and the chart title. One customization which is certainly worth considering in the case of a box and whisker plot is the addition of data labels. We can hover over the different menu choices, and these move the labels to the right, left, above, below, and we can see that the left is probably a good choice for the position of data labels. There's enough complexity in the construction of a box and whisker plot that it makes sense to include the data labels based on your audience. In any case, let's now move on and expand the data that we are operating on. We've currently been only doing this with a very small little subset of our data. You can see in the top left that we've only gotten rows 3 through 12 highlighted. Let's change that. We click on the select data button on the top right, and then we use the chart data range control in order to include the range A2 through B22. If we look closely at the data in the columns on the left, we can see that we've been careful to only include the data for the brands Ford and Toyota. So we've intentionally excluded the rows for Volkswagen for now, And what's more, we've also been careful to only include the data in column B. We'll get to all of the remaining data, but in just a little bit. With this selection, let's go ahead and hit OK. And we find that at this point, our box and whisker plot throws up some really interesting insights. On the x-axis now, we have two category labels, Ford and Toyota. On the y-axis, we continue to have the prices. We can tell at a glance that the distributions of prices for Ford and Toyota are very different. First off, on average, prices for Toyota cars are higher than those for Ford cars. How can we tell that? Well, we can see that both from the mean and from the median. We can compare the two horizontal lines inside the Ford and Toyota boxes, and the horizontal line representing the median Toyota price is significantly higher than the median Ford price. The median Toyota price seems to be at around $27,500. The median Ford price is a shade under $10,000. That's a big difference. Then we can see that the skew for Toyota cars is a lot greater. What does that mean? We can see that the little cross mark corresponding to the average price of a Toyota is much further above the median for Toyota than the cross mark for Ford is above the median for Ford. So not only is the median Toyota car more expensive than the median Ford car in our little data set, in addition, Toyota has some really expensive outliers which push the Toyota mean far above the Toyota median. We can then see that the interquartile range on the downside is very similar for both of these cars, which means that Toyota does not really compete in the lower price segment. Again, all of this is based on this made up little data set. You can also see that the lower whisker of the Toyota plot is above the upper bound of the Ford box. That's yet another confirmation of the higher prices associated with Toyota relative to Ford. We've studied the Ford box and whisker plot in detail so we can understand the outlier, that's the $23,000 model for Ford. There are no outliers in Toyota. There is, however, one point which lies above the box but below the upper edge of the whisker. Notice how we were able to glean all of these insights just by looking at the shapes of these two box and whisker plots. We have not examined a single individual value in detail at all so far. This really indicates why box and whisker plots are such a popular tool in exploratory data analysis. In any case, let's move on and quickly hover over some of the key points so that we also get a more detailed insight into the data. The top whisker for Toyota clocks in at $72,000. We can see that from the little tooltip. The one point which is above the box but below the top whisker is at $65,000. Please remember again that Excel differs in the way it builds its box and whisker plots in that the top and bottom whiskers actually correspond to points in the data. You can see that $72,000 priced vehicle in row 20, column B. Let's keep scrolling. The top edge of the Toyota box is at $61,000. This corresponds to what you'd get if you ran the Excel function percentile.exe on all of the Toyota points and pass in 75th percent as the input argument. We can then scroll down to the average, which is $33,519. The median for Toyota is $24,400. We see that by hovering over the little horizontal line inside the box. We can also view the individual points inside the box and whisker. We hover over them until we get to the bottom edge of the box, which clocks in at around 14,500. Next, let's see how we can customize some of these properties. So we right click and then choose the Format Plot Area option. This in turn brings up the dialog over on the right. At this point, we are actually more interested in formatting the data series. So we click on a series and then the dialog updates. We click on the little bar chart icon over on the right, and this brings up various interesting options which we should be aware of. There's a slider there for the gap width. That's purely aesthetic. But then the other checkboxes and radio buttons here have to do with the actual calculation. The first checkbox reveals whether we turn on or off the show inner points function. The second governs whether we show outlier points or not. And the third determines whether we show mean markers. Note how all three of these are currently checked. And that's why we have the outliers as well as the mean markers in the form of the little cross marks inside each of the boxes. Further down below, we have a radio button set corresponding to the quartile calculation. The two options are inclusive median and exclusive median. Now, it's fair to say that the method used to compute the median is key to the whole construction of the box and whisker plot. Excel has its own internal method which relies on the percentile methods in Excel. There are two such methods, percentile.inclusive and percentile.exclusive. These make use of interpolation, that's some kind of mathematical technique, while computing the median. The difference between the inclusive and the exclusive medians comes down to whether, while computing the 25th percentile, we take into account the median of the entire data set or not. If we include the median, that median is going to be shared. It's going to be a common point between the 25th and the 75th percentile calculations, and that is going to lead to a smaller interquartile range. On the other hand, if we use the exclusive median, then we are going to have a greater spread. So the interquartile range will be larger, and so will the whiskers. Let's quickly try out these different elements. We first vary the gap width. We vary it in a couple of different ways. We then toggle the checkboxes for show inner points as well as show outlier points and show mean markers. That gets us to the one checkbox we have not discussed so far, which is the show mean line checkbox. When we check this box, a line is drawn connecting the means of the two box and whisker plots. You can see it very clearly on screen now. It goes from the X mark of the Ford box and whisker to the X mark of the Toyota box and whisker. Mean lines are a powerful tool when you have multiple categories. Let's say we had 10 car brands. Those mean lines might actually give us some interesting and important information about how the prices vary and how the average price varies based on each category. Comparing the means of the price for different values of a categorical variable such as the brand is the basic idea of one-way ANOVA, and that's why these mean lines are quite a powerful technique. You can employ them if you need to decide whether to apply one-way ANOVA or not. Next, let's toggle the value of the quartile calculation. It's currently set to exclusive median, as we've already discussed. When we use the method of exclusive medians, we are going to have greater interquartile ranges and greater whiskers. If we now change that setting to inclusive median, we can see that all of the box and whisker plots shrink. By switching to the inclusive median, we have reduced the interquartile range and also correspondingly reduced the length that the whiskers extend out. We've now understood all of the customization elements related to box and whisker plots as well. So let's close this format data series dialog and run our box and whisker on a little more data. We click on the chart design button up top, use the select data control, and now we are going to expand our selected data, not lengthwise but breadthwise. We've now selected rows 2 through 12, but this time we have both the diesel and the petrol columns in there. Please note that this time around we've shrunk the number of rows to again only include all of the cars with the brand equal to Ford. When we hit OK, we now find that we have two box and whisker plots. Both of these correspond to Ford, but now we have an additional variable, and that's the fuel. This is indicated by the color coding. The blue box and whisker plot is for diesel, the orange one is for petrol. We can see that the statistical properties of these two groups are quite similar. The extents of the boxes and the whiskers are similar for both types of fuels. There is the one outlier in the diesel variety, there's no outlier in the petrol, but other than that, these boxes look quite similar to each other. It's interesting to note that the median diesel price is higher than the median petrol price, and that checks out with what we know about car prices. One point worth noting about this example, on the x-axis we have just one label, and that's Ford. The box and whisker plot was smart enough to figure out that diesel and petrol correspond to two columns for the same label, that's Ford. We can expand this even further by using the select data dialog in order to add in data for Toyota. Now selected up to row 22, that's the last row with Toyota. We haven't yet included Volkswagen, but we do have both diesel and petrol in there. So now when we hit OK, our box and whisker plot has not 2 but 4 box and whiskers. These correspond to the two brands Ford and Toyota, which are on the x-axis, and then the diesel and the petrol variants for each of these brands. A few insights jump out. The brand is a much better determinant of the statistical distribution of the prices than the fuel. How do we know this? Well, just look at the two blue box and whiskers. They don't look like each other at all. On the other hand, compare the two box and whiskers for Ford, they look a whole lot like each other, and even the two box and whiskers for Toyota look quite a bit like each other. So, on the basis of this, it's the brand rather than the variant of fuel which is a better predictor of the price. We are now ready to select all of the data in our dataset. So, we click on the select data button up top, select all of the data in our little spreadsheet and hit OK. And as expected, the plot on screen now has 6 distinct box and whiskers. Along the x-axis, we have the 3 brands Ford, Toyota, and Volkswagen. And for each value of this brand variable, we have the 2 box and whiskers, one each for diesel and petrol. So again, do keep in mind, box and whisker plots are used with categorical variables on the x-axis. Here, the categorical variable is the brand. That categorical variable takes 3 values, or there are 3 categories or levels for that categorical variable. Those are Ford, Toyota, and Volkswagen. We can now perform all of the same formatting operations which we've worked with so far. So for instance, we could choose to display mean lines for only the diesel vehicles. We do this by clicking on any of the diesel box and whisker plots. This brings up the format data series dialog on the right, and there we can check the box show mean line. This will only introduce mean lines between the blue boxes. If we'd like to repeat this operation for the petrol vehicles, we can use a drop down up top. We click on the little down arrow next to series options. We change the selected series from diesel to petrol, and then again check the show mean lines checkbox. And with this, we've come to the end of our exploration of box and whisker plots. On screen is a fairly complete set of box and whisker plots. We encapsulate all of the brands as well as the types of fuel. We also have mean lines which show the trends, the differences between the means along each of these two variables. We had made the point earlier that when we use mean lines with one categorical variable, that can be thought of as a precursor to one-way ANOVA. Here we have two categorical variables, the type of fuel and the brand, and this box and whisker plot with the mean lines can be thought of as a precursor to two-way ANOVA. In a previous example, we had worked with e-commerce data relating to sales by category and subcategory. That had been an example of hierarchical data because, of course, the subcategories are included within categories. In that particular case, we had made use of a tree map. You can see that tree map in the center of your screen, but if you turn your attention towards the left, you can see that below the preview of the tree map is a circular diagram which looks quite a bit like a donut chart, and that is a sunburst plot. And that's the subject of this demo. Sunburst plots are preferable to tree maps when we have more than one level of hierarchy. In order to see what this means, let's turn our attention to the data for this example. Here it is on screen now. In column A, we have company, column B is year, column C is quarter, and then finally in column D, we have the actual data, which is the revenue. The e-commerce data had two levels of hierarchy, category and subcategory. But here we have three, company, year and quarter. And this is why a sunburst chart is going to be our go-to visualization for this example. Let's get started in the usual way. We select all of our data, click on the quick analysis button in the bottom right, navigate to the charts section, and there click on the more recommended charts on the extreme right. This brings up the familiar insert chart dialog. Click on the all charts tab, and there over on the left we see the sunburst plot. There it is right below the tree map. When we select the sunburst plot, we can see in the center pane that there is just the one variant. So we don't have to go through multiple different variants. This is all there is. Let's hit OK. And then we find that this chart is not at all what we had in mind. We have an almost meaningless collection of donut slices. Some of them are the symbols of companies and others are quarters. This clearly is not a sensible chart. And the point of doing it this way was to bring across to you that while constructing a sunburst chart, it's important to get the legend entries and the horizontal categories just right. Luckily, this is a very easy problem to fix. Let's right click and pick the select data option. This brings up the familiar select data source dialog, which we have worked with multiple times before. Let's take a moment to observe these incorrect settings. The problem clearly is on the left. We can see that the legend entries which correspond to the series there are year, quarter, and revenue. Now, out of these, year and quarter are not legend entries. It's only the revenue which is a legitimate data series. We also have a problem on the right. The horizontal category axis labels have inexplicably been set to Microsoft. Well, it's not inexplicable, it's because of the layout of our data in our workbook. Let's get started fixing this. We click on the remove button multiple times. This eliminates the year, quarter, and revenue columns. And when we do this, that also gets rid of the horizontal category axis labels on the right. Now let's click on the add button and proceed to actually add back the data which we want to visualize. This is going to consist of only the revenue data which is in column D. We then hit OK, and at this point we can see that we have just one legend entries series, and that's the revenue. Then next, let's click on the edit button over on the right, and now we are going to select all of the other label values. These are the values in the cells A2 through C10. This is important. We've got to make sure that all of the levels of our hierarchy appear on the right, that is in the horizontal category axis labels, and not on the left, that is as a part of the data series which are to be visualized. And now if we pay close attention to those labels, we can see that Excel has inferred the data pattern. You can see that the first row in the horizontal category axis labels is MSFT 2018. The second row is MSFT 2019 first. And that's because Excel has inferred that we have data only for all of 2018 for Microsoft. That's the data in row 2. On the other hand, it has also inferred that we have data for all 4 quarters individually for Microsoft for 2019. And that's the data present in row 3. And even though the word Microsoft does not appear in row 3, the label for this row is correctly displayed as MSFT 2019 first. And this shows us that this Sunburst plot has indeed picked up on the additional level of detail that we have for the year 2019 for Microsoft. If we look really closely, you can see that we do not have that additional level of detail for either Google or Amazon. For both of those companies, for 2019, we have just the aggregate revenue data. We do not have a quarterly breakup. At this point, we hit OK, and we now have a correct but completely unlabeled Sunburst plot. Clearly, we've got to fix up the appearance. We do this by clicking on the plus icon on the top right, and there we start enabling different values of data labels. We just check that data labels checkbox, and as soon as we do this, the graph is updated and it starts to make a lot more sense. Notice in particular how for Microsoft, we have data for 2018 as well as for 2019. The difference is that we have an additional level of detail for Microsoft for 2019, and that additional level of detail is the third annular ring of the Sunburst plot, which has the quarters for second, third, and fourth. Well, there's still one little problem, which is that we don't actually see the revenue numbers in there at all. That's something that we've got to address as well. The easiest way to get there is to navigate to the more data label options. That in turn opens up the format data labels dialog over on the right. You can see that there are checkboxes there for the series name, category name, and value. We can try experimenting with these checkboxes. For instance, we turn the series name checkbox on and off. But what we really need at this point is to check that value checkbox. And as soon as we do that, the revenue for each year or quarter, as the case might be, appears in the corresponding section of the Sunburst chart. Our little Sunburst chart is complete. We can now take a step back and admire how nice it looks. You can see that we have concentric circles. These concentric circles correspond to the columns containing the labels. So we have the innermost concentric circle corresponding to the top level of our hierarchy, which is the company. Then the second concentric circle corresponds to the second column of labels, which is the year. You can see that we have the values of the year repeated for each company. So we have Microsoft 2018 and 2019, Amazon 2018 and 2019, and finally Google 2018 and 2019. There is also a third concentric circle, but that's only partially formed, and that's because that third concentric circle corresponds to the quarter, and we only have quarter level information for one company, Microsoft, and for 1 year, that's 2019. And that's why we only have the third concentric circle on the subset restricted to Microsoft in 2019. Finally, notice that all of the revenue values appear at the appropriate level. So if we have a revenue associated with a year, such as for 2018 for Google, then that's where the revenue number appears. For Microsoft for 2019, we do not have a revenue number for the entire year, but we do have individual revenue numbers for the 4 quarters. Now that we've built this Sunburst chart, we can customize it in various ways. You can see, for instance, that we have improved the formatting of the currency information. We are changing the fill, and we can also add in nice lines to separate out the sections between the concentric circles and their arcs. All of this formatting is well and good, but because we performed it so many times, we are going over it pretty quickly. And at the end, we have a really nice looking, well formatted Sunburst chart. Let's now delete the chart and get back to our basic dataset. You can see this on screen now. This is sheet 1. Let's now click on sheet 2. You can see that there's a tab for it over in the bottom left. Sheet 2 also has hierarchical data, but this is organized in a slightly different fashion. Once again, we have a time-based hierarchy for a financial metric. This financial metric is sales in billions of dollars. The time-based hierarchy starts at the level of a quarter. Some quarters are broken up into months, others are not. You can see the second quarter, for instance, is all by itself. Then some months are broken up into weeks, but others are not. In fact, in this example, it's only the February month which is broken up into weeks. All of the other months appear standalone. Sunburst charts are perfect for this kind of hierarchical data, even when that hierarchy is irregular, even when we do not have a perfectly symmetric hierarchy which applies equally to every row. Sunburst charts are smart enough to figure out what to do with them. Now, in the previous example, when we selected all of our data and just blindly munged it into a Sunburst chart, things didn't work out very well. Let's try the same experiment here and see how things turn out. We've selected all of the data in cells A1 through D14. We click on the Insert menu item up top, navigate towards the section for the charts, click on Recommended Charts, navigate to the All Charts section, pick the Sunburst plot from the list over on the left, and when we hit OK, we find, somewhat to our surprise, that we actually have exactly the right Sunburst chart. The innermost concentric circle corresponds to the first layer of the hierarchy, that's the quarter. So we have first, second, third, and fourth. The second concentric circle corresponds to the month. For those quarters like quarter 2 where we do not have month level information, that's missing, so that's correct as well. And then for those months where we do have a week level breakup, in fact there's only one such month, that's February, that breakup appears as well, that's in the bottom left corner. Clearly, this Sunburst chart was able to correctly infer the structure and the hierarchy. In case you're wondering how this is, it probably comes down to Microsoft Excel figuring out that these quarters, months, and weeks are units of time and that there is a natural hierarchy between them. It's also an example of how little bits of machine learning have pervaded the implementation of Excel. We can also see this in other Excel features such as Flash Fill. Suffice it to say that Microsoft Excel is a very smart tool, and the Sunburst chart is a great representation for multi-level hierarchical data. How did we get to now? How exactly did we get into this current mess? Questions like this are often posed in corporate meetings, and Excel has a visualization which helps to answer exactly such questions. On screen now is the Waterfall chart, which is a great tool for explaining how we got to a current state by applying small changes to an initial state. The Waterfall chart is a relatively recent addition to Excel, and what you see on screen now is one out of two types of waterfalls we are going to build in this demo. As you can see in column D, this waterfall chart only has data for 2012. The second waterfall chart we are going to construct is going to contain data which spans years. And then we'll see how we apply a filter to the data behind that waterfall chart by selecting 1 year, like say 2015, and then we correspondingly get the waterfall chart for that year alone. This is what we want to build. Let's go ahead and get started. Let's start with the simple data that you see on screen now. We have columns which correspond to organization, category, line item. This refers to an accounting line item, and then fiscal year followed by a dollar figure. As usual, let's get started by selecting all of this data. We click on the quick analysis icon over at the bottom right, and in the tab pane which opens up, we navigate to the charts section, then click on more over on the extreme right. That in turn leads to the insert chart dialog. We click to the all charts tab, and there towards the bottom, the third from the bottom, is the waterfall chart. We go ahead and hit OK, and this waterfall chart gets added into our Excel workbook. Now, as it stands right now, this isn't much of a waterfall, so we've clearly got to improve upon this. As we already saw with the Sunburst chart, the place to fix this is probably in the Select Data dialog. So we click on the Select Data button in the top right, and there we closely examine the legend entries, that's the series, in the lower left. And we can see the problem there. Excel has interpreted the fiscal year column as a numerical series which needs to be plotted on the waterfall chart, and that explains the weird appearance of that waterfall chart where every value has the same value of 2012. Let's go ahead and click on the remove button. This eliminates the fiscal year from the list of series in the bottom left, and as soon as we do this, our waterfall looks exactly as it should. You can see that the horizontal category axis labels over on the right have been created from the concatenation of each of the rows in our data. We saw this in the case of the Sunburst plot as well. Excel is pretty smart about figuring out how to interpret those label values. If there are missing values, it knows how to use the value from the previous row and concatenate these correctly. Check out, for instance, the very first axis label, that's MIAG, income operating revenue. That's a straight concatenation of the values in cells A2, B2, and C2. Turning our attention now to the waterfall chart over on the bottom left, we can see that this chart has the correct details. It starts with the operating revenue. Note that the operating revenue block is not floating, it's anchored to the x-axis. Subsequent blocks are floating. Each one of them is not attached to the x-axis and starts where the previous one left off. The investment income box, for instance, starts at the level 62, which of course is exactly where the operating revenue box ended. And in similar fashion, the raw material cost begins at 62 plus 37, that's 99, just shy of 100. But then because it's a negative number, minus 44, it extends in the downward direction. You can also see that increases are coded in blue and decreases are color coded in orange. And in this way, we can see that we have various changes which increase and decrease the amount of cash, and at the end we have the total which stands at 6. We can also see from the height of each rectangle how material the corresponding cash flow is. We can see, for instance, that raw material costs were the largest and most material costs. And finally, we can interpret that value of 6 over on the extreme right as the profit. That's what's left over after all expenses. But that now leads to a troublesome question. If 6 is what's left over after all costs have been deducted from the revenue, then shouldn't that bar for 6 be anchored as well? Why is that bar floating? And that's an absolutely valid question. That bar should indeed be anchored. We need to attach that bar to the x-axis. Let's see how that's done. For that, we'll need to hit OK, and then we've got to perform an important little operation. We right click only on the one box corresponding to that number 6, and from the right click menu, we choose the option Set as Total. As soon as we do this, this bar is going to become anchored. In other words, it's now going to extend downwards to the x-axis. This set as total operation is a very important one in the context of waterfall charts. You can apply this operation to any bar in your waterfall if you'd like it to reach all the way down to the x-axis. That will then become an intermediate or final ending point for your waterfall chart. And with this, we have successfully implemented the first of the two waterfall charts which we previewed at the start of this demo. Let's now get on with the second and slightly more complex one. We change the active worksheet by clicking on Sheet 2 in the lower left corner. Sheet 2 has data which is similar in structure to Sheet 1, but the difference is that we now have data for multiple years. So the columns remain the same as before: organization, fiscal year, category, line item, and then the amount in US dollar millions. Well, in reality, the order of these columns is ever so slightly different from the order of the columns on sheet 1, but none of that matters to the waterfall chart. because after all, there's only one series that's got to be displayed, and that's in column E. Remember that here we have intermediate totals representing the total cash on the books of the company at the end of each year. So the way to interpret these is as subtotals, which then start the next waterfall corresponding to the next year. Now that we've selected all of this data, let's go ahead and put it into a waterfall chart. We do this by clicking on the Insert menu item up top. We navigate to the section for charts, which is towards the center, and there is a little icon which looks like a waterfall. And indeed, the waterfall chart is the first one there. Let's take a moment to read this tooltip. As Excel informs us, waterfalls are great to show the cumulative effect of a series of positive and negative values. So if you think of some of the other visualizations that we've worked with, such as Treemaps, which could not cope with negative values, waterfalls are the exact opposite. You think of a waterfall when you have a series of both positive and negative values. And as the use case below explains, it makes sense to use it with financial data consisting of inflows as well as outflows. In any case, having understood that tooltip, let's go ahead and click on that waterfall chart, and a really intricate waterfall chart gets added to our worksheet. Let's expand this so it occupies a lot of screen real estate, and then we notice that we have all of these data items with the legend total. Notice all of the values of total on the x-axis, which now need to be anchored. Let's go ahead and do that. We've got to perform this anchoring operation one by one. Let's start with the element called total way over on the right. We right click and click on the set as total option, and that in turn causes this bar to extend downwards rather than upwards. And what's more, you can see that it now ends at the value of 0. In similar fashion, we are going to right click all of the other bars which are labeled total, and each of these is now going to be anchored in the same manner. And by the end of this process, we have one large waterfall chart. That waterfall chart always ends back at 0, and that's when we have the total for each year. This waterfall chart is a multi-year waterfall, and that's why it's a lot to take in. But this is where the filter option unexpectedly comes in handy. Let's select the fiscal year, that's in column B. Note how we select the entire column, and then we click on the sort and filter button way over on the top right. Please note that this sort and filter option is a part of the home menu, and you can see the home menu item on the top left. It's the second item from the left, just to the right of the file menu item. In any case, coming back to the sort and filter, we scroll down and click on the filter item there, and this is going to add a little filter icon to the heading fiscal year, which we see in column B. We can now use that filter icon in order to select one or more of the years, and that in turn is going to update our waterfall chart accordingly. We're going to try that out in just a moment, but first we've got to drag this unwieldy waterfall chart to the bottom just so we have a little more screen real estate. Let's now scroll up and click on the filter in the fiscal year column. Let's first uncheck the select all button and then only select the year 2012 and hit OK. And our waterfall chart now bursts into view, and we can see that it has the correct appearance. Notice here that the bar for 6 is in gray. This shows that it's a total bar. In a similar fashion, we can also try different values on the filter. We need to scroll back up to the top to get to that filter, and once we do, we can apply the different fiscal year filters. Let's deselect 2012 and try 2013. The waterfall updates automatically. The same happens when we change the year to 2014. Let's also try selecting multiple years. You can see that we've now chosen both 2014 and 2015, and when we hit OK, this one works just fine as well. This gets us to the end of our exploration of the waterfall chart. We are now going to turn to another exciting kind of chart used widely in business, and that's a Gantt chart. This demo is all about Gantt charts. You can see an example of a Gantt chart on screen now. A Gantt chart is a valuable tool in project management. It demonstrates a project schedule, and it has time on the x-axis. It has tasks on the y-axis, and the actual values in the Gantt chart correspond to the length of time which each of those tasks is going to take. Here, these tasks refer to common steps in a software development lifecycle. You can see that we start by gathering requirements, perform UI design, code up the actual app, perform unit tests, then system tests, launch the app in beta, fix bugs which were found during the beta, add improvements, then perform final testing, and then at the very end of all of that, we release a version. So this is a pretty classic set of steps. And then with the duration data that we have in column D, we have a schedule which tells us when our app ought to launch. This then is a preview of what we're going to build in this demo. Let's start out with the raw data. Let's place our cursor in cell B2 that contains the date, that's the 7th of July 2020, and then notice something really important. Notice towards the top center of the screen that the data type of this cell B2 is date. This correct data type for the start date column is the fact on which this entire Gantt chart demo hinges. In order to understand why that is, let's first understand what an Excel date is. Dates in Excel are represented as integers. These represent the number of days since the beginning of time according to Excel, which is the 1st of January 1900. So any date value in Excel is actually an integer value, which is the number of days since the 1st of Jan 1900. This means, of course, that we can add integer values to dates. And if you take that one step further, if you subtract two dates, what are you going to get? Well, an integer value. And we can look closely at our existing data, and there we can see that the difference between the start and the end dates is equal to the duration which we see in column D. So the start date that's in column B plus the duration that's in column D is going to give us the end date which is in column C. This is a key insight which we need in order to build our Gantt chart, and that's because the Gantt chart is one of the few types of charts that is not ready-made yet in Excel. We are going to have to build our Gantt chart by hand using a stacked bar chart. So let's go ahead and get started. We select all of the data in columns A through D. We then click on the quick analysis toolbar, click on the charts tab, navigate to the more button that opens up the insert chart tab. We click on all charts, and there, as we remarked a moment ago, we'll have to find the bar chart entry over on the left. We are going to have to create our Gantt chart from a stacked bar chart. So we click on bar, and that in turn leads to a large number of variants of bar charts. The first one is a clustered bar chart. That's not going to do it. We click on the second, and that's the stacked bar chart that we are so interested in. Let's take a quick look at the preview. This doesn't look very much like a Gantt chart, but we can fix that. So let's go ahead and hit OK and add the stacked bar chart to our Excel workbook and then set about fixing it. We've already encountered such issues multiple times before. When we have charts which don't start out looking the way we'd like them to, our first port of call is the Select Data button over on the top right. We click on that and the Select Data Source dialog opens up. We do not need to tweak the chart data range in the control at the very center top. We do, however, need to adjust the legend entries, that's the series which we wish to visualize. You can see that right now there's only one series there, and that's the duration, but we've got to change that. Now remember how the bars are computed in a stacked bar chart. If you have multiple series, the values of those series are going to be added together. So what we need to do here is introduce two series. The first is going to be the start date, and the second is going to be the duration. Then when we actually plot our stacked bar chart, we are going to have two bars, one for the start date and then the second for the duration added on top of the start date. And that duration added to the start date, of course, gives us nothing but, you guessed it, the end date. Once we understand how to proceed, it's actually quite simple. We click the edit button and select the series corresponding to the start date. We also make sure we have the right series name, that's the cell B1, and then we hit OK. At this point, we have one series in our stacked bar chart, and that's the start date. Then we click on the add button, that's on the bottom left. That in turn allows us to add a second series, and that second series is going to be the duration. We navigate to the cells with the duration data. We start with the series name, which is in sheet D1, and then we have the series values, which are in the cells D2 through D11. Once we are done with this process, we hit OK, and we now have 2 series, and you can already see in the preview over on the bottom left that we have something which looks like a stacked bar chart. That's one good thing. The other good thing is that we've clearly been successful at adding the duration, that's the orange rectangles, onto the start dates. Those are the blue rectangles. Now we still have a long way to go. There's a lot to fix, and that includes the horizontal category access labels, which currently are just set to the integers 1, 2, 3, 4, and so on. So let's now click on the edit button over at the top of the horizontal category access labels. And once again, we are going to navigate to the right cells. And those cells now are the data in A2 through A11. That is the access label range. And that corresponds to the steps in our software development lifecycle. And now we can see from the preview over in the bottom left that our stacked bar chart is looking even more sensible. We now have the correct names associated with each of the stacked bars. This is an important milestone, so let's hit OK and examine this graph in some detail. Let's begin by clicking on the blue rectangles. As soon as we do this, the data in column B gets highlighted. So it's clear that the blue rectangles correspond to the start dates. In case you're wondering how the start dates have been plotted as numeric values, well, just again remember how dates are defined in Excel. Every date is simply the number of days that has elapsed since the 1st of January 1900. And so for instance, that start date of the 7th of July 2020 is going to have a numeric integer value, something like 44,000. Now the next order of business is to make those blue rectangles disappear. So we right click on Format Data Series, and then in the dialog which opens up over on the right, we navigate to the paint bucket icon, and there we change the fill options. So we expand the fill card, and there we set it to no fill. As soon as we do this, the blue rectangles have vanished, and our graph now looks discernibly more like a Gantt chart. We need to expand the border card and set the line setting to no line as well. And then there's one little bit left for us to do. Pay close attention to the y-axis. That currently starts with the last step, which is the release version, and then it goes down all the way to the first step, which is gather requirements. This is again an artifact of how bar charts are computed. Remember, we had encountered this while working with bar charts. The order of the bars in the bar chart is the reverse order of the rows in the data. And that's why our first row in data, that's row 2, corresponds to gather requirements. And that's why we currently have gather requirements way over down at the bottom. But we've got to fix that because Gantt charts are read from top to bottom. Now, because we had clicked on the y-axis, the dialog over on the right is already the right one. That's the Format Axis dialog. We need to click on that little bar chart icon over on the right. And at the bottom, we need to reverse the category order. We simply check that box which says categories in reverse order. Instantaneously, the order of entries on the y-axis is reversed. We now have the first step first, that's gather requirements, and we have the last step last, that's release version. We're almost there, but we still need to fix up the x-axis. Right now, the problem with the x-axis is that it does not start precisely at the start date of the first task. What's more, it also does not end at the end date of the last task. Right now, the start date is the 10th of March 2020 and the end date is the 4th of April 2021. That's not what we have in mind. We'd like the start date to be the 7th of July 2020. That's the value in cell B2. And the end date to be the 26th of November 2020, which is the value in C11. So let's fix the x-axis. We right click and choose the Format Axis command. That in turn opens up the dialog way over on the right. Notice how both the minimum and the maximum values are integers and both of them are around 44,000. This should come as no surprise. That minimum value of 43,900 is merely the numeric representation of the 10th of March 2020 and the maximum value of 44,200 is the numeric representation of the 1st of April 2021. In order to get the correct minimum and maximum values, let's click on the corresponding cells in the data. So we click on cell B2 and then we paste that value into the minimum box. We paste it in as the date, the 7th of July 2020. Excel takes care of converting it to a numeric value, and that is 44019. We can see up top that the left edge of the x-axis is now correct. Let's repeat this experiment for the end date. Let's try a little twist. So we click on cell C11 and then we right click and pick the format cells option. The current cell formatting is of type date. However, if we were to change that to make it to be of type general by clicking up above, the numeric value is 44161. That's the number, and that's the number we are going to paste into the maximum value of the format access dialog. Before that, we very quickly undo the format cells operation so that our end date is once again correctly displayed as the 26th of November 2020. That just takes a moment for us to attend to. Then we choose the x-axis and paste in the new maximum value, which is 44161. And as soon as we do this, our Gantt chart is complete. We can close the format access dialog and view our handiwork. You can see that the Gantt chart now correctly ends on the end date of the last task, that's the release version. It correctly begins on the first date of the first task, which is the 7th of July 2020. And in this way, we have successfully implemented a Gantt chart by jerry-rigging a stacked bar chart in Excel. In this demo, we are going to build a visualization known as a band chart. You can see this band chart on screen now. It gets its name from the fact that in the background, we have three bands which represent low, medium, and high levels of a certain variable. Those bands are in the background. In the foreground, we have line charts corresponding to variables measured against those bands. And from the foreground and the background together, we get a sense of whether the variables in the line charts lie in acceptable zones or not. This band chart, for instance, which you see on screen now, depicts the customer satisfaction ratings for the US and Canada. So the blue line corresponds to the US and the orange line corresponds to Canada. And the bands in the background tell us how those have trended over time. Thankfully, there are no points where the customer satisfaction rating lies in the low zone. That's the gray band over at the bottom of the chart. We'll see how this chart can be built using the combo chart construct in Excel. Let's go ahead and get started. On screen now is the data, the raw data that we begin with. In column A, we have the month. Columns B and C correspond to the customer ratings for the US and Canada. We select all of this data that's in the cells A2 through C14. Then we use the quick analysis toolbar in the bottom right. Remember that in case this little toolbar button does not show up, you can always access it using the Control Q keyboard shortcut. Clicking on the quick analysis button brings up a tab pane. We navigate to the charts page and then click on the more button over on the extreme right. The insert chart dialog opens up. We switch to all charts, and there at the very bottom on the left is the combo chart. We go ahead and select that choice. As soon as we do this, the pane over on the right gets updated. Up top, we see the templates of the different types of combo charts supported in Excel. The basic idea of a combo chart, as its name would suggest, is that multiple visualizations are combined within the same graph area. The first type of combo chart, the one that's previewed in the center of the pane, for instance, is the clustered column hyphen line. And we can see from the preview that this combines a column chart along with a line chart. This dialog also has another interesting set of inputs at the bottom. These allow us to choose the chart type and the axis for your data series. There are two series names displayed, US and Canada, and there are two chart types. The first is currently set to clustered column, the second is currently set to line. We can see that there are also two checkboxes asking whether we'd like to represent these series on the secondary axis. Let's go ahead and change the chart type. We are going to set both chart types to be line with markers. And there's a drop down which allows us to pick absolutely any kind of chart for the chart type. So we go ahead and pick the line with markers for the series US, and then we repeat this for the series Canada. And at the end of this process, we have two line with marker charts in our combo chart. We now hit OK, and this gets added to our worksheet. At this point, we just have two line charts. That's all that we currently have, but we are now going to go ahead and add the bands in the background. Next, somewhere in our spreadsheet, we define the thresholds which correspond to the three bands. These bands are called low, medium, and high, and the thresholds for these are 3, 8, and 10. So we believe that any rating below 3 is low, any rating between 3 and 8 is medium, and any rating above 8 and below 10 is high. Now the next step is going to be just a little cumbersome. We now need to set up values of these bands for every row in our data. So we start by adding in 3 rows, which we've now also titled low, medium, and high. These rows are in columns E, F, and G. Note how this is in row 2. So we've aligned these with the actual data in our spreadsheet. And now the next step is quite tricky. The end goal is for us to build that band chart which we had previewed at the start of the demo, and those band charts are going to be built as stacked column charts. And as you recall, stacked column charts are built by placing values one on top of the other, that's by adding values together. And so we've got to construct values such that those values, when stacked one on top of the other, are going to give us the low, medium, and high thresholds which you see in cells I3 to K3. Lowest column in our stacked column chart merely needs to take the low value. So we simply set the contents of E3 to be exactly equal to that low value, and that low value is defined in cell I3 and it's equal to 3. Note that when we do this, we use the dollar signs which help to lock cell formulae. This means that this is an absolute cell reference to the cell I3. And when we copy that cell down in a moment, that means that we will get the value 3 in all of the cells E3 to E14. Currently only have the value 3 in the cell E3, but we'll copy that formula down in a moment. Before that, let's perform a similar operation for the medium column, that's column F. And here, once again, we make use of absolute cell references and enter the formula J3 minus I3. Note that both J3 and I3 have made use of dollar signs in order to ensure that these cell references are absolute. Why are we entering this formula in here? Remember how a stacked column chart works? The values in each stack are going to be added one above the other. So what we'd like in cell F3 is a value such that when it's added to the value in cell E3, it gives us the threshold for the medium band, which is 8. Now the value in cell E3 is 3, the value of the threshold is 8, and so in cell F3 we require the value of 5, which is equal to J3 minus I3. Again, note how we are careful to lock the cell references. And when we enter this formula, we can confirm that the cell F3 indeed contains the value 5. Now, in similar fashion, we type out the formula K3 minus J3 into the cell G3, and this in turn gives us a high value of 2. Remember again that we are doing this in order to have our data compatible with the stacked column representation. The low band has an upper threshold of 3. The medium band, which is placed above the low band, has an upper threshold of 8. 3 plus 5 equals 8. And the high band has an upper threshold of 10. 8 plus 2 equals 10. Now that we have all of these values for row 3, we simply just copy them down. Because of our use of the absolute cell references, this copy operation is smooth and we get the same values 3, 5, and 2 in every one of the rows 3 through 14. Next, we've got to add these as series into our chart, and that's what's going to turn our chart from a pure line chart into the band chart. So we right click on the chart, hit select data. In the list of series over on the left, we click on the add button, and then we add the series corresponding to the low, medium, and high data. In each case, the actual data is going to be added to the series values input, and the series name is going to be taken from row 2. So we perform this operation 3 times in succession, and at the end of it all, as we can see from the select data source dialog over on the left, we have now 5 series in our graph. These 5 series correspond to the US and Canada, as well as the low, medium, and high bars. On the right, we still don't have the horizontal category axis labels set correctly. So let's hit edit and let's use the input in order to specify the names of the months. We now hit OK, and our data range now looks fine. We still have a problem though, which is that the series for low, medium, and high still show up as line with markers. We've actually got to change these now to the stacked column representation. That's not hard for us to do. We right click and use the change chart type option in order to go back into the change chart type wizard. At this point, the current chart type shows up as line with markers, but we change that by clicking on combo over in the bottom left. There at the bottom of the screen, we have drop downs which allow us to control the chart type for each series. The initial default choice is clustered column, but we change that so we turn both the US and Canada back to line with markers. And then once that's done, we scroll down and change the line types to low, medium, and high to be stacked column charts. And this is a really important step. We need those stacked column charts for the bands, and that's how we are going to get our band chart. We do this 3 times in a row, and we can see already in the preview that we have our nice band chart. There's still a bit of a problem though, which is that the band in the background does not extend all the way through. That can be changed as well. Just got to ensure that the gap width for the low, medium, and high stacked columns is basically equal to 0. So we first select the low series by clicking on the gray markers at the bottom, right click and use format data series in order to set the gap width to 0. You can see this in the gap width slider over on the right. We've moved the slider to its extreme left position and gotten the gap width to be equal to 0%. As soon as we do this, we can see that we have the band chart that we had set out to build. Because there's no gap at all between the stacked bars for the low series, the same gap width has been applied to the high and the medium series as well. We can now go ahead and customize other aspects of this chart's appearance, but our job is basically done. We have successfully implemented band charts in Excel. Band charts are a great way of telling how a particular series is doing against levels which we are comfortable with. Band charts are also known as interval charts or range charts, and they are an interesting technique for monitoring performance in a business context. In this demo, we are going to talk about scatter plots. A scatter plot is a great construct for visualizing or identifying relationships between variables. Scatter plots are often a precursor to other modeling techniques such as linear or logistic regression. Let's go ahead and get started. We can see that we have a data set which has attributes of diamonds. The columns here are the carat, the cut, color, clarity, depth, and price. We are going to use scatter plots in order to visualize the relationships between the price and depth, as well as between the price and the weight in carats. 1 carat is equal to 0.2 grams, or in other words, 5 carats make up 1 gram, and carats are used typically as the unit of weight while evaluating how heavy a diamond is. Let's go ahead and get started. We select all of the data in columns A through F and then click on the Insert button up top. We navigate to the section containing all of the charts towards the top center, and there you can see there's a graph which has just points without any connecting lines, and that little icon corresponds to a scatter plot. The menu which opens up shows 5 different types of scatter plots, but the first is by far the most common. This merely plots numerical values on a pair of axes, and that gives us a way, by looking at just the raw dots without any connecting lines, to see what kind of connecting line might make the most sense. And this is why a scatter plot is a valuable tool in exploratory data analysis. It helps you determine what kind of model you can use in order to fit a relationship between two variables. In any case, let's move on. We choose that type and our first scatter plot appears on screen. We can see that this has price on the y-axis and it has the depth over on the x-axis, but we need to control the exact variables with more precision. So let's go ahead and click on the select data button over on the top right. When you select a range which has multiple columns and the last of those columns is numeric, if you then try and insert a chart, Excel is going to interpret only the last column, that's the rightmost one, as the numeric data series to be plotted, and it's going to compute a concatenated version of all of the other columns and treat them as the axis labels. This is what's currently being done. You can see that on the left we have one series which is the price, that's the rightmost column, that's column F, And then on the right of this dialog, we have all of the horizontal category axis labels. Those are merely concatenated versions of the columns A through E. Because a scatter plot requires two dimensions, the second rightmost column has been taken as the x-axis. In any case, let's get rid of this series. We select the price series and use the remove button. Then we click on the add button, and this allows us to redefine the series we wish to plot. The series name is entered by hand and it reads carat versus price. And then notice that because this is a scatter plot, we've got to specify both series X values and series Y values. The series X values are going to be taken from column A. So we are going to have the weight of the diamond in carats taken as the X axis. And then we have the price that's in column F as the Y axis. A quick word on the naming convention of graphs. You can see that in this particular instance, we have named our graph following the X versus Y convention. X is the weight in carats, Y is the price, and we've named this graph carat versus price. In reality, a slightly more common naming convention is the Y versus X convention, but both forms are perfectly fine as long as you make it explicit which convention you're following. In any case, we hit OK and return to the select data source dialog. There, we are going to add in a second series. So we click again on the add button over on the top left. And we are now going to compute another scatter plot. This one is going to be price versus carat. So we are going to interchange the X and the Y axes. This time we have X-axis values taken from column F, that's the price, and the Y-axis values taken from column A, that's the weight in carats. So we hit OK and come back to the select data source dialog. Notice in the left now that we have two series, carat versus price and price versus carat. We are going to turn off the price versus carat graph for now, but we will come back to it in a bit. For now, however, it's important for you to keep in mind that these two series are not the same. A scatter plot can be thought of as the precursor to a linear regression. And if you work with linear regression, you will be aware that the regression of y on x is not the same line as the result of a regression of x on y. These are two different operations, and this is also true with scatter plots. Interchanging the x and the y axes gives us different scatter plots. To be precise, the results are going to be rotated by 90 degrees. In any case, let's keep going and add a third series to our scatter plot. So we click on that add button on the top left yet again. And this time the series we define is called price versus depth. As its name would suggest, we have price on the x-axis and depth on the y-axis. So the x-axis values are taken from column F and the y-axis values from column E. At this point, we have three series in our chart, but we only enable one of them. So we've unchecked the check boxes next to price versus carat and price versus depth. Now when we hit OK, a simple scatter plot is displayed in our workbook. And this scatter plot has just one pair of points. These points contain the carat information on the x-axis and the price information on the y-axis. We can tell by looking at this graph that there is clearly an upward sloping or positive relationship between these two variables. As the carat weight tends to increase, the price tends to increase as well. Of course, there are also other factors, and we can see that very clearly by looking at all of the diamonds where the weight in carats is equal to 1.5. We can see that there is a wide range in their prices. The cheapest of those diamonds has a price which is less than $6,000, while the most expensive diamond in our dataset, which also has a weight of only 1.5 carats, has a price just above $18,000. Despite this one aberration, on average, however, there is a clear upward trend. So as one variable increases, the other tends to increase linearly as well. This would suggest that it would be a good idea to try and predict the price by using the weight in carats as one of the predictors in a linear regression model. However, we can also see that because of the presence of those outliers like that most expensive diamond, that we probably should consider adding other variables such as the cut, which is contained in column B. In any case, we now have our scatter plot and we can now format the axis and the chart area in all of the manners which we have employed so far. In the interest of time, I'll skip over a detailed discussion of these customizations, but there's nothing particularly new here. And try out all of these customizations on your own. Let's pick up the action again with a change in the chart type. We've clicked on the insert menu item and we've expanded the set of scatter charts. Now on screen you can see that there are 5 different types of scatter charts supported in Excel. We've already commented on how the first of these is the most commonly used. Let's quickly cycle through the others. So we move our mouse so that it's over the second chart type. We can see that we have a tooltip telling us that this one is called a scatter with smooth lines and markers. That tooltip also informs us that this chart type ought to be used when there are few data points and when the data represents a set of XY pairs based on a formula. Now, our X and Y values are not taken from a formula, these are real world readings, and that's why the chart in the background looks like that unruly squiggle. A scatter plot with real world data is most useful when you're trying to identify what kind of model to fit, and adding these smooth lines usually does not help with that objective, and that's why this is not a very popular type of chart. Let's move our mouse one position to the right. This is a scatter with smooth lines, so we don't have the line markers anymore. But in other ways, this chart has the same weaknesses, and we can tell from the curve in the background that it's still quite a scribble. Before we explore the last two types, let's take a moment to move the chart out of the way, and then let's come back to the fourth type of scatter plot. This is a scatter with straight lines and markers. Here, the lines connecting the points are all piecewise linear, so every individual segment is a straight line. Again, it doesn't help a whole lot. We can see from the use cases that this is recommended when there are many data points and when the data represents separate measurements. Once again, the curve over on the right is not very confidence inspiring. Let's try out the last variant. This is a scatter with straight lines. The only difference is that we no longer have the line markers. For our particular use case, it's pretty clear that the first and simplest type of scatter plot suits us best. In any case, it was good for us to get a sense of these other options available. Let's exit out of that menu and go back to the chart design menu. So we click on the chart design menu item on the top right. We then navigate to the select data source option. Remember that we had defined 3 series in our scatter plot but only enabled one of them, and that's the one that's currently enabled, carat versus price. We are now going to disable this series and enable the other 2 series. So we are going to construct a scatter plot which visualizes not one but 2 relationships. We make those changes to the checkboxes and hit OK, and the scatter plot which we see has a pretty weird appearance. The orange points lower down represent the relationship between price and carat. The gray points up top represent the relationship between price and depth. How do we know that? Well, if we look at the y-axis, we can see that the orange points all have y-axis values which are close to 0. And we can see that the weights in carat, which are in column A, are also relatively close to 0. All of the gray points up top have y-axis values which are around 60, and we can see from the depth that that's also the approximate range of the depth of our diamonds. This observation gives us a hint about how we can fix the issues with this graph. We just need to represent these 2 series on different axes. So we choose one of the series, right click and use the format data series option. And then in the dialog which opens up on the right, we change the plot series option from primary axis to secondary axis. And as soon as we make this change, the scatter plot looks a lot more normal. There are still some rough edges to the scatter plot. We still have to change the units on the y-axis, but all of those operations are simple enough. We have thus successfully demonstrated the creation of scatter plots, and we've also seen how different types of scatter plots are supported in Excel. And we rounded out this demo by visualizing not one but 2 pairs of relationships on the same scatter plot. In this demo, we are going to construct something known as a waffle chart. A waffle chart is also sometimes known as a KPI chart. Here on screen now is a quick preview. This waffle chart includes a 10 by 10 grid. You can see that the grid occupies the cell positions from H2 through Q11. That gives us 100 numbers, and those 100 numbers start from 1%. You can see 1% in the lower left corner. That's the cell H11. Then every subsequent value towards the right increases by 1%. So we have 1, 2, 3, and so on until we have 10% over in cell Q11. A similar pattern is followed in row 10 and all of the other rows until over on cell Q2 we have the value of 100%. So this 10 by 10 grid represents what percentage of a particular task has been completed. This is one essential aspect of the waffle chart. The other essential aspect is the number in cell F13. That number currently reads 10. We can change the value of that number using the spin buttons right next to it. You can see now, for instance, that we've used the spin button, clicked on the down button, that caused the value to change to 9. And now if we pay close attention to that square grid, we can now see that only 96% of our task has been marked as complete. The cells N2 through Q2, which contain the percent numbers 97 through 100, are now grayed out. Why 96% specifically? Well, look closely at the number in cell E13, that's 96.99, and that number in turn is taken from the cell F10. This column, column F, contains the completion percentages referred to by the various tasks, which are defined in rows 2 through 11. We've encountered this data in a previous demo. So we are slowly piecing together how this waffle chart works. In cell F13, we have the number of tasks or the number of steps that have been completed. We can control that using the spin buttons. As we alter the spin buttons, the percentage completion from column F is picked up and placed in cell E13, and then the proportion of the 10 by 10 grid, which is less than the number in cell E13, is going to be marked as complete. Right now, for instance, we've said that 4 tasks are complete, and the fourth task has a completion percentage of 51.13. We can see those values both in cell F5 and then down below in cell E13. And that's why in our waffle chart, that's a 10 by 10 grid, we have only the squares up to and including 51% marked as complete, as shown by the dark green shading. Now that we understand how the waffle chart works, it's actually relatively easy for us to go ahead and implement it. Let's see how this is done. We start with the same raw data we had in the Gantt chart example. We have columns corresponding to the task start date, end date, and duration. And then in column F, we have the percentage of completion represented by each task. You can see that the contents of column F increase steadily, and they start from 7.52% and go on up to 100%. So the first step, which is gathering requirements, constitutes 7.52% of the total task. The second task, which is UI design, comes after gathering requirements. When we finish UI design, we will have finished 19.55% of the entire task. And in a cumulative manner, we keep increasing the percentage of the task completed until finally, when we release our version, that's on row 11, that means that we have accomplished 100% of our task. Next, let's set up the numbers in our grid. We just format these rows and columns so that all of those cells H2 through Q11 have the same height and width. This gives the grid a nice square appearance. Please note that 10 by 10 grid is completely independent in terms of its horizontal placement of the raw data. We just happen to place those values representing the 1% to 100% completion levels in the same horizontal lines. There's no necessity for this to be the case. Next, we are going to insert the spin buttons. For this, we click on the developer menu item up top, and then in the list of controls, which appears towards the center of the screen, we click on insert, and from the list of form controls, we click on that little spin button control. This causes the spin button to be added to our Excel worksheet. We can resize it to get the size and exact appearance that we have in mind. Then we right click on this form control and choose the format control option. This in turn allows us to specify the current value, the minimum and maximum values, the incremental change, and then most importantly, the cell link. We've set the current value to 1, the minimum value is 1 as well, the max value is 10. Each time a spin button is clicked, we'd like the change to be 1 in either direction, and then we wire up this control to be linked to the cell F13. We do this by clicking on the little arrow button over at the extreme right of that link cell input, and then clicking on the cell that we have in mind, which is the cell F13. We can now go back and hit OK, and our link to the spinner has been put in place. Note the contents of cell F13 are set to 1. Excel did this because the initial value of our control was 1, and we've linked the control to this cell F13. Now we've got to wire up the percentage of completion in cell E13, and the way we are going to do this is using the index function. On screen now, you can see the tooltip for the index function. There are two versions. The first of these takes in an array. Here we've specified the array F2 through F11, and the second takes an index into that array. Here the index into the array is taken from cell F13, and the index function is going to return the value in the array at that particular location. In our example, for instance, in cell F13, we now have the value 2, and that's why in cell E13, we have the second value from the list F2 through F13. That second value, which is in the cell F3, is 19.55. If we tweak the value in F13 using the spin buttons, we find that the value of E13 updates in real time as well. Let's quickly change the formatting of cell E13 so that it's in percentage form, just makes things a little clearer. And now we turn to the most important aspect, which is wiring up the waffle grid with that control. To do this, we select all of the numbers in the waffle grid. These are the cell locations H2 through Q11. And we then click on the conditional formatting button up top. We are going to add a conditional formatting rule to set up our waffle chart. So we click on the manage rules button at the very bottom. This brings up the conditional formatting rules manager. You can see up top that this is showing formatting rules for the current selection. That current selection, of course, is the waffle grid, the 10 by 10 grid with the percentage completion numbers from 1% to 100%. Let's click on the new rule button, and then let's move this dialog out of the way so that we can clearly see the link between the waffle grid and the percentage of completion. Up top in the new formatting rule dialog, we have the rule type. We're going to click on the second entry here, which says format only cells that contain. When we select this option, we can see that the lower part of that new formatting rule dialog changes, and we can now specify which cells are going to be governed by this rule. And notice that the rule is of the form format only cells with cell value between, then H11 and E13. This is maybe the most important part of this whole demo. H11 is hard coded to contain the number 1%. E13 corresponds to the percent of completion, which is defined using the index method and linked up to the spin button. So this conditional formatting rule is going to take every cell value that lies between 1% and the currently completed percent and apply a format. This is the heart of the creation of the waffle chart. All that's left for us to do now is to click on that little format button towards the bottom and actually specify the format which we would like in our waffle chart. This is fairly easy to do. We just use the controls and add in that dark green background and set the font color to white. This is going to be the format for all of the completed cells. So back in the rules manager, we hit apply, and that's going to apply this rule to the current selection. We can see that up top. Next, we'll quickly define a second rule. We'll do this by clicking on the new rule button on the top left. This is going to be the rule which will apply to all values which are not between H1 and the percentage of completion. So we pick the second rule type, we specify the relational operator not between in the format cells rule definition down below, and then we again pass in the same two cells H11 and E13. No change here. The only difference lies in the fact that the relational operator is now not between instead of between. We now need to define the format for these cells, and we do this in a similar fashion. We specify a fill color which is a light green shade with the same font color. So these two rules have now been applied to all of the cells in the selection. We can close out of the conditional formatting rules manager, and our waffle grid is complete. We can see that the initial value of the completion, that's cell F13, is set to 1. The percentage of completion that corresponds to is 7.52. And in the waffle grid, we can see that all of the squares which are at or less than 7% have been shaded in the dark green. We can also experiment with different values of the spinner, and we can confirm that our waffle grid does indeed work satisfactorily. Waffle charts, also known as KPI charts, are a handy tool in project management, and in this demo we've seen how to successfully implement them. Come to the end of this course building box plots, sunburst plots, Gantt charts, and more. We started this course by creating a box and whisker plot and understanding its elements in great detail. We saw how such plots convey a wealth of information about the statistical distribution of a variable in a compact form. This information includes the mean, median, 25th percentile, and 75th percentile. In addition, as we learned, box and whisker plots are great for identifying outliers in a data series. We then moved on to the use of sunburst charts, which are great for visualizing hierarchical data. In particular, sunburst charts are great for data with differing levels of detail available. For instance, with time series data where some but not all years are broken up into quarters, or some but not all quarters are broken up into months. Sunburst charts score over Treemaps and pie or donut charts for such use cases. We then moved on to waterfall charts and Gantt charts. Waterfall charts show the cumulative effect of positive and negative values to illustrate how we went from an initial value to a final value. We learned that waterfall charts consist of an initial bar followed by a series of positive and negative bars such that each bar starts where the previous bar ends, thus forming a waterfall from the initial to the final bar representing the total value. We also work with Gantt charts, which are a powerful tool in project management and help illustrate progress towards a goal involving multiple parallel tasks. We noted that Excel does not contain any direct support for Gantt charts, but we were able to create Gantt charts from stacked bar charts using an ingenious implementation. Next came band charts and scatter plots. We learned that band charts can be used to quickly eyeball the trend in a line chart, and that scatter plots are very useful for identifying and understanding the relationship between two variables. Scatter plots in particular have gained popularity as a part of exploratory data analysis or EDA, which helps a data analyst decide what type of model best captures the relationship between a pair of data series. We rounded out the course by constructing a Waffle chart, also known as a KPI chart. KPI is an acronym for Key Performance Indicator, and Waffle charts visualize progress on such an indicator by visualizing the percentage completed towards a goal. Waffle charts like Gantt charts are not built-in Excel chart types, so we saw to build waffle charts manually using a nifty system that included a grid of percentages, suitable conditional formatting rules, and a spin button. You now have a good grasp of how advanced visualization types such as box plots, sunburst charts, Gantt charts, and waterfall charts can be used in Excel and are ready to move to the use of business intelligence tools in the courses coming up ahead. That's it from me here today. Thank you for watching.
In this video, we'll see how to integrate AI tooling into an Excel workflow using MS Copilot. We'll cover natural language commands, pattern detection and data cleaning recommendations, data visualizations, and advanced formulas. One of Copilot's most impactful capabilities is enabling analysts to use natural language to execute data analysis and visualization tasks. In other words, we can type data cleaning or other requests into the Copilot chat in a conversational manner, and Copilot will execute the tasks using behind-the-scenes Excel functions and menu operations. Let's see how this works by starting with a simple data cleaning task, changing the format of our date column. We'll open Copilot and paste the prompt into the chat box. Change the date format from mm/dd/yyyy to yyyy/mm/dd. As we can see, Copilot will take a few seconds to execute this command. Then we preview the results and have the option to apply it to our sheet. If all looks good, we apply it and have easily executed this data cleaning task. Next up, let's see how to accomplish a column split, another common data cleaning task. In this dataset, we have one column with both first and last names. Instead of using the text-to-column splitter with a space as our delimiter, we can ask Copilot to handle these actions and split the column for us. Split the customer column into first name and last name. Handle discrepancies with the word unknown. Here, we've also included instructions for how Copilot should approach cases that don't exactly fit our setup. Even without prompting, Copilot will handle edge cases and let you know what it has done, but establishing your own method of organization helps to adhere to your existing practices for data analysis and avoid introducing distracting or disruptive syntax into your workflow. This is particularly important if you work on a team that has pre-existing standards and norms. Beyond specifying data cleaning tasks, we can also ask Copilot to suggest cleaning or analysis recommendations. For example, Copilot might recognize multiple data types within a single column and recommend that the column be separated. Or it might recommend pivoting data from wide to long format for better analysis or visualization. Please suggest data cleaning tasks for this dataset. Is it ready for visualizations? The dataset is mostly ready for visualizations, but a few data cleaning tasks are recommended. 1. There are some missing values in the customer name column. These should be filled with unknown, or the rows should be removed. 2. The unit price column is stored as text, so it should be converted to a number for proper analysis. 3. It's a good idea to check for duplicate rows and remove them to ensure the results are not skewed. Copilot identifies missing values in the customer name column and a data type issue in the unit price column. Additionally, it suggests that we review negative or zero values that might indicate data entry errors, and it suggests standard data cleaning tasks of deleting duplicate rows and handling missing data. Another way we can use Copilot is as an exploratory data analysis tool. Simply asking what patterns it can find is a good entry point to understanding our dataset. What patterns do you find in the data? Eventually, Copilot parses through the data and runs some basic analytics. There are several interesting patterns in the data. Some customers, like John Smith and Maria Garcia, appear frequently, suggesting they are key buyers. Laptops and smartphones are among the most popular products, indicating high demand for these items. The East and North regions have a large number of sales, which may point to regional preferences or market opportunities. There are clear monthly sales trends, with some months showing higher total sales than others. Copilot can tell us which products sell the most, which customers are top buyers, and which regions have the highest sales. Next up, we'll make some data visualizations. First, let's see what happens if we had not done any data cleaning or validation prior to visualization. Please create a pivot table that shows total sales by region. Then insert a column chart to visualize the results. Here we see why it's necessary to verify Copilot results and always keep an eye out for errors. A quick inspection of the visualization reveals that there's a surprise fifth category, South, likely a misspelling of South in the region column. After inspecting the pivot table and the data manually, we can verify that the solution is indeed to merge the SUT data with the South data. Please update any instances of South in the region column to South. Tell me how many instances there were. Then remake the graph. Now the graph has only 4 regions, as expected, and the total for South is slightly higher with the data properly aggregated. Additionally, Copilot returned a report on how many changes it made to the data. There were 241 instances of South in the region column, and all have been updated to South. The column chart now accurately shows total sales by region with the corrected data. This ensures your visualizations reflect the true distribution of sales across all regions. Let's make one more visualization that shows the breakdown by both region and product. Make a stacked column chart where each column is a region and each piece of the column is a product. This isn't what we asked for. We want the region and product categories flipped. Let's keep prompting to get the graph we wanted. We'll make the prompt more specific and explicitly state where to put variables. Swap the region and product fields so that x-axis displays the 4 regions, and each stacked column represents the product-wise breakdown within those regions. That's better. Now we have a visualization that clearly shows which regions sell the most and which products sell the most. It's easy to compare these two variables, and this graph is now a tool that can inform future business strategy. Finally, One of the most helpful things Copilot can do is properly populate complex or nested formulas and add new analysis columns to our dataset. Show a table listing each day of the week along with its total sales amount, so I can see which day had the highest sales overall. Copilot returns a written explanation of how the answer is computed, and it's always a good idea to look this over. You can even select the drop-down to show how the analysis is done behind the scenes using Python code. To determine which day of the week had the highest sales, the date column will be used to extract the weekday for each sale. The total sales amount will then be summed for each weekday, and the day with the highest total will be identified. This will provide a clear answer to your question. We also get a table with the results. Saturday had the highest total sales for the month, with 178,550 in sales. This means more sales happened on Saturdays than any other day of the week. We could add that weekday column to our sheet if we wanted. We can also easily add the table to our sheet for a nicely formatted table that's ready to share.